introducing our very first speaker.
What it's going to take to get
thank
there.
you all for being here. We appreciate
Today's
it.
theme is thriving in space. And our first speaker, Emma, are you on? Are you ready? Inspire conversations about space, the co-host, so that's a yes.
Introducing our very first speaker.
What it's going to take to get
thank
there.
you all for.
Hi there. Now I can unmute. I'm sorry that it was not allowing me to do that previously.
Okay, great.
Morning.
How are you?
Thank you.
All right. Well, Emma Learnhardt, did I pronounce that correctly?
Lanehart.
Lanehart. Emma Lanehart is the program planning and control manager for NASA's Gateway program, which will be a critical Artemis way station and outpost in orbit around the moon. In this role, Emma leads the team responsible for all the business operations of the Gateway program, including budget, acquisition, strategy, and contracts management, schedules, cost estimating, information technology, and external engagement. Sounds like just about everything. Previously, she worked at NASA headquarters, the White House's Office of Management and Budget, the Space Policy Institute, and consulted for government agencies and aerospace companies. Emma, welcome. The screen is yours.
Thank you. All righty. So good morning, everyone. Thank you very much for having me. What a great series of conversations around the infrastructure and really what it takes to move humanity into space and into the future. Right? I was asked, hey, it's cold here, love Gateway, thanks Terry. I can see the chat before I pull up my screens here. I'm in Houston, Texas. It is not cold here, but we're looking at what should be for July in Houston, a really, really nice day. So getting my input there on the temperature and weather updates across the team here. So I'll chit chat just a little bit with y'all this morning about the NASA Artemis program and my piece of it that I work on, the Gateway program. I just have a few slides, mostly pictures, to talk through today, and then hopefully we'll leave plenty of time for any Q&A. Would love to have plenty of time for a dialogue with this community. With that, let me start sharing my screen. Please do bear with me. The US government still does not really use Zoom. So even after all this time in the pandemic, a little bit of a Zoom newbie. All right, could I get a check that everybody could see my screen?
Yep, yes, we're good, Emma.
Okay, great, thank you. All right. So Artemis, really quickly, what is Artemis and how does Gateway fit in? Artemis is our overarching construct at NASA for how we discuss and organize our return to the moon. And when we say return to the moon, we're not just talking about landing the first woman and the first person of color on the surface of the moon, but also the cislunar space in orbit around the moon and all of the infrastructure and logistics resupply necessary for that. Artemis, speaking as a let's say longtime NASA person now, I think I can say that, is a united effort across NASA. It is not just one mission directorate, which is one of our main organizational components in the agency. It is cross-cutting across multiple mission directorates, not only human exploration and operations, but space technology and also our science mission directorate. Really a unifying effort across NASA. And Gateway is a key critical element of it. Gateway fits in here with multiple pieces, as I mentioned, across Artemis to include the big rocket that we need, the Space Launch System, and the crew capsule, the Orion spacecraft, landing commercial payloads on the surface of the moon through the Science Mission Directorate's CLIPS program, Commercial Lunar Payload Services. We need surface suits, surface capabilities, surface tools, which will lead up to an Artemis base camp. And in orbit around the moon, we will have the Gateway space station. So we think of the Gateway, this is a graphical depiction of the full configuration as our first outpost in a sustained lunar orbit. It is a special orbit, NRHO, near rectilinear halo orbit, which will allow us to see and send crew down to the surface, lots of different places on the surface of the moon. If we think back to the Apollo program, really all of the lunar landings in Apollo were around the equatorial region of the moon. I'm hoping that as part of this conversation series, you guys have talked about the interest on the lunar South Pole for possible resource utilization, the craters at the South Pole having water ice. So Gateway will allow us access to all interesting areas on the surface of the moon and provide a look back to the Earth, direct communication at all times. Off to the side here, I can't see it on my screen, but I hope you guys can too. One of the great things about Gateway is this is a commercial and an international partnership. We are building the integrated spacecraft with multiple commercial partners. I'll touch on a few of them and our status there, as well as our international partners from Canada, the European Space Agency, and Japan with JAXA. It is really the next step beyond the partnership of the International Space Station program, and we are really just beside ourselves to carry that legacy forward into deep space. The infrastructure and the capabilities that Gateway provides, we are going to be building this up incrementally over time. And I think on my next slide, I'll show you what the first two pieces, which we will launch together, look like. And then this full configuration will be built up, autonomously docked over multiple years. As we build up the capabilities of the space station, we will allow for extended mission directions. The crew can stay for longer. I think this really gets to the meat of this conversation today about what it means to truly thrive in space, needing to really be able to be there in the deep space environment for a while with astronauts, with crew members, to conduct relevant research and science and technology demonstrations, and make sure that they have the logistics to survive and thrive in that environment, with enough air, water, everything that comes along with that. We will be flying payloads, scientific payloads on the Gateway, both on the outside of the space station as well as inside. And really, I want to hammer that this is truly an international partnership, and we work hand in hand with our partners on a daily basis. They are involved in every forum that we have to manage the program, all of our control boards, which is our key gates for decision making internal to the program. And really looking forward to being able to travel again and be able to see our international partners in person. That is going to be very nice post-pandemic. I mentioned the first two pieces of the Gateway. We call this our initial capability. It is made up of the power and propulsion element. I'll use my cursor here. This is Vanna White. And back here, this is the power and propulsion element with, you can see some solar arrays coming up at the top, at the bottom. Attached to it is the cylinder here, the habitation and logistics outpost. The power and propulsion element is being built and delivered by Maxar Technologies. And the habitation and logistics outpost, HALO, is being built by Northrop Grumman. The power and propulsion element contract we have had in place with Maxar for a couple of years now. HALO, we have been engaging with Northrop Grumman for a little over a year, but on Friday we had a big piece of news for our program, which was the finalization of the last major phase of the contract with Northrop for HALO. We call that the phase 5 firm fixed price contract, and that is in place and final. Really ready to go here and deliver that, that spacecraft, as well as integrate it with the power and propulsion element of PPE. These two pieces will be integrated on the ground, and they'll be launched together on a single launch vehicle. It will be a Falcon Heavy, and we are targeting a launch of these first two pieces in November of 2024. All together, this is an expanded view of the spacecraft when we're at something like a final configuration or a sustained configuration, and it gives you a snapshot of all the pieces and who is providing them. So we are working with SpaceX, not only for the delivery of the PPE and Halo, but also for our logistics resupply with Maxar and Northrop. And then you can see the international components being provided by ESA with their International Habitat, or IHAB, as well as contributions from JAXA. They're a refueler called the Esprit refueler module, which is depicted here, and Canada with the external robotics system. Much more than just Canadarm3. This also includes all of the components on the outside of the spacecraft that's going to allow this really advanced robotic arm to literally walk itself around the outside of the spacecraft to conduct research, to move payloads around, and maintenance. It's incredibly cool. One of the key features and critical elements of Gateway as infrastructure is the opportunity for expansion in the future. And we do that through an internationally agreed to set of standards for docking mechanisms. And every time on a graphic like this, you see these little circles. Those are all docking mechanisms that will allow for future expansion of the Gateway, or for visiting vehicles like logistics resupply to come to Gateway and then leave again, or for the Orion crew capsule to come and bring astronauts up to the Gateway to stay in that deep space environment. Let's not restart now. The last, honestly, 2 years have been tremendously busy, but the last 6 months in particular on the Gateway program have been tremendous. I think in the introduction, Layla described my job as just about everything. You'll notice there was no mention of technical expertise in that description. That is correct. I am not a rocket scientist. I am not a systems engineer. Sometimes it's a little bit difficult to really describe what my job is. I typically say that I'm both the CFO and COO, Chief Operating Officer of the program, a little bit of Chief of Staff duties in there as well. But it's funny, Layla, that you use those words, because sometimes the easiest way to say what I and my organization do is just about everything other than systems engineering and the technical. So for us, looking at this list of accomplishments, with contracts being awarded, with life cycle reviews being completed, passed with no actions, key decision points at the agency being made, and getting official NASA approval to continue with what we are doing, has been within my shop, and just really a tremendous list of accomplishments over the last 6 months. I cannot take credit for any of the international partner engagements or status there. We have an international partner manager who worked his bum off to get our memoranda of understanding signed late last year with ESA, JAXA, and with the Canadian Space Agency. I would be remiss if I left this conversation with just PowerPoint slides and artist depictions of the integrated spacecraft. Not only are we making our way through NASA decision gates, getting procurements in place, all those critical things, but we are building and making progress right now, particularly on Halo and the PPE. These are just a couple of pictures. The primary structure of Halo is being assembled right now in Italy, Italia Salenia Space, And we have every week been getting pictures of deliveries of the component of the PPE. You can see a snippet of what the rollout solar array will look like on the PPE, and the boom, which is very, very long, that will provide the structure for the solar array to roll out and deploy once PPE and Halo launch together. So we are rocking and rolling. This is a really, really exciting time to be a part of Gateway, and I'm pretty sure that is all I had for you, except to leave you with a couple of ways to connect and follow along with the story, with the NASA Artemis social media accounts, blogs, and I'll point out that we have a brand new public-facing website, nasa.gov/gateway, which will collect all of the specific Gateway-related information in addition to the Artemis resources that you can see here. That was a little quick, but I did want to leave plenty of time for questions and discussion. So I think I will stop sharing my screen there, and I look forward to any questions.
Good morning, Emma.
Hey, Michael.
How are you?
I'm good, thanks. How are you?
Good, good, good. Always good to see you.
Good to see you too.
So you actually answered one of my kind of immediate questions. Can you go a little bit further into what your job is? Because there's a lot of people, I think, that kind of misunderstand that.
Sure, yeah. My title is technically Program Planning and Control Manager, PP&C. PP&C is a specific discipline within NASA that basically provides all of the information, data, recommendations, and support to my bosses, the program manager and the deputy program manager of Gateway, to make sure that they have the controls in place and that they have enough information to make informed decisions about the management of resources. Resources, in this case, I am specifically talking about people, so our staffing requirements, and dollars. Obviously, we are a NASA program. We are funded by taxpayer dollars. This comes along with an incredible requirement for control and accountability. I take that part of my job extremely seriously. It is the most important part of my job to make sure taxpayer dollars are being expended correctly and efficiently, and accomplishing things that we want to as a nation, as a space agency. But there's a lot of other stuff in my job, if you'll allow me to expand, Michael. For Gateway, we are a really, really small and lean management team.
That was my next question. What does that look like?
Right. So I have all those other functions that were listed included in my organization, such as information technology. What does that mean? That means everything from providing our government issued laptops to the team to cybersecurity requirements. So we have one person who works directly for me, and that is her entire portfolio. In other programs, that might be a little bit larger with a larger support team, but we're pretty lean.
Cool. Amazing.
Yeah. Thank you.
So I've gone on record a couple of years ago, prior to Gateway, saying that the International Space Station is the epitome of human capabilities, right? It is the hardest machine to operate that humans have ever built. And I know that some of the folks at the Large Hadron Collider disagree with me, but I think the ISS is the epitome of human achievement so far. There's going to be a day when ISS doesn't operate. Sad day for humanity, but you know, Gateway's coming along. So Gateway has a brand new system. It's completely redesigned. It's not 20 years old. So which is going to be the epitome of human achievement? Is ISS still going to keep the crown, or is a smaller, more tech-savvy Gateway going to take the crown? I actually can't tell from the outside, so I'm curious. Where do you stand on that?
I'm going to give you my personal and honest answer.
Yeah.
International Space Station, crowning achievement of humanity, as you say. built, assembled during very challenging times across our globe with international partners that held together despite all odds. Permanently crewed for 20 years now. When I think of Gateway, we are leveraging all of the experience and honestly, Michael, some of the technologies from ISS to keep it simple, to keep it affordable. Gateway, we're an infrastructure project and we are the launching pad for what comes next. So I think Gateway will have a very critical part to play in lunar surface exploration and the Artemis Base Camp buildup, but also as the place where we can develop and test the technologies, procedures, capabilities necessary for a future human mission to Mars or somewhere else in deep space. So I think we are going to be the enabler of everything that comes next, but I am not sure if we would be cooler than the International Space Station. I got to be honest.
I mean, ISS is a pretty amazing machine. So, yeah. Okay, all right. So fingers crossed about the future of Gateway, because it can be expanded, right? So we know what it is today. 20 years from now, it might be a very different machine. But okay, I wasn't really sure. I mean, just it's hard to gauge scope and intention.
Yes.
And we've got 20 years of evidence that ISS is pretty awesome. There's a question from the audience. I'm pretty sure I know the answer, but I want to make sure that we ask it. Hi, Emma. This is from ArcSay. Hi, Emma. Do you have any platforms for new startups to participate in these projects? New startups without experience and guidance from experienced players and some program or platform to enter the industry.
Absolutely. So the first two things that come to mind, I mentioned very briefly something like CLPS, Commercial Lunar Payload Landing Program, that is managed by the Science Mission Directorate. We are trying at NASA to specifically open up barriers to entry through programs like that. But for smaller entrepreneurs, for very new startups, I would point you to something like the SBIR-STTR program within NASA, which is actually a federal program. Other agencies like Air Force, Navy provide funding for these projects. So SBIR is the Small Business Innovation Research Program, and STTR is about technology transfer. Every year, we provide really a significant amount of funding and requests for what the agency needs in the future through those programs. That would be a really great place to look.
Cool. Thank you. So, we only have 2 minutes, so I need a short answer on this, but I didn't catch the news on Friday. So can you give me can you give us a little bit more info on that? Because I missed it, so it's new to me.
Yeah, we were hoping to get that press release out not on a Friday, but, so it goes with approvals. So and there was plenty going on in our space world last week, right? Getting ready for the Virgin Galactic launch on Sunday, which was just so tremendously exciting. So the news on Friday was the finalization of our contract for Halo with Northrop Grumman to include the final DDT&E, the final design, test and evaluation of that module and the integration of that module with the power and propulsion element. So it is a $935 million contract.
So $1 billion just kind of flew under the radar. Sorry, I really should have been paying attention to that one, but I did miss it. I'll go make sure that I look it up. Emma, it's always terrific seeing you. Love chatting with you. Thanks a lot very much, and we'll talk again. We'll talk again soon. I'm going to turn it over to Lila and Lee. I appreciate you being able to work out your schedule. You've got a lot on your plate right now. Thanks a lot.
I do. Okay, thank you very much. Thank you all for the questions.
Bye-bye.
Bye.
You're muted. Okay, I will tap dance for a moment while we figure out how to get Lila unmuted. Good morning, everybody. I don't have any control over this. Leo? Whoops.
Good morning. I can introduce Michelle.
Okay, great.
Go back to that spot on the agenda. All right. So Dr. Michelle Perchinock is retired from NASA Johnson Space Center, where she managed the food science research to enable humans to travel to and live on Mars. Michelle was previously the HRP Advanced Food Technology Project Manager and the Shuttle Food System Manager, where she was responsible for space food product development, menu definition, nutrition, processing, packaging, and research integration. She has a PhD in food science from Cornell University and a BS in chemistry from Brown University. Michelle also served as president of the Institute of Food Technologists. Michelle, thank you for being here.
Thank you for inviting me. So I'm going to try to share my screen. I don't do this part often enough. I do a lot of Zoom, but I'm going to try to do this. And let's see, I want to do desktop 1, share, and then I'm going to start my slideshow.
Looks great.
Well, let's see if we can do this slideshow. Whoops, wrong one. Because I want to do it the other way. Oh, I think I can. What is it? Somewhere I can use swap displays. All right, how does that look?
That
Now
looks like it should.
Okay, so let me go back to the front. So again, thank you for inviting me. I love this topic to talk about, and I don't get to talk about it as often now that I'm retired. I'm gonna give some history and then sort of move to the Mars mission. But as our previous speaker spoke, the moon can be sort of a testing spot for some of this. So as we'll hear, Mars is a long, long way away, and as everyone knows that, and it's not necessarily efficient or effective to test new systems directly on Mars. So doing some of this testing and understanding on the moon will help a lot, though, because the moon has less gravity than Mars, it's not going to be quite the same. So this is probably a pretty old graphic, but again, what I want to emphasize here is right now we're going on the International Space Station. Those missions are most of the time around 6 months, but can have gone up to 12 months in a couple of cases. Then we'll go to Moon, and then Mars is going to be somewhere on the order of a 32-month trip, and that's once we're going to the surface of Mars. So 6 to 8 months to Mars, probably about 18 months on the surface so that the planets are again close together, another 6 to 8 months back home. So let's talk food. There's basically 4 requirements that a space food system has to meet. It has to be safe, acceptable, nutritious, and then efficiently balance appropriate vehicle resources, such as the volume, mass, waste, water, power, etc. Now, we'll talk a little bit more about each of these, but just to give you an example of when I say efficiently balance, shelf life is going to be a big deal. We could help this shelf life immensely by packaging it in really, like stainless steel packaging, in maybe a refrigerator or freezer, but all that takes a lot of mass and volume and power, and that may not be the right way to go for a given mission. So let's start from the beginning, because I think there's a way to then appreciate how far we've gone. So I will say, even in the Mercury mission, NASA did not even know if people could eat in space. There was not an understanding of how much of the eating process, through the chewing, the swallowing, and the digestive process, how much of that was due to gravity and how much was due to just your physiological body, how things work. And so they started very slowly with a meal and a pill kind of concept, or the tubes, which was basically pureeing anything into the consistency of applesauce. Gemini, we basically went to a little bit more engineered, because now they were going up in space for more than just a few hours. And then Apollo, because it was now a longer mission and there was more opportunity to do some testing, they had what we call thermostabilized foods. That's basically a canned food, or canned food in a pouch. The spoon bowl was the first time, and that's a picture of it on the right, that they ate with utensils. And because of surface tension, you can do that. And then natural form foods is what I call middle of the grocery store foods, because these are the ones that are already shelf stable because they're drier, or they are just naturally don't need refrigeration. So these would be things like nuts and dried fruits and other items. Skylab was probably the most sophisticated food system that that NASA, excuse me when I say we, I know it's been 4 years, but I still think we occasionally, that NASA had a freezer on board, because Skylab missions, everything went up on the first mission and there was no resupply. And the item on the right is what they called their the food tray, or the warmer, and it's heavy. It's probably 40 pounds or more. And in there were places to put the food, but also places to warm up food. But you would never launch this on a NASA mission now. It's just way too heavy. Shuttle Mir was our first opportunity for international agreements and co-missions. And that one required a 9-month shelf life. And shelf life of food is basically the time when the food is still safe, acceptable, and the nutritional content is still adequate for the health and well-being and performance of the crew member. And of course, now we're on ISS. NASA has some special FDA allowance, food and drug allowance on irradiated foods. This is not the foods that you see in the store occasionally that are irradiated, like our spices might be irradiated to kill off some insects and other things, but this is done to what we call commercial sterility. So the same as what a canned food would do. It's just using irradiation. And before someone asks me, no, there's no leftover radiation in the food. It completely dissipates as soon as that electron, it's usually an E-beam or a gamma, isn't being hit, the food is not being hit by it. And then we borrowed some packaging ideas, or actually they still use, I believe, the same material that the military uses for their MREs. And it's a multi-layer package that has some aluminum in it. Aluminum is wonderful for barriers to water and oxygen. And I had many, many years ago, a middle schooler say very, she knew what's going on. She said, water and air is not food's friends. And she's exactly right. immediately the food chemistry happens. But that gives the food on the ISS somewhere between a 12 and 18 month shelf life for most of the food. Whoops. All right, now why is it not moving? Let's try, okay, we'll go this way. So this is what the food system looks like now. And so you can see the beverages are all in powdered form. And yes, we do still, or NASA does still use Tang, which for people who are my age would remember all those commercials about Tang being for NASA. It wasn't that Tang was developed for NASA. It was that NASA realized this is a very smart way to package our beverages, but they're also using other dried beverages. The rehydratable foods or freeze-dried foods. You'll also find breakfast cereal in that kind of pouch with the dried milk powder. And so when you add water through, and I don't know if my pointer worked, but through this little septum, then it will hydrate the food. And I think we'll talk a little bit more about that, but the water is either at ambient or I'll say hot, but it's not super hot because again, power takes precedence on some of these missions, as well as the fact for safety. And then these are what do look like MREs, but they are all NASA formulations at this point. About, I'll probably lose track of time, but probably about 7 or 8 years ago, the NASA Food Group went through a huge reduction in sodium process. And in the process, we stopped using a lot of MREs that we had been using. And then condiments are liquid because you would certainly not want some pepper flakes to be floating around and getting into your eyes or any other orifice of your body. So let's sort of compare International Space Station food system requirements with Mars. And of course, Moon again would be something in between. So as we mentioned, 6-month mission versus a 32-month or more mission. International Space Station has no refrigerators or freezers for food storage. They do have some freezers for biological samples, but not for the food. So all the food is processed and prepackaged, with the exception of a little bit of the veggie, the greens that you sometimes see that they grow. And I think Joy and Massa, who follows me in speaking, will be talking a little bit more about that. To my knowledge, they have not made a decision for the Mars missions whether there will be refrigerators or freezers for food storage. The food group has an extended shelf life test going on right now, and that will give more information on whether they can reach this 5+ year shelf life for a Mars mission. If you think about 32 months of the actual mission, making the food, packaging the food, stowing the food, and the fact that there was discussion about positioning the food in advance to the people going, which would mean probably 2 years in advance. So if shelf life can't happen without the refrigerators or freezers, then NASA will have to get very creative on figuring that one out. Because International Space Station, there are probably scheduled resupplies every 6 to 3 months normally, no resupply for a Mars mission. Radiation, yes, we're irradiating the food, but in general, we don't want radiation hitting the food at a low level or medium level, and we don't know what that level will truly be because we really haven't done any testing of that. But because on the Mars missions, the food and crew and vehicle will all be leaving low Earth orbit. There will be some radiation. How that affects the food is still to be determined, but it's likely it wouldn't be a huge impact, but there could be some. Right now on ISS, they have somewhere in the order of 8 to 11 days standard menu cycle, meaning every 8 to 11 days, those menu items are repeating themselves. And we don't know what that will be, but we do know that that it will have to be at least that long because of the fact that, and we'll talk a little bit more about that acceptability. And finally, the current food system that we have really does not meet this 5 to 7 year shelf life. And so there's a lot of work that is being done and will continue to be done. So just to give you an idea of what the shelf life is, it is not just one thing. It's not like if I found the right packaging, it would work. If I found the right process, it would work. It is a combination of all these pieces. Formulation. Before I worked at NASA, I was doing product development for a rice company in Houston. And basically I kept telling my boss, who was a marketing guy, good ingredients in gives a good product out. Start with bad ingredients, you're not going to get as good a product. So formulation is everything, but it means also trying to get all those nutrients in there and other food items, macronutrients, micronutrients that you might want. Processing. There's some indication that some newer processing methods being used in the food industry, which is pressure-assisted thermal sterilization, or PATS, and microwave sterilization, which is MATS, could help. Lyophilization improvement, which is the freeze-drying process. Maybe we don't have to freeze-dry quite as much. And then 3D printing, and there's been, as our previous speaker spoke, there SBIRs, there was many years ago a 3D printing SBIR on that. Packaging, I've already talked about. We just need a great packaging material that is both oxygen and water, excellent oxygen and water barrier properties. But we would like to get out of the foil, because foil cannot be if you burned up foil, it would be ash. And unlike ISS, where they basically take all the trash, put it in a progress module from Russia, it goes into the Earth's atmosphere and burns up. On Mars, you're stuck with all this trash, and what do you do with all of it? And there's a lot of work that's been done on that. And of course, the environment we talked about, and all of this is a closed system, so we need to make sure we have enough variety, enough that will help with the psychosocial support, which is maybe eating together, and then the physiological impacts, which the whole human research program at NASA is looking at, and how does the food help mitigate some of those physiological impacts, like bone loss, et cetera. So the terrestrial part, the left column is basically what food scientists here on Earth, when they're developing products for Earth-based systems, the grocery store, restaurants, et cetera, are looking at. But when we start looking at the longer term exploration missions, some of these other items do fit in more importantly. You've got, food is in a package, so you're not really seeing the food, but if you could see it, it might be a little bit better. Aroma. This is all volatiles, and on Earth, hot air rises, so the volatiles are, and the aromas are going up to your nose. In space, in weightlessness, that aroma could be going to your feet. So how do you get that flavor even stronger? Serving temperature, again, ISS is not serving things at super hot temperature because of safety and power. Food preferences, long-term acceptability. There are people here who probably have the same meals on Monday every week, Tuesday every week, Wednesday every week. I went to school with some of those people. But other people want variety. So how do you sort of mix and match that? Cultural. If you're from a different culture, maybe you like Asian food more, Italian food more, how do you put that into the menu? Familiarity. People talk about, oh, we'll just get the right kinds of, this is years ago, we'll get some of the right nutrients through blue algae. And it's like, but no one knows what blue algae is. How do you get them familiar with it? You can probably get them familiar with eating more tofu or vegetarian items, but that may be about it, especially for a 3-year mission. Social, debriefs on International Space Station when we had food debriefs, we talk about when we eat together at the end of the day, it's so much better. We can decompress, we can talk about things, what's going on. And then we'll talk a little bit more of the dining location, because we've gotten debriefs saying, get the dining area away from the WC or the bathroom. It's doing this to me again, so, okay. So again, eating together, holiday meals. Yeah, what did you have for Super Bowl Sunday? What did you have for Thanksgiving? This is probably a picture, or could be a picture of a combined shuttle and ISS crew. The shuttle crew would often host the ISS crew with a special meal, whether it was because maybe there was an international crew member on the shuttle who wanted to share some of his local foods. And we work hard to try to get that approved and put together in a shelf-stable manner, because again, there's no refrigerators or freezers. And crew care packages, again, for resupply on ISS, the crew can get some special foods that they really want, as well as other items. On Mars, that's not going to happen. And again, we've talked a little bit about this, but again, food quality, variety, and acceptability is so important. And it's as important, it's hard to measure it as easily, but psychology of food is as important as the nutrition of the food for these longer missions. Because if you start getting tired of the food, or not, just not wanting it, the food isn't as acceptable as before, you're going to you will only eat the minimum amount that you need to not be hungry, but it may not be enough to get the total nutrition. And then more changes will happen, whether it's bone loss, muscle mass loss, immune system issues, etc. So again, and a lot of it is, and this will change with the Mars missions a little bit, but everything is so schedule oriented on NASA missions that very little do they have their own choice on. But on ISS, they do have some choice of self-selection of their menu items. What do I want to eat today for breakfast? Now, as I said, this is 8 to 11 day menu cycle, so they're only going to be able to eat whatever's in that package for then. But again, they have some control over their menu, which is so important in a mission where they don't have much control over what they're doing day to day. There are anecdotal reports that food doesn't taste the same in space. And I mentioned that, smelling the food is really a lot where your taste comes to, and it's 85 to 90% of what you taste. And so we've talked a little bit about this. I did not mention the fact that the food is eaten out of packages with small openings because of surface tension. It does stay in the package, but you don't want to open it too much, because if you then jerk the food package too much, the food could go flying. And then fluid shifts in the body due to the microgravity do result in a feeling of congestion in the nasal passages. So you may not be tasting the food as much because you just can't, you feel like it's similar to when you have a cold. You're not getting all of those volatiles that you hope are even getting close to you because of the microgravity. You're still not smelling enough and tasting enough. Okay, again. So I talked about location, and this was a little bit of a joke when we were many years ago starting to look at the what's now the Orion vehicle, and the crew members were saying, you got to get the dining table away from the toilet or the WC. And it's like, it's not that big a vehicle. And even on ISS, that's the same case. So you do the best you can and try to take care of it that way. And then here on ISS, the exercise equipment can also be very close to the toilet and the dining facility where people might be sweating and all that. So again, how do you at least be aware of the issues that might happen. So let's talk a little bit and sort of introduce some of what Joy and Masa will be talking about. As we talked about, ISS is mostly the prepackaged foods with a little bit of pick and eat with the veggie chamber. And the Mars scenario is eventually more of that bioregenerative or growing of food will occur on the Mars surface in growing chambers, not outside. Probably hydroponically, because that's a lot easier to do than carrying up a lot of soil and dirt, because the Mars surface, to the best of what we've learned, is that it's not necessarily conducive for growing plants. And with using hydroponics, you can cycle in the fertilizer and nutrients that are needed by the plants. But all this adds into more research that has to be done. Not even talking about growing the plants, but once the plants are ready to harvest, what are the radiation effects of the food and of the plants, obviously, but then how do you handle these items in the microbiological issues and crew time? So right now it takes less than an hour for a crew member to prepare their food, eat the food, and clean up. But if you are starting to do more of the food preparation, even making a simple salad will take some extra time. And how does that get balanced with the rest of the crew time resources that they need for other tasks? And again, I think Joy will be doing this. I'm not going to talk too much about this, but plant chamber crops and bulk ingredients, and then the food system team will have to identify how to use these products, and especially if eventually bulk ingredients are used or grown, wheat, for example. How do you make bread or cake or pasta with these items, and being completely self-sufficient at some point, which I'm not sure will ever happen, but it could in decades. So based on the food system, what's involved. So we've got pros and cons of the package, and a lot of this we've talked about. There is a lot of nutrient degradation with the packaged items. And there's high mass and volume. Now the bioregenerative will have high mass and volume to get the infrastructure up there, but after that it may be lower. There's a lot to be said on taking care of plants. I've taken up gardening in my retirement, and it's wonderful. You have variety and customization, but again, crew time, and then what happens if a crop fails? What do you do about that? How do you plan for that? And then food preparation. You've got right now just a food warmer and a water dispenser. But if you went to the preparation of food, you would have what I call gourmet kitchen appliances. And just to sort of give a very quick overview, because I see I'm running out of time drastically. There was a case study done several years ago with the food team, and how do you get the mass down by 30%? And it was pretty hard to get it down 30%, but they could get it down a little bit by saying, well, what if we just had food bars for either breakfast or lunch during the week, and whether it's every day or not. And what they found is, though you have a lot of great pros of mass and volume reduction, the crews that were in mock studies on analogs, it was actually one at Johnson Space Center, said they just couldn't take having a bar for like breakfast or lunch every day. And there were only 4 bars at that point, 2 savory, 2 sweet. And I know they increased it to 6 total for a longer study, and I have not seen the results of that. But you've got to start thinking about that psychological effect. But it's a lot of mass if you bring up just a packaged food system for the whole Mars mission. And with that, I'm done. I always like to thank both the current and former advanced food technology team members. They're great. They continue to be great, and just like to thank them. And I think we're going to do more of the questions during the panel, but let me know if I'm supposed to be taking questions now.
No, we are going to move on to the panel, but I want to point out, Roxanne had a comment here. I'm a big fan of your NASA research. I was wondering if you knew why NASA no longer makes the ISS menu publicly available. The last document I could find was 2011. Do you have any information on the NASA ISS menu?
I don't know why they're not publishing it. It may be just that they just haven't done it recently, just forgot. It's harder to publish a menu for ISS because it is more just based on food groups. These breakfast items, these desserts, these, but they do add typically anywhere from 2 to 6 new items every year because, again, variety is so important. Cool. So I don't know. Let me just stop sharing. There we go. So I don't know why they haven't published it. You can put in a request through NASA PAO or something, see if they can take care of it.
Okay. We're going to move on, but thank you very much. Stick around for the conversation here in a little bit.
Yep.
All right. Thanks. Lila?
Yeah, thank you so much, Michelle. This really brought back a lot of memories for me. Just the wonder of like astronaut ice cream as a kid.
Which they have never eaten.
Really?
That was a big, that's just
it all.
that they brought it up once because a crew member said, we sell it all over the place. We should at least have it once. Because they bring up freezers for biological samples, occasionally they will super freeze some ice cream to bring it up to the ISS crew, real ice cream, but not the freeze dried. Oh, sorry. I hate to burst people's bubbles.
Totally bursted, but thank you so much. That was really, really fascinating. Thank you.
Thank you.
All right. Well, we will move on to Joya.
Yeah. Hi.
Hi, Joya. How are you?
I'm good. And hi, Michelle. Good to see you. So I'm going to share my screen now. Is that good?
Let me do a quick intro, Joya, and
okay,
then you can take it from there.
Okay.
Thanks. Dr. Joya Massa is a NASA scientist at Kennedy Space Center working on space crop production for the International Space Station and future endeavors. She conducts space crop research and outreach, helps enable external scientists, and helps plan for future ways to feed space exploration. She has a BS in plant science from Cornell and a PhD in plant biology from Penn State, and postdoctoral research from Purdue and Kennedy Space Center. Joya, please, you have the screen.
Okay, well, thank you. And it's wonderful to be here with you all today. I had a forced computer reboot and it took me forever to get in, so I apologize for that. But I'm going to share my screen and hopefully that coming up. Okay. It doesn't say that it's sharing. Is it sharing? Can you see it? You cannot see it. Okay.
It's sharing, but it's flashing for some reason. Like it's not.
Let me try putting in a slideshow.
Oh, there we go.
Better? Okay.
Yes.
Great, except I can't see you at all, but now I'll do that. Okay. So hello, everybody. Today I'm going to talk with you about plants in space, veggie, and space crop production. And, Michelle gave a fabulous introduction to our work. First of all, just a few members of our team. I just want to show their pictures. This is a very collaborative project. We have scientists, we have all different kinds of scientists and engineers working together, as well as interns and postdocs. And it's something that we can't do without a team. So why are we growing plants in space? You know, I think you've already heard this, but I love this photo of Mike Hopkins showing his Thanksgiving dinner. And, you know, it's a good dinner. You know, the food is really good. But as Michelle said, over time, some of the quality and the nutrients in that food degrade. So right now we're focusing on supplementing the packaged diet for more near-term missions, for these, you know, longer missions. At the same time, also the psychological well-being of growing crops is something that we're actually starting to take data on. There's been a lot of anecdotal data for a number of years on this, and now we're getting concrete data. Plants help to revitalize the atmosphere. They take up the carbon dioxide that the astronauts are breathing out. They give off oxygen. So they can be a very important part of a life support system for the crew that's even separate from the food system. They also take up water through their roots. It doesn't have to be the cleanest water, though you probably want it pretty clean if you're going to be eating the plants, but they give off completely pure water vapor from their leaves. So they can be a critical part of the water purification system as well. And, you know, what might a longer term habitation on the moon or Mars look like? This one's depicted on the moon. And you can see here a concept where you have densely packed layers of plants growing under electric lights in the same facility that people are living and working and sleeping. We have a very thick outer wall to protect from some of the hazards like micrometeorites and radiation, galactic cosmic radiation, solar particle events. We have an airlock to protect from dust. This is fairly realistic for a permanent station on the moon or Mars. This one's on the moon. And, you know, we're already growing plants in similar fashions on Earth today in vertical farms or plant factories around the world where we have these densely packed layers of plants growing under electric lights. This is really great in urban areas, especially for high value crops. Economically, it doesn't make sense for all crops, and it doesn't make sense in all regions of the world, but in large urban areas or places where farmland is just not nearby, where they want fresh, high value produce, it can be very economically sustainable. This is a training facility at Osaka Prefecture University, where they're actually training university students in vertical farming. A more near-term scenario might look something like this, where you have an entire module that could launch on a rocket and that could be hooked to other modules to form your space habitat. And this greenhouse module could then support the crew that live here, maybe for, you know, shorter duration missions, not maybe permanent stays. And we're growing crops like this on Earth today. This is the US South Pole greenhouse at the US Antarctic Station, where they have volunteers who take care of the crops, especially over winter, and they produce fresh salad crops for the crews living at the base in Antarctica. It's not just nutritionally important, it's also very psychologically important for them. They have people that spend a lot of time with these plants. They never lack for volunteers. We actually have one of our scientists in Antarctica right now at the German Neumayer station running the Eden ISS plant growth facility in a collaboration with the German Space Agency. So we're learning a lot more about this long duration isolation crop care. So our space crop production vision is to ensure food system security on long duration missions beyond low Earth orbit. And what I mean by food security is the condition in which the crew have continuous access to sufficient safe and nutritious food, which meets both their dietary needs and food preferences in order to maintain peak health and performance. And so we're doing this near term. We're focusing, as I said, on the nutrient supplementation of the packaged food. But long term, we're starting to move towards caloric replacement to begin to start to facilitate Earth independence. We may never be completely independent from Earth, but the idea is to move in that direction. And so, you know, we're looking at these candidate crops, and Michelle had a list. Right now, we're kind of on the left-hand side of this chart. We're focusing on these salad crops and herbs that can be picked and eaten fresh without significant processing equipment. And we're testing a number of these in our ground facilities and then working those into spaceflight testing. The staple crops, things like white potato and sweet potato, really all you need is some cooking capability. If you had a microwave or an oven where you could cook those, you could have baked potatoes and baked sweet potatoes. And those are pretty high calorie crops. They don't require a lot of processing. Obviously, you can process them more extensively. Things like wheat and soybean do require a lot more processing equipment. Like Michelle pointed out, you have to have basically all that stuff. And that's a lot of launch mass and crew time. Or more likely robotics and automation. So we would have to have, your milling and threshing equipment and, your tofu presses and bread machines and things. But we'd also have to have the robots to run those, which I think is a really great opportunity for a lot of students that are interested in robotics and developing robotic approaches to this, because the crew on Mars are not going to have time to do subsistence farming. They're there to explore Mars, and the food production will have to be something that kind of takes place with pretty limited input from them. So when we think about plant growth in the environment, there are these 5 cardinal factors that have to be within a certain range for plants to grow well: temperature, light, moisture, nutrients, and atmosphere. And in the space environment, these may differ a little depending on things like gravity. With microgravity, there's no natural convection. So we have to have fans to mix the air to distribute the temperature in the atmosphere. The lights can look different depending on what characteristics we want from the plants. And we're actually studying this right now to see how that light quality, that spectral quality, impacts plant growth, plant nutrient content, even plant flavor. Fertilizer is very heavy if we're going to be, launching everything from Earth that's not really sustainable. So we have to figure out how to reuse things like your stems and leaves and roots of a tomato. How do you reuse those to grow the next set of tomatoes? Probably, as Michelle said, hydroponically. How do you get those nutrients correctly dosed to those plants? And water is really tricky, especially without gravity. Water and air don't mix. You see this separation. And plant roots need water and they need oxygen. So how do we water our plants? So we have these challenges for space crop production, and some are very specific for deep space, that lack of convection, microgravity. Some are very specific for surfaces. You have dust, you have partial gravity. Some are shared between both, like the radiation, micrometeorites, maybe operating at reduced pressures. Then we have some crop-specific challenges down here at the bottom that are just as relevant for any terrestrial agricultural system. How do you have productivity? How do you have stress tolerance? How do you optimize for your environment and schedule things effectively so that you always have some of the crops that you want? Maybe you want, 1 head of lettuce every day for, continuously, but you don't want wheat continuously, right? You would want wheat in batches. So how do you schedule things? And then we have some shared challenges in these different environments. How do we be sustainable? How do we control the microbiome and ensure food safety for the astronauts with, limited vehicle resources, all these environmental stresses, et cetera. So we're doing a lot of work on the International Space Station to test these future technologies. We don't need them yet. We have a very good diet. We have, great health and performance based on nutrition. But in the longer duration missions, we may need these things. And so we're starting to test them. And one of the things that we've been testing is a small plant growth chamber called Veggie, which is pictured here. It's in the Columbus module of the International Space Station, which is the European laboratory. And you can see that environment with all the wires and cables and plastic and metal. It's very synthetic. So you can imagine how having something green in that environment might make you feel if you're up there for a long duration. Veggie's about the size of a 2-drawer filing cabinet. So it's pretty small and it's kind of collapsible. It uses LED lights, red, blue, and green. And it uses the space station environment to control the plant growth. So the carbon dioxide, temperature, humidity is all coming from the space station. And for the very first crop in veggie, we grew red romaine lettuce. Here you can see Steve Swanson harvesting that. We had a lot of challenges with the watering. We continue to have some challenges with the watering, though we've gotten a bit of a handle on it. But we only got 3 of our 6 plants to grow, which in baseball terms, you're batting 500, so it's not that bad. But obviously, we wanted to do better. For the second test, hopefully you can see this video. This is Kjell Lindgren, who will be going back to space station soon, harvesting the second set of lettuce. And we got 5 of the 6 plants to grow. We had a hardware problem with one plant pillow in the top left corner there. So even now, when we're growing these crops, and I'll show you more of the crops that we've grown since then, we still bring samples back to Earth. So the astronauts get to eat about half the lettuce. The other half here was frozen and returned for food safety and nutrient analysis. For the crops that they're eating, they have to sanitize them. And right now we only have citric acid-based sanitizing wipes in a bag. They put the layers of leaves in between layers of wipes and press it for 30 seconds. This knocks down the microbial contamination. After that, they did the toast, because that's what we all do with our lettuce. And you see Kimia Yue, Kjell Lindgren, and Scott Kelly taste lettuce. So this was a big deal. This was the first time that we grew crops to eat in NASA hardware. And, you know, Scott talked about the logistical complexity of having people live and work in space and the long supply chain that's required. So we have to be more self-sustainable for a Mars spacecraft. And Kjell, who is a physician, talked about the benefits of eating the fresh food, the contribution that the plants had to the space station ecosystem, and the psychological benefits of seeing them in the environment. So it was pretty awesome that they made these speeches as part of this harvest, and it really encapsulated all that we've been thinking about. Since then, we've grown more lettuce, but we looked at repetitive harvesting. So this is Shane Kimbrough, who's doing repetitive harvesting the last time he was on space station of the same red romaine lettuce, a technique called cut and come again. We were able to grow the lettuce twice as long and have continuous harvest from the same plants for a month. Peggy Whitson did the same thing with Chinese cabbage. And then we sent a second veggie unit. And here you see Scott Tingle showing off some mixed crop growth within 2 veggies. We had these slightly staggered so that we could have harvesting every 3 days for that month after the plants were mature, to start to look at what a continuous harvest scenario would look like. We've sent additional new crops. So we had the red Russian kale, dragoon lettuce, which is a small butterhead lettuce, wasabi mustard. This one's kind of a spicy horseradish flavor. Extra dwarf pak choy, a crispy, juicy little baby bok choy, and amara mustard. We call this one steak plant. It's a bit meaty, kind of an umami flavor. And we were growing these in different combinations, with the last 2, the extra dwarf pak choy and the amara mustard, just recently harvested this spring on space station. They grew for about 70 days, actually. 2 of these were actually selected by middle school and high school students in a program that we partner with the Fairchild Tropical Botanic Garden called Growing Beyond Earth, where we have this citizen science program. We have about 250 middle schools and high schools around the United States now testing crops in small plant growth chambers in their classrooms and providing data. If you can have a crop that grows well with 50 different classrooms with different students watering, different temperatures, altitudes, everything else, then it may be a resilient crop for space. And so all of their data gets fed to NASA, and the ones that look like good candidates then get tested under higher fidelity conditions in our labs. We've conducted the VEGO4 experiments, where we were doing the red to blue light ratio impact on the plant growth, the nutrient composition, the organoleptic appeal. We actually had the astronauts do taste tests on orbit, and microbial food safety. And here is where we started doing the assessments of crew behavioral health. So they're doing psychological surveys on how the plants make them feel, how the plants impact their life, as well as, you know, the importance of fresh vegetables in their diet. And we had a lot of engagement and a lot of interesting food combinations come out of these experiments. Here you see more of the astronauts just enjoying the plant care and enjoying eating them. So they were pretty successful. We've gotten a lot of feedback from the astronauts on how much they love the aroma of the plants. And they say it's like, you know, when they open the veggie, it's like being in the produce section of a grocery store, and how they just really miss that aroma on the space station, which I gather doesn't smell too nice. We also have recently grown radishes in the advanced plant habitat, which is a different piece of hardware. This is Veggie's big sister. This is the very controlled plant physiology research chamber. And this experiment was conducted by principal investigator Carl Hassenstein from the University of Louisiana Lafayette, and the crew members got to eat these. This was over last winter. And then this spring, we did the mixed crops. As I said, we showed that you could transplant. So we had some that didn't germinate, and if you're a gardener, you know that if you were to transplant this plant here on Earth with this little tiny root, it would never have survived. But it actually survived in space. This is one case where the fluid physics worked to our benefit in microgravity. So we were able to successfully transplant plants from plant pillows. We tested a new way to handle seeds where the astronauts were able to plant them directly on orbit using these seed films. So it's a water-soluble, food-safe polymer that we basically embed the seeds in on Earth. And so Mike Hopkins planted this red romaine lettuce in our grow bags, our plant pillows that had no seeds in them, on orbit, and they grew exceptionally well. And the idea behind this is to start to develop a library of seeds that the astronauts can plant. You know, they can actually select what they want to plant and grow, not just what we're prescribing. So the seeds can be sent dry in these films. The films themselves could also have things like fertilizers or growth promoters or beneficial microbes in them, freeze dried essentially, or just dried, and then they could be added to whatever growth substrate we want. So this is a really great demonstration to show that future autonomous gardening might be possible in space. And just yesterday, this experiment was started. This was a ground shot of what is going to be growing now. These are the Española improved hatch chili peppers. So they got initiated in the advanced plant habitat again on space station. The astronauts like spicy things, you know, as Michelle alluded to, their sense of taste and smell is kind of muted often in space. You see a lot of bottles of hot sauce and sriracha up there. So the idea was to grow some hot peppers and see how they like them. So in the ground test, they did really well. We hope by September or so, we'll start to see something like this on the space station. And as everyone from New Mexico always gets asked, you know, red or green? The Española chili peppers can be eaten red or green, and depending on your preferences, you tend to like one or the other. So we're really looking forward to this, and we'll also be collecting the crew data on psychological benefits and the organoleptic appeal of these crops. So I'll just end, you know, a lot of thanks to our team, to all the astronauts who contributed so much of their time and effort and enthusiasm to this research, and of course to the funding at NASA Space Biology Human Research Program and the ISS. And this is just a shot of a bouquet that Scott Kelly made on Valentine's Day with some crops I didn't mention. We actually grew zinnias, which are more ornamental than edible, and he decided to make a bouquet. So thank you very much.
That was awesome, Joya. I have zero biology background. I mean, none whatsoever. And so literally everything that you and Michelle posted was brand new to me. And I haven't seen that in in space before. So I'm really excited to see both of your presentations here. You have some comments in the chat. Let me find it. There was one in particular. Roxanne was asking, was that a polyvinyl alcohol water soluble film? Is that what they transport the seeds in?
So it's actually the same material that's the Listerine breath strips. It's a polymer called Pullulan. And we had a polymer chemist on our team, and he researched all of the different available, water soluble, food safe polymers. And this one had like the lowest water content. So it was able to be stored dry for very long. But yeah, I think there are probably a lot of different things, including PVA, that could work. This one was Poland, though.
I mean, really, it's pretty fascinating. So just a rough guess, lettuce is kind of the crop you showcased here, but how many plants, edible plants, I mean, the flowers are pretty, but how many edible plants are now kind of ISS rated?
So I think we're at about 15 varieties of leafy crops.
Okay.
And then, the peppers, we're working on tomatoes. We've had plans for dwarf tomatoes for a while.
Long time, yeah.
And we've just had some hardware issues with that for veggie, because it is such a long growth cycle. And then, the radishes. So I think we're at about 15 or so.
We don't do particularly well in our backyard with tomatoes, so I imagine it's a little harder even up there. 15 plants, that's pretty amazing. I was at a DC conference about 8 years ago, and there were some Italians that insisted that they were going to make a spaghetti dinner on ISS, which means grow the wheat to turn it into spaghetti, basil, tomatoes. Any progress on that? I mean, it seemed like a far-fetched claim at the time. So if you're telling me you can't make tomatoes, I'm guessing we haven't gone very far on that.
Well, I haven't heard about that specifically, but I mean, wheat has been grown successfully on ISS. Basil has recently been grown with the Asian Urban Space Experiment coming from the Japanese Space Agency, which I think was in collaboration with scientists in Malaysia, I believe. So they did basil. So all of these crops can be grown. Tomatoes can likely be grown. We've just been trying to work out the hardware. The Russians have grown tomatoes before, but they did not get flowers or fruit, to my knowledge. So it's I think the challenge comes more from the processing side at that point. Threshing the wheat, grinding it into flour, milling, and then making the pasta. That's pretty hard without gravity. So, but I think the plant side is doable. Getting the hardware right and that growth environment right, that's been really tricky. But we are working on a larger production system that will come next to be able to do more larger scale production.
So we just had Dr. Massa, we just had Emma come in talking about Gateway. Are any of these experiments expected to transition to Gateway, or is that mostly going to stay on the ISS?
From the plant side, we do hope to have some research in Gateway. One of my colleagues works a lot on the radiation, and as Michelle said, that is something that we've got to get a handle on for deep space. So I believe there's a plan to have seeds on Gateway for radiation testing, longer duration, outside of Earth's magnetosphere. The radiation testing that we currently do is at Brookhaven National Laboratory, where we, subject the plants or the seeds to simulated galactic cosmic radiation or simulated solar particle events. But these are high dose and short duration, as opposed to the low dose, long duration you would get in an actual scenario. So Gateway is going to be really important for that. I don't know how much space we're actually going to have to grow larger plants, but one of the categories of crops that we're interested in are called microgreens, which are essentially baby plants, 7 to 10 day old, or 7 to 14 day old plants. And so that could be a really great place to test those out.
Microgreens, are those spices? I'm sorry, that seems like a really basic question, but I don't know what that means.
No, yeah. So microgreens are sort of a category of essentially baby crop plants, and you can grow everything from broccoli and carrots and corn to basil and fennel and some of your spices as microgreens. And essentially, the plant germinates. You get the two seed leaves, and then you get like the first true leaf, and that's the point when you eat them. So you plant a very dense lawn of these. You plant a ton of seedlings, or a ton of seeds, and then you essentially mow the lawn and eat the grass clippings. But they're fascinating, and we're working with our colleagues at USDA to research these because the young plants are very nutrient dense. So they have between 4 and 10 times the nutrient content of their mature plant counterparts. You can grow almost any plant as a microgreen where you eat the leaves or the plant. So not tomatoes, obviously, because you don't eat the leaves of those, but pretty much, all of the leafy crops, things like radishes, all of your herbs and spices, and they're very, very flavorful. So you can just have a small handful of these little plants and you just get a huge burst of flavor. So we think they're a really good candidate for space. You do see them now more and more in the grocery store, and you see them in a lot of restaurants. These will be the little tiny plants on top of your fish.
Yeah. Okay.
And unlike sprouts, they're grown in the light and you don't eat the roots. So they don't have the same microbiological safety concerns that you may get with sprouts, which tend to be grown in the dark in a very moist environment.
Wow. Let me ask a question from the audience. Kevin was asking, have any root vegetables been grown?
Yeah, that's a great question. There have been potato experiments, like on the space station, there was a potato experiment. And my colleague Ray Wheeler is like a world potato expert. But while we've done a lot of ground testing with potatoes, sweet potatoes, daikon radish, they haven't yet been grown in space. The cherry bell radishes that you saw in the advanced plant habitat, they form a root kind of on top. But at this point, we're still using granular substrates to grow the crops. It's sort of a modified hydroponics. It helps to buffer this water-air mixture challenge that we have. But it's not easy to harvest things out of that without that material going everywhere. So I think we need a dedicated root crop hydroponic system for space, and we haven't developed that yet.
Wow. All right. Well, that's pretty interesting. We're going to kind of transition, bringing both of y'all together to kind of turn this into a conversation. Lila and Lee, are you a part of this, or am I leading it? I just need a little bit of feedback on this.
Yeah, absolutely. You are leading it. I'll just do another quick intro. I mean, you've essentially done that, but I think for the people joining us, I just wanted to give them a little context about, who we're talking to and who the speakers are. So thank you all for joining us. Thank you, Joya. That was phenomenal. I loved all of the photographs you featured of the astronauts at work. It was just great to see a day in the life as well. And I don't know, kind of made me hungry. So thanks. All right. So our next panel will include Michelle Pernichik and Joya Massa. And Dr. Michelle Pernichik is retired from NASA Johnson Space Center, where she managed the food science research and was previously the HRP Advanced Food Technology Project Manager and the Shuttle Food Systems Manager. Joya Massa is a NASA scientist at Kennedy Space Center working on space crop production for the International Space Station. So please, Michael, ladies, take it away.
Right. All right. So a question that comes up surprisingly frequently is why can't you use some of the human waste for fertilizer, right? There's a, why can't we use some of this stuff? I know that the chemical toilet at ISS makes that stuff kind of unusable, but people have asked several times about that. So can you just kind of give the official answer on why we can't use that for fertilizer?
Yeah, the short answer is we can. It's just very complicated, and we really need to ensure food safety. I mean, food safety is the #1 priority for any bioregenerative system or any food system in general. We don't want to get the astronauts sick. But urine is something which is a great source of nutrients. The big challenge with urine is the sodium. Humans need sodium. We excrete a lot of sodium, and plants don't like sodium. They don't grow in salt water for the most part. We've had a number of technologies and approaches looking at ways to get the nitrogen, the urea and the ammonia and things that plants can use out of the urine, the phosphorus, calcium, and provide them to the plants while excluding the sodium. And it's technologically pretty challenging, but I think it's feasible. The human solid waste is, there's a lot more microorganisms there. Yeah. It's still feasible, but it would require something like, combustion or really high temperature anaerobic digesters or aerobic digesters, something to break down. And so it's really complicated to just get that whole process through, get those nutrients back in a form that plants can use without any of the potential human pathogens. Most of the microorganisms that are on the space station are human associated, right? We are sanitizing our plants, we're sanitizing our hardware, we quarantine the astronauts before they go, but they have a very large human associated microbiome. And if that microbiome starts to grow in your food system, even if it's something that's perfectly, okay in your body, it may not be okay if you're eating, someone else's microbiome, or things could mutate or whatever. So I think food safety has to be, the complete priority, and then, figuring out the technological approaches from there is a bit of a hurdle.
And I'll add, again, you have to efficiently use or effectively use and balance those resources. And if it takes so many resources to sanitize the human waste or make it ready for plants, you have to balance that with how much weight or mass am I taking up in fertilizer or other nutrients needed, and what's the benefit, or where's that return on investment. So that's what the system engineers do a lot of.
That's actually related to an earlier question about setting up a settlement on the lunar surface. How easy is it to transition some of this technology, some of the food systems to the moon, right? We're going back.
Right. Yeah, so we've actually, one of the fun parts of working at NASA was doing these blue sky discussions and looking at, well, what if we did this? What if, where are the challenges? Where are the benefits? And and so the question really was not necessarily even on the moon, but if you went to the Mars and had a habitat there, and then you're coming home, and this food is now that you took from Earth, 3 years old or thereabouts. What if we did process on the surface? And the answer is, it takes a lot of equipment. Something like freeze drying might work, because you're basically, if you can get down to the cold temperatures, you're basically taking that water out of the food, skipping that liquid phase and going from frozen to gas. Something like the thermal process, the thermal sterilization process, which is under pressure, probably also would work, but these pieces of equipment are huge and takes a lot of energy. And again, where's that sweet point on mass volume crew time versus figuring out on Earth how to get a longer shelf life food and then just sending it up? And I think we'd all rather use our resources on Earth more than taking those resources on a space mission.
So there's roughly 6 people at the ISS on a typical, at any typical time. There's 3 more on the Chinese Tiangong. At some point, we're going to double that. At some point, we're going to get to 18 people. At some point, we're going to get to 20 people on orbit. Is it really, right? Like right now, it's an ROI question for 6 people, but as you get more people up there, does it change the math? Does it change the equations?
I would expect so. That's not my expertise.
Okay.
But I think, you know, as you get more people, some of the maintenance tasks and the infrastructure tasks are going to be the same no matter how many people you have, and now you're sharing that. Yes, some of it is, you know, they're still going to have enough food and water and things like that up there. But I would expect you can start getting sort of this volume discount per se that you know,
Right.
on it. But you also don't want to send up that many people without knowing that you can do it and that they're safe and healthy and all that also.
Right.
Yeah.
I was having a conversation yesterday with an ECLIS guy, and we were just kind of spitballing. How do we move from 6 to 12? And it's pretty hard. And the food logistics and the environmental controls logistics are probably the hardest part because the technology is there, but food logistics and ECLIS look like really difficult problems to just get a common crew of 12 people at ISS or anywhere else, like the next space station. Sorry, I cut you off, Joya. What were you going to say?
Well, you know, just I guess as one point of reference, you know, like you say, certain things do scale. And so when we went for the commercial vehicle now that can take 4 astronauts instead of 3, as we had been doing,
right.
The addition of 1 extra crew member doubled the amount of crew time for science on space station. So that was huge. You know, we got all this new additional science time just by adding that 1 person, because, you know, all the maintenance tasks remained pretty similar. But then if you go, you know, from 7 to 12, well, then you do have increased maintenance and also a lot of increased, like, as you say, ECLIS load. So, yeah, it's a game of continuous trade studies, you know, and I mean, the system analysts are the most important people in this equation because there's just so many parameters to try to integrate and think about. So.
And your data is only, or your results are only as good as your data that you put in there. And so we have to almost learn more before we can get a really good answer. You can start getting a good answer, but you know, there's a lot of unknowns there.
I'm going to read a question from the audience. I don't understand this question, so you have to break it down so I can get it. But are any works proceeding to develop, and I hope I pronounce this right, mycelia for soils production? So first, help me understand the question and then answer it, please.
So mycelia are fungal, you know, strands essentially. So there's been some really interesting work in, you know, in just the general, you know, industry looking at fungal mycelia as ways to build things. They make packaging out of it. You can make household goods, lampshades. You know, fungus are pretty amazing organisms, and they're fairly poorly studied, but they're getting more attention now because they're they're the ones that can take you know, decomposing material and generate useful products. NASA in the past has funded research, you know, looking at, can we take inedible plant wastes like your leaves and stems of tomato and grow edible fungi to help supplement the food system. And, you know, I think in theory you can, in practice it's challenging like everything else. But the mycelia could also be used to make building materials for a habitat, or here they're discussing using this fungus to make soil, or make some sort of soil substitute. I mean, this is essentially kind of how composting works. Composting is sort of a suite of different organisms, fungi, bacteria, and other things that break down the inedible plant wastes and generate materials that plants can then use to grow from. So we are not actively working on this, but I think it's an area that does need attention, figuring out how to just take that waste. There's been work in the past on composting. There's been work in the past on leaching, using water to pull those nutrients out. Biochar, essentially making charcoal out of them, burning off a lot of the carbon, which you could then capture and use for something else, like fuel or atmosphere, and then taking the mineral residue that's left, and a lot of it's just figuring out what's going to be the most effective way, and then how do you get that back to the plants effectively? How do you dose your hydroponic system and get the correct amount of nitrogen when you're using compost? It's pretty complicated.
Yeah, it seems it. It seems it. Lee posted a question. Michelle, you used to work at Quaker Oats pet food division.
Yeah.
How is making food for puppies different from making food for astronauts?
Actually,
that sounds pretty crazy. I like that.
Yeah, and then between those two, I was developing rice mixes, which isn't quite as exciting. I used to say that developing the pet foods was in some ways very similar to developing a NASA food system, because if you are feeding your pets correctly, not giving them table scraps and human food, the food that the pets are getting is the only food and the only nutrition, and they have to eat enough, so the acceptability is there. And of course, much of the food is not left in the refrigerator or freezer. It happened that when I was at Quaker, I was doing both the intermediate moisture, the moist food, the bits, as if you look, and then the dry food, and so shelf stable. So very similarly, because again, they need all that nutrition, and dogs are not that picky when they eat, but cats can be. And just a quick note, Quaker had a kennel, an old mansion with 200 dogs and 400 cats. And I used to tell the vet that took care of these animals, and I used to work on a cat food for a while, and cats never liked my food. And it's like, if you come in one morning and all 200 cats aren't there anymore, you can blame me. So I was so frustrated. But no, it's very similar. Technically very complicated. So yeah.
In the one case though, it's a mass productive process, because you're not feeding 6 cats, you're feeding
Correct.
6 billion cats.
Correct.
So how is that different when you said, okay, how are we going to keep these very specific 6 humans alive versus the production? Like, I think scale changes and
it does. Yeah. So so instead of producing, you're right, and I don't remember the numbers because it's so long ago, but we had 4 very large extruders putting out. One of my projects in the beginning was Quaker's dog food kibbles and bits and bits and bits. And they had 4 extruders putting out the kibbles, the bits together, massive, putting in all this. NASA's food lab, which is not very large at Johnson Space Center, has 2 freeze dryers. They use a facility up at Texas A&M University for the retort, for the thermal process. And then they have a packaging room. And so they package, like the fruits and nuts and crackers and cookies, and I'll call them chocolate covered peanut chocolate, all are packaged at Johnson Space Center by hand. So it's a real, yes, the packaging
I assumed
equipment.
it was outsourced. It's done in-house?
Everything is done in-house these days, and most of it. Yes,
Okay.
there's occasionally a product that's come out, but as I mentioned, when we went through this sodium reduction project, and where some of the sourcing was coming from, like the freeze-dried camping food or the MREs, but both of those need very high sodium because you're either, trekking with the military or on a hike somewhere, backpacking. That's not what our crew members need. And so I haven't looked recently, but I'm guessing a massive percentage of the foods are either processed in-house or gotten from the grocery store or their distributors and then repackaged, because you may get a package of chocolate covered candies, M&Ms,
Yeah.
but you're going to put it into an individual serving size with, I don't know, 15 M&Ms in there, and then vacuum pack and seal it. But all of that is done in-house at the lab, because again, you're only feeding 6 people.
Yeah.
And actually you're not even feeding 6, you're feeding 3, because the international partners, or Russia specifically, is taking care of the other 3, give or take.
Okay.
It varies, but yeah. So there are people in the lab who are just devoted to production.
Huh. I don't know. I just never imagined that. I just figured it was outsourced somewhere. Like y'all did the science, but I didn't assume that y'all were doing the.
Yeah, it ended up. It's for a while there was some production done somewhere else. It's just easier with NASA's quality QA controls and everything else, that bringing it in-house was easier. Now, as crew sizes grow, that may change, but right now the facility is there.
That's really neat. Somebody's asking about bioreactors, algae, insects, nutritional yeast, that sort of thing. Is any of that stuff in development? Where are we at with that?
To my knowledge, it is not in development. It's being talked about, but as I mentioned, if we talk about, let's take algae, very healthy, but maybe you could take some algae and sprinkle it on your breakfast cereal, or something like that. But until we're on Mars, where there's 3/8 gravity, it is likely that you can't open the package enough to transfer some algae into there.
Okay.
And familiar food is so important. If they're not comfortable with the food, and you could say, well, they're up there for science, let them do it. I agree, but I've never, shuttle astronauts actually opened my eyes a little bit to that, because they had a personal preference menu, and they're basically on a camping trip for 2 weeks. And I'll say at least half the crew members were very strong in their opinions of what they wanted to eat on board. And, so I talk about it, and it didn't always go this way, but, you basically have 2 kinds of astronauts. You've got the military types and the civilian types. And though not always one-to-one association, I will say the civilian types aren't as willing to sacrifice their own preferences as much as the military folks might. And so think about a 2-week camping trip or a 2-week shuttle mission versus a 3+ year Mars mission.
Hold your breath for 2 weeks, right? As a former Marine, I can really appreciate where they're coming from. Like, okay, that's what they told me to do. That's what I'm going to do.
Right.
Yeah. Wow.
And even our own military don't eat MREs for more than, I think the limit is 3 days.
Yeah.
They are under requirements to set up a kitchen if they're on deployment somewhere and they're eating MREs.
Yes. So our partners in, the European Space Agency are doing some work with algae in the Melissa program, the Microecological Life Support System Alternative. So if people are interested, they can look up that work. And they have tested some of these algal bioreactors in space, but as Michelle said, NASA is not doing that. We have funded a small business that's working on duckweed production system for space. And again, getting these things palatable is critically important. You want something that tastes good, that they're going to want to eat regularly, because otherwise it doesn't matter how nutritious it is. If it doesn't taste good, they're not going to eat it, and they're not going to get all those nutrients. So,
Tim Chrisman asked a question in the chat, quote, "Did you say a mansion with hundreds of dogs and cats?"
I did.
Where is this?
So Quaker Oats, which is now part of PepsiCo, had its R&D facility in Barrington, Illinois, which is a suburb about 40 miles northwest of Chicago.
Okay.
And Barrington Hills is a very fancy part of Illinois, or that suburban Chicago. And it was an old mansion. And you could still see the dance floor. That's where I think the cats were housed there. But it was beautiful to go into. But they had bought the mansion and retrofitted it with cages for the dogs and cats, because similar to, where we did taste panels or sensory tests at the NASA Food Lab to test some of the new food items that we were thinking of, we would test the dog and cat food that we made in our pilot plants against the leading, competitor, and you put 2 bowls of food in front of the animal and see how quickly they ate and how much they ate, depending on, like cats, it was how quickly, and the dogs it was how quickly, and the cats were how much. But they were all there, and there was a vet and a whole team of people taking care of these animals.
That's kind of hard to imagine. I kind of feel like Dr. Doolittle's in the corner. So the last question I want to talk about is kind of this, industrial farming process, right? Like I want to see a lot of people, more than 6, somewhere in space. So Joya, you posted an image of a production facility, a farm. That's still a pretty far ways away, but we're starting to perfect that technology down here on the ground. There are vertical farms kind of all over the place. There's some that be considered in our city. How transferable is that technology to down here on the ground and useful to us right now?
Yeah, we work really closely with the controlled environment ag community. We go to the same meetings, and so we do meet regularly with a lot of the people in this industry. And there's a lot that's very transferable. There are things that NASA is doing that can benefit the industry, and there are quite a number of things that the industry is doing that can benefit NASA. Even things like, how do they make sure their seed sources are clean so they don't have disease outbreaks? If they had a disease outbreak in their plants, it could cost them millions of dollars. I'm just talking plant diseases, not anything that could affect humans. But I'm also I'm part of the Controlled Environment Food Safety Advisory Council, because I'm interested in what these industries are doing to ensure food safety and how we can translate it. And so I think a lot of it's really sharing knowledge. The development of technologies has been fueled by this industry, in terms of lighting for crops, sensors, control systems, automation algorithms. So I think there's a lot of good crosstalk from that, and that's going to really benefit this space exploration in the future.
Great. One last question. I've been curious about this. I've gotten food poisoning before. It's not very much fun. What happens? Have there been any sort of I know that folks, when they go to the station originally, a couple of days, they're feeling pretty queasy. But what happens when people have a real problem?
It's a good question. So for years, I used to say there's never been an incident of food poisoning. And at one point, and at one point, one of our astronauts, and I won't name him, said, oh no, Michelle, there has been an incident of food poisoning. It's like, really? And he never gave me the proof. He said he would go back to his logs to find out. But I here's my theory. There has never been an incident of food poisoning because of the food. Now, we very much, and this is why you probably got some food poisoning or other people do, we very much emphasize to the crew. If you open up a package, heat it up, hydrate it, you make sure you eat it. I always say 2 hours. It's really safe for 4 hours, but I always like to say 2.
Right, right.
And I am guessing that someone left their package out for too long. So yes, they had food poisoning, but because it wasn't due to the food system, we never heard about it, because I will guarantee you that if there had been an incident of real food poisoning on board, we would have heard about it.
Right.
It would have been like #1 high priority, tell us what's going on. And that never happened. There was an incident. The Europeans were providing some canned foods, actually gourmet foods, many, many years ago in shuttle for one of their European astronauts. And there was this film of white on the when they opened up the can. And we don't use cans, but they did. And it was like, oh no, what is this? What is this? Well, it ended up, it was just some fat that had floated to the top. But we heard about this immediately. And it, you know, like we had to do days of testing. So again, I think the NASA food team is extremely careful about processing or, you know, sterilizing the foods or making sure everything is clean. There's no, you know, packaging is tested. It goes through micro testing, sampling before it gets packaged, and then before it, and then after it's packaged. So all that's done. And so things are caught in advance. The crew is taught to look for cracks or open packages that shouldn't be open and don't eat them. So everything works, and that's why it's going to take so much more work as Joya's team starts with the plants, more plants, and sanitizing the plants. And then think about cooking in space. If they should decide to make a spaghetti dinner with pasta and tomato sauce, all of that is going to take a lot of training and potentially testing to make sure that they don't get any foodborne illnesses through that part of it.
It's amazing. Thank you so much, Drs. Pechonik and Masa. This has been really eye-opening to me. It's a completely new field. So thank you very much for your participation. I'm going to turn it back over to Lee. Hi, Lee. Welcome.
Hi, that was incredible. Thank you so much to all 3 of you. Great insightful questions and relaying of questions, and just the level of expertise and being able to talk about it so that we can all enjoy the topic. Really appreciate it.
Hey, Laura. Bye.
And good morning, everyone else. I'm Lee Steinke with Foundation for the Future, and I'm really glad to see you all again. We have a very loyal audience here, so thanks for being back. Next up, we have our special segment, What's Going On with Laura Forzik. What's Going On is sponsored this month by the charming and generous Terry Trevino. Mr. Trevino is currently completing his Master's of Science in Space Studies, Aerospace Science, and Space Operations. He comes to the industry after a career in real estate, and he has immersed himself in the possibilities and challenges of the industry. Terry, we're so grateful to you for your steadfast participation in Conversations for the Future, and now for this generous sponsorship. Thank you. If you're enjoying this event, everyone else, and would like to help cover the cost of this programming, simply add a sponsorship to your registration for our next event, or make a donation at www.f4f.space. That's the number 4. And now for what's going on. Ms. Forzik is the owner of space consulting firm Astrolytical, specializing in space science, industry, and policy, and offering space career coaching services. She is a NASA subject matter expert for planetary science missions and is also the primary author of Astrolytical Explore Flybys and Orbits Analytics, which I highly recommend. Ms. Forzik is also the author of the book Rise of the Space Age Millennials and is a frequent source for news publications, regional newspapers, and public radio. Laura, we'd have to be living under a rock not to know a little bit about what's going on right now, but you'll put it all in perspective for us. Welcome back, and what's going on?
Thank you, Lee. Thank you for having me on again. It's a pleasure. Yeah, so we're going to start out with the big news, but we're not only going to start out with it because it's the big news, but because I'm going to start close to home and then go farther from Earth. So that's my plan for this segment here. I'm going to go into a little more detail than I did last time. I hope you don't all mind. So yes, my phone has been ringing off the hook with reporters, journalists within the space sector, with outside the space sector, wanting to talk about this quote unquote billionaire space race. And what is missed in that conversation by outsiders is how we thrive in space, why suborbital spaceflight, human suborbital spaceflight benefits the space sector, benefits Earth. And so that is something I want to focus on initially, because this isn't just a stunt. It's not just an ego trip, although I will admit there was quite a bit of showmanship and quite a bit of egos going on with billionaire founders, right, as expected. But let me back up and tell you, for those who aren't too familiar what's going on, there was a flight on Sunday by Virgin Galactic. They flew a full crew of Virgin Galactic employees plus 2 pilots. Previously, they had either only flown just their test pilots or just their test pilots plus 1 Virgin Galactic employee, Beth Moses. And this time they flew 4 Virgin Galactic employees. One of them was Sir Richard Branson, who is the founder of the Virgin Group and Virgin Galactic. And he has been waiting, sounds like his whole life, for flying to space. And of course, Virgin has been talking about flying their own vehicles to space since I've lost track, about 17 years, something like that. So they had been waiting a very long time to fly their billionaire founder. And so they had a very successful flight. I don't know about you all who were watching it, but I was holding my breath, which then I let go with tears after they were successfully in space and then landed back on the ground. It's always very emotional, human spaceflight, right? And then coming up in about 7 days, that's the current plan. So on a symbolic day of July 20th, Blue Origin plans to fly their first crewed flight of New Shepard, which is their suborbital vehicle. So previously they have flown 15 successful or partially successful. The first one was partially and all the rest have been just fine. Flights of New Shepard uncrewed. And so this will be the very first time that they fly with people on board. Those people include Jeff Bezos, the billionaire founder of Blue Origin, and his brother Mark, and then legendary aviator Wally Funk, who also has been waiting her whole lifetime to go into space. She is a member of what we now call the Mercury 13, which is a group of women who trained to hopefully become astronauts during the Mercury program. It wasn't an official NASA program. It was outside of NASA because at that point, only military fighter pilots were allowed to be NASA astronauts. And so these women, although they were highly qualified, were not allowed to become NASA astronauts. And Wally Funk applied 4 times throughout her life. She's a spectacular woman. She never got her chance to be a NASA astronaut. So here's her chance now to fly into space. There is a 4th member of that crew of Blue Origin that won an auction for $28 million. No, Elon Musk is not flying on New Shepard unless I missed something. I would think that I would notice that news, but Elon Musk does have a ticket to fly on Virgin Galactic that he bought many years ago. Blue Origin has actually not flown, or they've not actually opened ticket sales yet. So these have been getting lots of headlines, right? People around the world are talking about this billionaire space race, right? Which is a bit silly way to phrase it because it's not necessarily about the billionaires on board. It is about, flying people for one thing, being able to have this technology. And both of these vehicles are still in their test programs. Neither one of them are fully commercially operational yet, except for uncrewed flights. So the uncrewed flights of New Shepard, I think they're considered operational, although I'm not 100% sure, maybe not legally speaking. but they've been operating for several years, both of these vehicles, with doing flights for, for Blue Origin had been uncrewed totally because that's an automated system. Virgin Galactic has been flying, again, with test pilots on board, and then flying payloads also for NASA and for other customers. So to do really great science. And that is something I want to stress, is that overlooked in this whole conversation is the science that's being done. So on Virgin Galactic's flight on Sunday, there was a experiment on space biology that was flown with one of the people on board, Sarisha Bamla, and she activated this experiment at certain points of the flight, which is something that is actually quite difficult to automate. It requires a lot of set parameters and instruments, and there's a real advantage to being able to have a human in the loop, have the researcher fly with their research, or a proxy, which is what we expect on the International Space Station. The astronauts doing research are proxies for the scientists on the ground. But imagine being able to fly scientists with their own experiments. And this is the plan. And so last year, NASA started up a program where they have decided to fly astronauts and people they select on these suborbital vehicles. So people they select so far has been one person, Alan Stern. He has been selected to fly on a NASA-sponsored Virgin Galactic flight in the future to test some scientific instruments and payloads. And then also their own astronauts. So there's something called the NASA Subsea program, which is not well advertised because I don't know how much they've done with it. Subsea stands for suborbital crew, and it's a way for NASA to train their astronauts using suborbital vehicles, which are more affordable and, in theory, higher cadence, so they can get more spaceflight experience before they go into orbit or before they go to the moon. And so this is the program NASA started up last year to, in theory, when these flights become more operational, just put NASA selected astronauts on board to train them. And so not only do you have the option now of flying scientists with their payloads or scientist proxies doing research in space, but also flying NASA astronauts to train them. So it's really not just about the billionaires and the egos, it's also about really practical things we can do. But let's also talk about you and me, because I'm sure that a lot of you are like me who also want to fly on these vehicles. Yes, I'm a scientist, but I also want to go for that experience, right? And so what about people like you and me? Someone just asked about the price. Yes, so Virgin Galactic had initially started selling their tickets for $200,000. They raised it to $250,000, and then they paused ticket sales with the intention of raising that price again, an undisclosed amount. They have not done so yet. Blue Origin has not yet announced their ticket price. That first auction for the crewed flight that's happening in a week sold as a charity auction for $28 million plus a 6% fee for the auctioneer. And so we don't know. We can certainly guess that it's not going to be that high of a ticket price when they start actually selling, but we don't know what kind of data Blue Origin got from the people who were bidding. So my guess is that they are going to use that data and say X number of people were bidding this range, and therefore it's safe to have our pricing at this range. I think that's the smart thing for them to do, but they have not announced that yet. So we can guess it's going to be in the range of what Virgin Galactic is, somewhere in the $250,000 is my guess, maybe even higher. If you compare that to orbital spaceflight, it's $55 million to go to the International Space Station with Axiom Space. I don't know how much it is with Space Adventures. They work with the Russians with Roscosmos. And SpaceX sells free-flying missions like the Inspiration 4 mission that is going to take a crewed Dragon and go around the Earth. And we don't know what those ticket prices either are. And they haven't disclosed that. And so it's just going to be a lot of time until people like you and me can start flying with our own money. That doesn't mean that we can't go up sooner, because there's competitions and contests and sponsorship available. Right now, Virgin Galactic announced on Sunday they have partnered with OMAZE, OMAZE, to do a charity for a group called Space for Humanity, so that you can go online and donate money to get entries into winning a trip to space through Space for Humanity. Space for Humanity has been around for a few years. They also intend to fly people with their own sponsorship money in other ways. So that's one way that you could be sponsored, is by winning a trip that way. And there's other groups like that that are doing sponsored trips. There's also research flights. So I mentioned Alan Stern earlier in the conversation. conversation, his employer, Southwest Research Institute, actually bought 3 tickets for their for 3 employees on Virgin Galactic. And then back, if you remember the days of XCore, they bought tickets on XCore. There's other research institutes that have bought tickets. My friend Kelly Girardi is going to go up with a research institute on Virgin Galactic. And so this is the kind of thing that we can think about to get people beyond the billionaires, beyond the ultra wealthy, to get to space initially. And then the price, in theory, will come down, just like how a century ago, aviation was immensely expensive. And so because it was brand new, right? The technology just wasn't proven, it wasn't there. The business hadn't been, it just isn't where it is today. Now, that isn't to say the airline industry is very stable today, but at least you and I can afford a flight if we want to buy a ticket to space. And I can't keep up with the chat, I apologize. But in any case, I did want to move on to other topics though. So talking about suborbital space or any kind of space flight, we can imagine that space is going to get more and more crowded. And I'm talking here about suborbital and orbital particularly, and lots of more launches. So we can see already how much SpaceX has increased the launch cadence just globally. I don't know if I don't think they've beaten the number of launches that China has launched yet, but SpaceX by itself is the #1 launch provider for the United States, with with its Starlink launches mostly have added to that cadence, but also with other launches as well. And so with the increase in the amount of launches, both orbital and suborbital, we need a way to work with the other people who use the airspace, and that is the airline industry. And so back in June, there was a hearing held in the House where this was a topic of conversation of how do you get the airline industry to be happy with the restricted airspace of spaceflight, of the range. And this was even something that was bashed by Elon Musk in a tweet recently, where there was a wayward aircraft that delayed a flight. And so finding ways to work together and to communicate better with the airline industry and the space industry. And so the FAA just announced that starting at the end of June, they've finally started something called the Space Data Integrator. They've been working on this for a few years, and it's a way to reduce the amount of time that the airspace is closed off to aircraft that are typically using it. And so if you're in the middle of nowhere, right? If you're in New Mexico at Spaceport America, this might not be an issue. But if you're launching from Cape Canaveral, which is somewhat near Orlando, not too far from other hubs like Miami and Tampa, I mean, you can imagine how the airspace is crowded. And then there's like spaceports that want to operate at actual airports. And like the Denver airport, for example, they want to, somebody was talking about making them to a spaceport. And so you can see the ways that traffic needs to be integrated. And in fact, we've seen, I mean, by we, I mean my company Astrolytical has seen how at the Cape, there have been delays due to the number of spacecraft launching, the manifest in the range, just the amount of spacecraft that's launching from Cape Canaveral. And by the Cape, I mean Cape Canaveral Spaceport Station and Cape Canaveral Kennedy Space Center. Just both those areas launch so much that there's actually delays due to how many groups want to launch, how many different organizations, whether it's companies or NASA, Air Force, whoever, they all want to use that area. So then you add in airspace and it's just very crowded. So finding ways to work together with all the users of the air and space is very important. Moving on a little bit, because it's not just about these big names, right? It's not just about SpaceX, also Virgin Orbit and these other smaller launch companies. Now, Virgin Orbit, not to be confused with Virgin Galactic, same group company, sister company, but Virgin Orbit just had their second successful launch of 7 satellites, 12, I've actually forgotten, but a number of satellites for various customers. They just had their second successful launch, and we are going to see, hopefully, Virgin Orbit increase their cadence. And there's quite a number of small launch companies that are at the verge of being operational. Astra, which just went public, almost reached orbit. They got to space with their last flight, but they didn't quite reach orbit. But they're going to start being operational pretty soon, I would bet. There's other groups like Firefly and Relativity. I mean, there's just so many. I can't even name them off the top of my head. There's these groups that are going to be coming online, and that brings me to opening access to more groups, right? And so this is a debate I'm having in my own mind, where Astra, in their paperwork to file to become public, they talk about how they want to increase their launch cadence to 300 launches a year, which I don't see the demand there. I'm not going to get into an argument in this talk. It's a separate conversation, but you can imagine that increase of cadence if they were to technologically get to the point where they are launching almost daily. How does that open it up for customers? What kind of customers then would come on board? What kind of customers that hadn't thought about space before, thought space was rare, or thought space was extremely expensive, might come on board? And this is speculation on my part, because we haven't seen a large increase in demand, even with SpaceX launching so much. But imagine a future where there is that much. I mean, that's sort of on us, right? To tell other industries and to tell our partners and collaborators and customers that, yeah, there's these opportunities for you to go to space more affordably than you could in previous years. So all of that is coming on board, hopefully, in the near future with Virgin Orbit here, a little bit of a head start with these small launch operators. And of course, Rocket Lab, we're still waiting for them to come back after the last accident, but they've been launching for a few years now. And with all these launches and all these satellites that are going up, we need to think about being responsible stewards of our environment. And this has been on my mind quite a bit, because I just finished up the Brooke Owens Fellowship Summit with my team. I was a coach this year, and my team of undergraduate students, they came up with a concept to clean up space. Just they take a net system. I think they were talking about a magnet, but they got rid of that. But harpoon, satellite servicing with refueling, they called it Swiss Army Sats. It was just a way for undergraduates to start thinking about tackling some of the challenges. And the challenge here is the sheer number of satellites that are launching and are planned to launch. And there's companies like Astroscale and Northrop Grumman and other ones that are working on this. And so Astroscale just announced that they have opened up additional ground stations around the world. And this is important because this is a global problem, right? Astroscale itself is an international company. It's based in Japan. There's a headquarters here in the United States. Just thinking about this internationally, we need to work together with international partnerships to figure out how to be responsible stewards of the environment. And some countries are more responsible for the current state of the environment than others, the United States being one, where we have done quite a bit in past years to create space debris or leave dead satellites or leave spent rocket boosters. We need to be responsible for what we've done and make sure that we can still operate in space. Because if we have all of these satellites up there that might be up there, maybe it's low Earth orbit and they'll deorbit in a few years, maybe they're up in geo and they're up there pretty much indefinitely. And we need to figure out how to work with that. And thankfully, there are a lot of groups coming on board to try to think through this problem, but it is an international problem, which is something I want to emphasize here, is really being able to talk about this internationally. And the reason why I'm stressing this is because in a recent hearing with the Senate, I believe, Bill Nelson, the new NASA administrator, talked about how he wants to make the Wolf Amendment permanent. And for those who don't know, the Wolf Amendment restricts the ability for the United States to work directly with China. It is an amendment that was put in place by a congressman who didn't want the United States to be working directly with China, except in cases where Congress and the FBI gives a waiver. And so there was a question asked during this hearing, do you want this? Do you think that this should be a piece of legislation? And Bill Nelson said yes. But he did add a but there. There are places where we should be working with China, and that is making sure that we have space situational awareness and global responsibility for space debris. The United States and China and India have been responsible for anti-satellite tests, kinetic ASAT tests, where we have created space debris, China being, I think, the worst of them. And so there's an area where we need to make sure that we are responsible stewards of our environment moving forward. And moving forward beyond Earth, I want to talk about the moon in our last few minutes. So the moon. We have just announced maybe a week ago, NASA finally put out their next step N, which is the Sustainable Human Landing System Studies and Risk Reduction solicitation. And these are really small awards, up to $45 million. So this is not something big and gigantic simply because NASA doesn't have the funding yet, but this is NASA thinking beyond Artemis 3. And you might remember the whole controversy with the HLS Artemis 3 award, where it was awarded to SpaceX, and and everyone thought that there would be 2 awards, and SpaceX was the only awardee. And now there's all kinds of talk within Congress about how do we fix this? How do we give NASA the money or force NASA to award a second contract, presumably to Blue Origin? And NASA is currently officially waiting for Government Accountability Office, GAO, protest decision, which should come in a few weeks, just the beginning of August. But while they're waiting, they're also assuming that SpaceX is going to be the final winner of this and that the protests will come to nothing. The protests were by Blue Origin and Dynetics, the 2 other competitors. And they're also thinking ahead to what happens after this award, what happens later. So they're planning their Lunar Exploration Transportation Systems, is that the S? Let's program. And so they have issued this solicitation here for the next round. And again, the next round is not something that is a full contract. It's only up to $45 million. It's not enough for a provider to actually get to the moon, but it's a next step forward. And it's up to Congress to then give NASA the money to actually be able to move forward with 2 providers for the human landing system. And there was discussion yesterday. There was a House Appropriations, Commerce, Justice, and Science Subcommittee hearing yesterday, or markup, that talked about a bill which would give NASA more money than NASA has asked for in the latest presidential budget request. And I think even more money than the Senate wants to give them, but don't quote me on that. And so that bill went through, it got passed. Now it needs to go to the next stage of the House, and then it needs to be reconciled with the Senate. You know, you've got a process, but that's a good sign for NASA that Congress still wants to give NASA more money than it asks for. Silent in that bill, though, is the HLS issue, and that was brought up yesterday in the hearing. I forget which congressman mentioned it, but he talked about how we need to give NASA direction on HLS. We need to figure this out. And so that's still an open question. I'm sorry, I don't have a final answer for you there because it's just not decided. But I did want to stress some other things that are going on the moon that are less talked about. And that's the commercial lunar payload services and the satellite relay network. So CLIPS, you might have heard of that, commercial lunar payload services. There have been 6 awards to 4 companies so far. Let me see if I remember. Astrobotic, Intuitive Machines, Firefly, and Masten Space Systems. And they're going to be delivering payloads, rovers, and landers on the moon. And this is really, really exciting because it's not NASA hardware. If you remember back in the Apollo days and not too far ago, it was all NASA hardware. But this time, NASA's buying these services. NASA's talking about buying services for space suits and this kind of thing. And then I'm running out of time, so I don't want to go too far into this, but NASA's also talking about a relay system on the moon for communications, and they're calling that LunaNet. And they're working with the European Space Agency on a similar program called Moonlight. And so all of this is finally happening. We're finally getting lots of activity on the moon. And I could talk about the Chinese, Russian plans to put a lunar base, which you could ask me in the questions if you want, but but I think I've run out of time. So I'm going to stop here. I think we have time for maybe a couple of questions.
Laura, this What's Going On segment with you has been one of my best ideas. So thank you. I wonder, we had a question in the chat from Jordan Melagrana, a good friend to our organization. He wanted to know, is it more likely that we'll just be doing these tourism flights just to enjoy the view, or are we really going to start getting to other places on the globe more quickly through these suborbital flights?
Yeah, it's going to start with the former, and then I anticipate it'll go to the latter, but it's going to take time. Yeah. So it needs to be proven safe. So that means a lot more flights, and they're not even commercially operational yet. Virgin Galactic did not fly any paying customer humans, like paying customer, like payloads. And Blue Origin, you can consider this next flight to be a paying customer because whoever it was won an auction, but they haven't opened ticket sales yet. So give it some time, give it a few years for these things to be operational, to go up and down, and then we can maybe see it happening within the United States. When you're talking about regulations for this kind of thing, I'm not going to get too far into like the learning period indemnification kind of stuff, but right now the FAA cannot really regulate this as well as regulates airlines, and so that probably needs to change before it starts operating like an airline. And then if you're talking about internationally, there's even more complex regulations. So yes, I think that'll happen, but give it a few decades. It's not going to happen immediately.
Decades, okay.
Decades, yeah. Mm-hmm.
So Given what you know about the analytics that you follow, you've talked about market price and the research that an auction will yield, but talk about what you think would be a profitable price for these companies right now or say in 5 years.
Yeah, I have no idea. I mean, I'm not
Yeah.
privy to the information that these companies have on how much it costs and what the fuel costs are and what their how they need to refurbish their equipment and the labor involved. I have no idea, but I can imagine that they're hoping it'll go down in price, and it'll eventually need to be that we don't have an entire mission control for each launch, right? It'll
Yeah.
need to be more automated than that as things come down in price, and I don't know the time frame of that, nor could I tell you what they're making for each flight. I have no idea.
All right, thank you. I want to just, you brought up sustainability, great discussions last month on that, and we also have a September event of Conversations for the Future, which is about space sustainability, garbage and recycling. And why don't you tell us just a little bit about Astrolytical's flybys and orbits before we sign off?
Sure. Yeah. So if you go on astrolytical.com right now under Explore or Explore Analytics, you'll be able to see some of the offerings with the flybys. They're just little mini reports on certain topics. Right now, it's mainly space tourism and launch delays. And then you also might see on the top right there a way to sign up for our new newsletter. So if you like this What's Going On segment, in the newsletter every month, you will get not just the news, but what it means and what, how it all fits together and the insights and the analytics that go into there. So you can sign up for that. I think I was trying to read the chat, but it went by too fast. Someone talked about the coaching. And so if you're interested in space career coaching, it's right there on the Astronomical website. Almost 50 coaching clients so far, various levels of experience, some as students and some as, essentially retired people who want to switch careers, coming from all different industries, because space is for everyone. That's something I talk about a lot. It's not just for scientists and engineers, it's for every type of person out there, every experience level. And so contact me if you're interested in that. Follow me on social media, on Twitter, LinkedIn, and contact me with any questions. Really, I'd love to hear from you.
Thank you so much, Laura. Really appreciate it and can't wait for next month.
Thank you, Lee.
All right, next up, we have a dynamic duo. The incomparable Frank White, who appears to be joining us from space, understands how much people love space. But then Rod Pyle will remind us that space hates people, a line from his recent book, Space 2.0. Frank White is the author of The Overview Effect, Space Exploration and Human Evolution, and The Cosmo Hypothesis, Implications of the Overview Effect. He is also the co-founder of the Human Space Program and teaches at Boston University, Kepler Space Institute, Harvard Extension School, and Harvard Summer School. A film called Overview, based largely on his work, has had more than 8 million plays on Vimeo. Frank is a magna cum laude graduate of Harvard College, a member of Phi Beta Kappa, and a Rhodes Scholar. He earned an MPhil in politics from Oxford, where he was a member of New College. Frank, thank you for being here with your friend Rod. Rod Pyle, thank you. Rod Pyle is an author, journalist, television producer, historian, and editor-in-chief of Ad Astra magazine. He has written 17 books on space history, exploration, and development, including Space 2.0, Innovation the NASA Way, Missions to the Moon, and Destination Mars. He has written for NASA's Jet Propulsion Laboratory, Caltech, Wired, Popular Science, Huffington Post, Space.com, and many other periodicals and websites. Rod also co-authored and lectured for the Apollo Executive Leadership Program for NASA's Johnson Space Center and the conference board. Rod, it's great to see you. And Frank, the screen is yours.
Okay, thank you so much, Lee. Let me do the hardest part of today's presentation, which is, of course, sharing my screen and getting the PowerPoint up. Hang on. Okay.
There we go. Looks great.
Yep. The beginning of every Zoom meeting. Can you see my PowerPoint? So here we go. Fortunately, I guess everyone can. Hang on just a minute. All right. Now, this is a session on thriving in space, and our topic might seem counterintuitive. Space hates people, but people love space. I think as Rod and I unpack this concept, you'll see what we mean and you'll see why we're talking about it. You know, I was really impressed with the first two presentations, and I really think they kind of summarize what we're talking about, because that whole discussion about food and supplying the astronauts with food, that could have been called uh, space hates people and people love food. And so therefore we must supply them with food. But think of all the complexity of doing so, all the challenges of feeding people when they're even in low Earth orbit. So that could have been the title of that talk. And then when we listened to Laura updating us, it was really all about how much we love space. And I really feel that this simple sentence summarizes where we are today. I have to give Rod credit for starting this whole dialogue in an essay he wrote. And the first sentence of that essay was, space hates people, period. And I added to it, but people love space. And that's what we've been talking about. And I'm just really delighted to be here with Foundation for the Future to talk about it today. And Foundation for the Future and the Human Space Program, really, we're on the same path. We're on the same launch pad. So we totally support you and are happy to be here for this conversation. Well, it's already been set up, but I had to add a slide today, a new normal. We cannot go any further without talking about what happened on Sunday. Khalid is a singer who was at the spaceport when Sir Richard landed with his crew, and he sang a song called The New Normal. We're only 2 days into it or 3 days into it, whatever it is, but it's different today. And I think the meaning of it is going to sink in over time. For so many years, and I'm old enough to tell you it's a lot of years, for most of us, the idea of leaving this planet was beyond us unless we had some superhuman capability and we were good at math and science. I went to Harvard because there's no math requirement. And that was the beginning of the end of my astronaut aspirations. Even though I, like many of you today, wanted to be an astronaut, now we can. We really can. The only thing stands in our way is money. It's not being really incredible at what you do. And it's just a great example of how much people love space, that there are 600 people who have signed up to fly on the Virgin Galactic flight. My picture is of one of the very first versions, not the beautiful, sleek spacecraft we recently saw. I will say I did interview Sir Richard for my book, and he's very clear. He wants to democratize space. We came up with a phrase in the chat, space for all and all for space, kind of like all for one and one for all, the Three Musketeers. Sir Richard's into that. That's what he wants. He wants people to experience the overview effect. He wants them to come back and be environmentalists. And it's no accident he's supporting Space for Humanity. And, full disclosure, I'm on the board of advisors. It's an incredible organization. And the whole idea is to take this view, this special view that the Unity 22 crew had, and bring it back to Earth, bring it down to Earth to make the world a better place. But as they say on the TV when they're trying to sell you something, but wait, space hates people. What are we going to do about this? Think about it. Homo sapiens evolved, and we are Homo sapiens. We evolved to flourish on 30% of the surface area of this small planet called Earth. A lot of people say it should be called water because 70% of it is water. We can't even go into the water without special equipment, or we can't go under the water without it. We're the third rock from the sun. We're at the edge of the Milky Way galaxy. Once we go to 50 miles above the surface, as Sir Richard and his team did, or 62 miles, as Jeff and his team claim they will, it's not possible. We can't survive. We can't even climb Mount Everest without special equipment. So we're actually confined to a very tiny part of our own home planet. And I'm going to tell a joke, please forgive me, but when I was listening to the food conversation, I was reminded of the old joke about the restaurant on the moon. Great view, no atmosphere. Now, it's a terrible joke, but again, it summarizes, you're on the moon, you get the overview effect, you see the Earth as a whole system, completely interconnected and interrelated, everything, we're all in this together. But if you walk outside of this mythical restaurant, there's no atmosphere. Once again, we want to experience the overview effect, but we can't do it without special equipment. But let's go back. People love space. We love astronomy. We love science fiction. We love spaceships. We love launches. We love the whole idea of living on other planets. We're already in space, but that's not what we mean. We're on a spaceship. We have our own spaceship already, but we want to go off of it. We want to go into space with a capital S. It's a mythical, mystical place. We want to go there. We love it. So what's this all about? Is it a contradiction in terms, people? A contradiction in terms, I looked it up. It's a statement or group of words associating objects or ideas that are incompatible. So is space and people incompatible, or is it unrequited love that we're talking about? I bet everybody in this audience has experienced unrequited love, though you may not have experienced space. And that is love that is not openly reciprocated or understood as such by the beloved. So maybe it's unrequited love, or maybe it's just opposites attract, like my picture here. Whatever it is, something's got to change if we're going to realize this love that we have. Are we going to have to change for our love of space with a capital S to get it to be returned? When I was growing up, I experienced quite a lot of unrequited love, to be honest. And during that time, there was a song that was popular, and it was called "Do You Love Me Now That I Can Dance?" And, actually, when I was growing up, you really did have to dance, be able to dance to be loved, to be honest. And that song kind of captured it. I'll change. I'll learn to dance if you'll love me. And in my book, The Overview Effect, I talked about the possibility that Homo sapiens is going to have to evolve into Homo spaciens, either through adaptation to the space environment or intentionally, in order to really realize our love of this idea. The other thing Homo sapiens likes to think about is changing the environment. And we already have a lot of talk about terraforming, for example, on Mars. So, hey, I don't want to change. I'll change Mars, make it more like Earth. I don't know how you feel, but I get kind of antsy about that. I think Mars is an amazing, beautiful planet. I'm not sure when I migrate off of the Earth, I want everything to look like the Earth. I mean, I want to survive. I want to thrive, as the topic of the meeting, but do I want to make everything like Earth? Do I want a Mars Mart on Mars? I'm sure Walmart would love to do that, but is that what we want? Well, these are ethical questions, not really our topic today. Maybe our love is just a mystery. I don't know. Maybe we, those of us in this movement, we're always trying to explain to the doubters why we have to go, why we should go, the whole point of it. We try to explain this love affair, but maybe it's just a mystery that we can't explain, like human love. I don't know. Can you explain the love you have for your spouse or for any other aspect of your life? Maybe not. Well, Lee, I could end it here, but that'd be kind of boring. Let's try to explain it. Okay. Let's see what we can do. And if you've been in this movement for a while, there's 20 explanations, there's 30. We've tried them all. Most of them don't work with the doubters, but let's try 5. Serendipity is 1. Evolution is 2. It's in our DNA is 3. We got to save the Earth is 4. And one of my favorites is the Cosmo hypothesis. And this is the tip of the iceberg, but let's try it out. And then Rod will come and he'll shoot them all down. Here we go. So serendipity. This is my favorite in a way because it's all about the overview effect. I had a great conversation with Don Pettit at Johnson Space Center. He's the oldest active astronaut for NASA. We talked about exploring, and you never know what's going to happen when you explore. And he said, you can't say on February 29th, 2030, we're going to have a big breakthrough that's going to be worth all the effort. You can't do it. But that's what people often want. The overview effect is a case in point. People did not go, the NASA astronauts and the Soviet cosmonauts did not leave the planet to experience the view. The first astronaut I interviewed for my book was Joe Allen. Now, he was a shuttle astronaut, but he worked on Apollo. He said, with all the arguments pro and con for going to the moon, no one suggested that we should do it to look at the Earth, but that may in fact be the most important reason. I fundamentally believe it was. We could talk about that a lot more, but I believe the overview effect is probably the key to our survival here on Earth, because this blue marble picture, which has been seen by millions, it shows the Earth for what it really is. It shows us our spaceship. It shows us where we are in the universe and where we're going. We're on this interconnected, borderless planet, and we're all in this together. The astronauts keep coming back and telling us this, but it's awfully hard for us to grasp it. So serendipity, who knows? If we keep pushing these boundaries, who knows what we're going to get out of it? We don't know. And yet that's a good reason to do it. Evolution. A species has to evolve or become extinct. So does the society. Extinction is a lot more prevalent on planet Earth than we like to think about, because our species has survived so far. And there is social evolution, there's political evolution and economic evolution, as well as biological. But if you look at this as systems theory, which is what the overview effect theory is, evolution happens when you enter a new environment, you take in new information. That's what we're doing. We're entering a new environment. It's full of new information. It's mind-blowing what happens when we leave this planet. And that's good. That's a good kind of mind-blowing, and that's going to force us to evolve. A lot of what was talked about before I started speaking is about that. We've got to evolve. We've got to try new things if we're going to survive. And I believe the overview effect is the elephant in the room for humanity right now, because it's mind-blowing what the astronauts are seeing. And pretty soon, non-professionals like me and you and Rod and Lee, we're going to have that experience and we're going to bring it back, and we don't know what's going to happen with it. Number 3 is the explorer gene. I read a Nat Geo online article some years ago that made the amazing suggestion that about 20% of any population actually does have an explorer gene. It's also a risk-taking gene. Many of those who have this gene don't survive because they take too many risks. It's not a completely 100% good thing to have, but the article also points out that just because you have it doesn't mean you'll do anything with it. Society's got to support the expression of the gene, but if society does, it will be acted upon. People in our movement like to talk about it's in our DNA, but it actually might be. We might be programmed to evolve from Homo sapiens to Homo spaciens. Space with a capital S might actually be calling us to leave the planet and to evolve in this way. And if you have the gene, maybe you can't explain it, but you got to do it. And it could be that you won't go into NASA or become an astronaut or buy a ticket on Virgin. Maybe you'll become a researcher in medicine, or maybe you'll become an incredible meditator, but you're going to be an explorer. You're going to leave the well-worn path and take the hero's journey, as we call it. A lot of people talk about saving the earth. We have to save the earth. I don't think we do. The earth's been here 4.5 billion years. I think we're saving ourselves. We're saving our terrestrial civilization. Back in the 70s, many of you may have heard of limits to growth. There was a study done showing that our civilization had a choice, that we were potentially reaching the carrying capacity of the earth, and we were headed for what they called overshoot or collapse. In 2004, they updated the book. Instead of saying maybe, they're saying we have passed overshoot. Think about it. We're living on borrowed time, according to some researchers. When those studies were being done in the 70s, not one person suggested leaving the planet to help with this problem, except Gerard K. O'Neill, to my knowledge. One of my mentors, one of Jeff Bezos' mentors, and he started talking about the fact that the limits to growth scenario was intolerable. And in order to deal with it without expanding outward into the solar ecosystem would require the kind of government economic control that nobody really wants. I hope Jerry is receiving the the recognition he deserves now. Many of you may know that Dylan Taylor and Multiverse Media recently put out a film about him that you should all watch. And you should watch it in part because Jeff Bezos is definitely interested in the scenario that Jerry put out. I believe large-scale space migration will help restore the planet to some kind of sanity in terms of sustainability, which I think we're all in favor of. Finally, the Cosmo hypothesis. In my book, The Cosmo Hypothesis, I tried to come up with a new philosophy of space exploration. I realized most philosophies of space focus on benefits to Homo sapiens. And I started with, well, gosh, isn't it remarkable that after 4.5 billion years, we have this group of this species that actually can leave the planet. It didn't have to turn out that way. We could have ended up like the dinosaurs, who apparently turned into birds. That was their way to avoid extinction, but who knows what we would have become. But a number of space philosophers, and I'm not alone, I mean, starting with Carl Sagan, have talked about us as the universe being aware of itself. We can bring life, intelligence, and self-awareness to other parts of the universe. And, in overview effect, I talked about a mythical fish called the explorer fish. And one day this fish was swimming around and plopped up on land by accident, serendipity. Land, wow, this is weird. Air, this is really weird. I can't breathe it very long. And the explorer fish went back into the ocean and tried to explain to the other fish what land was. Land with a capital L. And they said, wow, that is so brave that you did that. Gosh, we're glad you're okay. But we have a lot of problems in the ocean, and we shouldn't go back onto the land till we have solved the problems of the ocean. I think let's start with the sharks. We really we can't afford the effort it would take to go out there in large numbers. Well, the fish have done that, and there is a strong scientific belief that we ourselves are descendants of mammals or fish who came out of the water. And the explorer fish could not have any idea what larger evolutionary purpose they were serving. And maybe we don't know either. But maybe we are serving a larger purpose in terms of universal evolution. Again, only one way to find out. But anyway, space awaits us no matter what, whether we know the reason or not. And maybe it doesn't matter. I was at a dinner at Harvard. We were talking about issues like this, and one of the people at the dinner said, Frank, don't you know the universe doesn't care about us? It doesn't know about us. It has no interest in us. And I said, how do you know? And it was time for dessert. There was nothing more to say because we don't know. Sir George Mallory was asked why he wanted to climb Mount Everest at a time when climbing Mount Everest was a lot like what we're about to do. Mount Everest hates people, I think. Scott Parazynski is the only astronaut who's ever summited Everest. And when I interviewed him, he told me it was a lot scarier to try to climb Everest than to go to the ISS. And so they asked Mallory, why do you want to do this? And he said, because it's there. His body was found on Mount Everest. We don't know if he summited or not. We don't know if he died on the way up or the way down, but he did it because it was there. And I love, President Kennedy and Apollo are historically connected. And President Kennedy paraphrased that at his famous Rice speech. And in his inimitable Massachusetts accent, and I live in Massachusetts, he said, we go to space because it's there. We choose to go to the moon and all the other things. And that was a great speech. But he went back to Mallory and compared ourselves to him. So we're already in space, but we're not in space with a capital S. That's what we want to do. Whether it's a mystery or whether we can explain it, some people are going to go. I think I will just stipulate that, as the lawyers say. There's about 8 billion people on Earth. That's one reason we think we're beyond the carrying capacity. I told you I went to Harvard because they had no math requirement. So these numbers could be wrong, but I think 20% of the population is 1.6 billion. That's the explorer gene. Let's say 10% of that is 160 million. I think I can say without fear of contradiction that as far as this equation goes, space hates people and people love space, it's going to balance out on people love space. We are going to go. And I'm going to close with a statement that former astronaut Sandy Magnus made when I interviewed her. I said, where's all of this going? Are we going to make it out there? She said, humans are incredibly adaptable. We will adapt and we will thrive, which goes back to our topic today, because that's what we do as a species. And I love this picture because I think a lot of people said to me that, Sir Richard was like a child. He was childlike in his enthusiasm. And after he came back, and I think we are, all of us, no matter how scientific we are, how technologically advanced we are, space with a capital S creates a childish or childlike enthusiasm that is key to our survival. So I'm going to stop there, turn it over to my friend and colleague, Rod Pyle. And I want to say, just before we start, I really appreciated Laura saying that let's get rid of this space race thing. That's not what's going on. That is so trivializing of what's going on. But Rod and I actually are in a space race. And essentially he's won, but I keep trying. And that is, who's going to write the most books about space?
Well, yours are longer, Frank.
I don't know about that, but I keep trying to catch up, but it's hopeless.
Yeah.
So anyway,
I don't know.
I'm going to concede that, but I'm going to concede the race, Rod. But yeah, tell us about the challenges. I've tried to close on the We Love Space, and tell us about the other side of the equation.
All right. Well, thanks everybody for having me here. It's a great honor. Frank, great talk. I suggest we solve our problem by just making a pact that we'll only write books together from now on. And then nobody can get ahead of the other. Can I have screen control for a second? I did, contrary to my indications to you, I did make a small PowerPoint because I'm tired of Frank having all the cool hypotheses. So I came up with kind of a lame one. So let me see if I
can we make him the co-host? Do I need to do that, or can Lila do it?
I think it may just,
there we go.
Can you see my screen?
Yeah.
Okay. Now I need to figure out a way to get it started. Okay, here we go. All right. So I came up with the siren principle. As inveterate sailors of distant seas, we are drawn to hazy shores, even once their true nature becomes apparent, which is not always attractive. And this is not meant to be in any way a sexist illustration. It's just a nod to the ancient Greeks, who, of course, being ancient Greeks, thought that mythological, wonderfully gorgeous and engaging women would sit on the shore and call to their sailors and then turn out to be awful things like harpies and devour them once they got there. We know that's no longer true, but we do find this metaphor operating across space. It calls to us in the most seductive way. And once we get there, we go, hey, this place is kind of nasty. So I would also say this, of the siren principle, the grass is always greener until it's not, and it's red and horrible. And here's Venus with all the trees burning down, if they ever had any. I'll get into that in a minute. When I was a kid, Frank and I aren't very far apart in age. When I was a kid, the space age was yet to begin when I was very young. So up until 1965, while over the early part of the 20th century, the solar system had begun to recede away from us in terms of how welcoming and verdant it was, we still had this idea that especially from the age of Percival Lowell in the early 1900s on, that the rest of the terrestrial planets were just kind of like Earth, but not as pleasant. Mars was drier, but it had water on the surface. There were forests growing there. There might be eight-legged thoats running around if you follow Edgar Rice Burroughs, but it was still a place that people could go. The atmosphere might be half that of Earth's, but it would be like breathing on top of the Mount Everest that Frank was referring to. And it would be okay. You just need an oxygen mask and a down jacket. Everything will be all right. Venus, on the other hand, being closer to the sun, but almost Earth's twin, about the same size, about the same gravity, just a little warmer, was probably a swampy planet. Some people hypothesized there might be dinosaurs roaming around there. That was a bit of a stretch, but it's probably a swampy, warm planet. We couldn't tell because it was underneath this huge opaque cloud cover. Well, starting in the 1960s, we sent probes to these planets. Venus turned out to be incomparably hot, 900 degrees plus on the surface. And we would later find out that it had acidic clouds of chemicals hostile to human breathing, and there was no way we were going to survive there. So our friendly solar system began to change. Mars turned out to be a rocky, arid place. The first views of it were not like this. There were black and white photographs of craters, and it looked an awful lot like the moon, and it was unpleasant as hell. Why would we want to go there? Venus turned out to be, as I said, a fried, roasted environment with acidic clouds and hostile in every way to life as we knew it. And the news just got worse and worse and worse as we moved into the 70s and 80s. So nobody would want to go to those places. It just didn't make sense. All right, that's the end of my PowerPoint because I'm not as productive as Frank is. So if I might just go for a couple minutes, I want to address some of those points. I'm not as much of a hard nose as I may have been made to sound like, although I am in an interesting position because I do edit the magazine Ad Astra for the National Space Society. And now this year it's in retail, so you can get it at the bookstore down the street. But the overall thrust of this magazine is to take humans to space in large quantities. The National Space Society was made up of a merger from the old National Space Institute, which is a pro-NASA group from the 70s, and the L5 Society, which was a starry-eyed, let's settle space, no Neil cylinders group, also from that same era. They merged a bit uncomfortably, and it's worked out over the long haul. But the overall thrust of this organization is let's settle the stars. People need to go there. We need to leave Earth. You can't stay in the cradle forever. You've all heard that Tsiolkovsky quote 100 times. So I guess another thing I would add is that I am cognizant of something I'll call the underdog effect, if you will. It's our shortcoming that we're not suited to space. It's not space fault. So although space doesn't like us very much, it doesn't like big squishy bags of muscle and water. It's very hostile to that. We freeze and fry and explode if we go there without protection. So maybe it's incumbent on us, as Frank has alluded to with Homo Spacians, to change ourselves to be able to be there. We can do that with spacecraft. We can do that with space suits, which is essentially a spacecraft that you wear. We can do that by altering our physiology and our makeup to be there. But we do have this exploration imperative, as he also touched on, which dates back at least to the Great Polynesian Expansion and forward from there. Historically, it's been about resources or about leaving a hostile political climate to seek something that's better for your people. I think now there may still be some of that. Anybody who's watched The Expanse has certainly seen that play out. But largely, it's because we want to know what's out there. And evolution is just too slow. You know, we can't go out and sit on an asteroid and wait for our bodies to acclimatize so that we can survive a hard vacuum and hard radiation. Radiation in space has turned out to be the great bugaboo, as I'm sure many of you have heard. In the early days of the space race, we actually had plans to take Apollo hardware and send astronauts to loop Venus and Mars. They were going to fly out to Venus. They were going to swing past Venus. They were going to fly then out to Mars, swing past Mars, swing past Venus again, and come home for a total of almost 900 days. Now, if we had done that, we would have found a bunch of fried strips of bacon in the spacecraft because there's a lot more radiation out there than we thought. So maybe we have to harden ourselves, and that's actually been tried. And if anybody's interested in more on that subject, there's a wonderful person named Martine Rothblatt who runs United Therapeutics. They grow lungs and other organs and are on all kinds of cutting edge research for improving the human body and repairing the human body. And she has a lot to say about transhumanism and the journey up and out. And I'll put that in the chat when I'm done here. But, if you ask me, being sort of the hard-nosed pessimist, as I've been cast, I say, the perfect thing to do with human beings, if you want to go into space, where you have problems with radiation, survivability, mass constraints, long journeys that the human body isn't necessarily suited to, certainly not in zero G. I say just transplant all our brains in little robotic cockroaches. You'll pick up some extra hands. They're very robust and they're very low mass. And if you make them smart enough, they can go out and do anything we can do and probably do it 6 times better given the number of hands and legs they've got. But that's a bit extreme. I came up with Space Hates People originally in the book Space 2.0, which you can see I've got a poster over here, just to describe the challenges of going there. But as Frank points out, I think indirectly, no astronaut I ever talked to anyway ever complained that space hates people. They just say it's hard. And as the great Antarctic explorer Ernest Shackleton said, difficulties are just things to be overcome after all. So that may be the way to go. Terraforming is certainly a possibility. We can change the destinations to be kinder to us when we get there, but it's got a very long time base, at least in the thousands of years. And according to some recent big vision thinkers I've spoken to, Jeff Grayson in particular, who writes for our magazine fairly often, there's a very good chance that the radar technology is expanding. We're going to be in other star systems before we can actually terraform a planet like Mars to be friendly to human beings. And when we get there, assuming there are Earth-like planets out there, not exactly conducive to us, because humans are very narrow in what they can survive. We're finding now, just with global warming, how delicate we are. Things go up a few degrees and we flip out. If you're living in Seattle and it suddenly gets up to 115 degrees, you're having a very bad day. And it's hard to sustain in the long term. So, but if we can go to an exoplanet that's within the same general temperature range, might be a different kind of sun, the orbit will probably be in a different part of their solar system. We may look back at our solar system and think, wow, that's just a trashy Kentucky trailer park that I would drive past and not stop, and find that is our ultimate answer. As far as carrying capacity goes, I think that's a really interesting discussion. I've had a number of articles that have edited in the magazine recently about that. One really fascinating one by Jeffrey Greenblatt over at the Orbital Assembly Corporation about the carrying capacity of the solar system, not just Earth, but the whole solar system. But I think specific to Earth, if you've ever driven across the US, you see that there's still a lot of room. If we can tame these environments, bring them back to their pristine condition, maybe engineer them a bit, there's a lot of room for expansion. Resources really become the problem. And the problem we're discovering now, of course, in this century is how we utilize those resources is the biggest problem. We don't really have a scarcity of resources yet, but how we utilize them, whether you talk about agriculture or the use of animals for food or the burning of fossil fuels, nuclear fuels, these are the problems that we've created for ourselves. And these problems can be solved with the adequate application of technology, I would suggest. But a lot of that's going to come from space, and it's going to come in two ways. One is there are vast untapped resources out there. There's trillions of time, the energy the entire Earth budget needs from the sun. It's a big nuclear furnace, 24/7. It's out there giving us power all the time. All we have to do is capture it and bring it back to Earth. That's called space solar power. That's a longer discussion, but that's one wonderful reason to go there. And something Frank and I have talked about a lot is how difficult it's been for NASA and other space agencies to quantify why it's worth going to space. Well, there's a bunch of good reasons. Getting power from orbit is a good reason, and we're not that far from doing that. The Chinese and the Japanese are a little ahead of us, but we've been working on it in the US since the 1970s. There's a lot of resources out there we can utilize to expand further and build out there. There's water on the moon. There's enough water on Mars to cover the entire planet to a depth of 300 feet. So we've got the things we need. We can use the atmospheric gases on Mars, and we can use the water on the moon to create breathable oxygen. Recently, if you may have seen, the Perseverance rover had a small experiment called MOXIE that converted a bit of carbon dioxide from the Martian atmosphere into oxygen, breathable oxygen. So that was a proof of concept, because these machines always work great on Earth, but the second you take them into space, things go wrong. So there's a lot of things to sort of digest and combine here, but I think the bottom line is we must go. One other thing I want to add is that space exploration has proven time and again to be, other than warfare, the greatest technological driver that humanity has. We have never exceeded the pace of development that we did have in the United States and the Soviet Union, frankly, during the space race. Trying to get Project Apollo to the moon was probably the greatest technological driver, other than World War II, this country has ever gone through. And for depending on which study you look at, for every dollar put into that program, between $16 and $23 came back in terms of what went into the economy. And that is a big part. That is where modern computers began. This iPhone I've got here has more computing power than the entire planet Earth did when we landed on the moon the first time. Sobering fact. And that NASA, for much of its existence in the 60s and 70s, was the single largest investor in education in the United States beyond the Department of Education itself. And this creates wonderful spin-offs. Now we see this happening in China and India. Their technological aspects of their societies are expanded rapidly. And a lot of that is due to consumerism, but a lot of it is also due to their pushes out into space. So besides the philosophical reasoning of why go, why explore, why settle other places, which I think is a very powerful argument, I'm all for that because it's there, because we need to, because we are born as explorers and we have this wandering urge within us. There's also very concrete, quantifiable reasons why it makes sense to go out there and utilize the vast resources to help us continue to expand and grow. And that'll work really well until we bump into another species that says, hey, not so fast. This is ours. You got to stay over there. But that's a whole nother conversation. That's it.
Rod, I'd like to continue the conversation a little bit here. I think it's great that you came up with the siren principle. And actually, I had the same thought today in preparing. I didn't come up with the term, but in the Odyssey, Ulysses, who was one of the first real astronauts in a way of his time, they're going through the Straits of Hercules. The sirens are singing, and he says, tie me to the mast. I don't want to be seduced. And as they go through, he starts shouting, let me go, I gotta go. I had this feeling that humanity is kind of in that state. Every time we talk about going, there's somebody who says, I'm going to tie you to the mast unless you give me a really good reason. I think it's inevitable, really, that we're not going to stay tied to this mast. I just believe that strongly. I think what I wonder, though, Rod, let me ask you this, because those of us who are here think it's inevitable. Is it possible that civilization might collapse and we might miss this opportunity? Is it somewhat urgent right now to resolve this issue one way or the other?
Well, that's a really interesting question. That brings up something I read a while ago. There was a study, and I apologize, I can't remember which university it came out of, looking at the age-old question of where is everybody? Why do we seem to be alone here? What's going on? And there's been a lot of answers put forth for that, none very satisfying. This study was very interesting, and it said basically, look, the universe is very old. Our solar system is a fairly recent arrival. We live out on this sort of threadbare extension of the arm of the Milky Way galaxy, and that there's a very good chance that the other advanced technological civilizations we're seeking, at least in our galaxy, have already come and gone. And of course, that feeds back on that old conversation about what happens to a technological society after a certain point if they don't overcome their tribal and warring instincts. Do they wipe themselves out? So yeah, I agree with you. I think we do have sort of a narrow chunk of bandwidth here to get this done. On the other hand, I am greatly gratified by the introduction of this new space age. Note, I didn't say new space race, although there are a lot of people, especially in political circles, trying to pose this as such, not between Bezos and Branson, but between the US and China right now. And let's hope that that doesn't come to pass. It's a good motivator in the short term, but in the long term, it doesn't necessarily have good outcomes. But I think this age of commercialism we're seeing, and for me, a lot of people I think felt yesterday, okay, finally, we've arrived. Okay, this wacky billionaire built his rocket plane. He recreated the X-15 and off he went into the cosmos, and that's wonderful. And I agree, it is wonderful. But for me, it was really in 2018 when Elon Musk launched the Falcon Heavy. Now, here's a guy who grew up after the space race, for the most part, who just was imbued of that mythology, those amazing times that people the age of Frank and myself experienced where there were these amazing missions of exploration going off to the moon as often as every 10 weeks. Now imagine that. For most of your lives, of the people in here, we've been circling the Earth in the space shuttle and the space station, which is great work. There are really important things to be done up there. Some of the biomedical advances alone are enough to offset the cost of that station at $170 billion. But when you look at the finite achievements, it's less so. So people like Musk and Bezos have positioned themselves to say, I'm tired of waiting. I'm richer than Croesus. I'm going to go ahead and do this myself. And this is like a 1950 science fiction movie, the wacky billionaire that builds his rocket and goes to the moon and walks around without a spacesuit or with no gloves on. It happened. And to me, that was a really pivotal moment, because for years I've been giving talks to groups of young engineers and kids and so forth, saying the new space age is just around the corner. There's going to be jobs for everybody, you know, from everybody from the barista at the Starbucks at Johnson Space Center to cooks, to cleaners, to everybody, including engineers and scientists. There will be great opportunities. That felt like that pivot where we finally entered this age where entrepreneurial zeal was going to make this happen. There are people that are not the most ardent fans of capitalism, but one thing you have to say about it is it's fast and effective. The side effects aren't always good, but it is fast and effective. And we're entering an era where people of means are beginning to realize there's a profit to be made out there. And whether that's one of our better instincts or one of our baser instincts is debatable. But when you have a profit, when you can close that business case, things really accelerate. And I think that's what we're seeing now. And that's what has me so excited. I would like to see a little more of a noble impulse driving this, perhaps. You may have read that Rocket Labs is preparing to send their own probe out to Venus because they can, because they want to, because it's good science. They're not going to make any money on it, but it's really good PR for them. And I was recently interviewing Gwynne Shotwell over at SpaceX, the president and CEO of that company, right under Musk. And I asked her, I said, you know, I get the moon. Okay. You're a NASA contractor now. There's money to be made there. There's water to be procured and refined and all that. And SpaceX is more about being the train than the town that it goes to, their transportation primarily. But I said, how the heck do you close the business case for Mars? This is really expensive what you're doing and difficult. And you guys are exploding rockets every few weeks, which I think is wonderful because it means they're succeeding and advancing what they're doing. But her answer was, look, by the time we get the Starship system up and running the way we want it to go, it'll cost less than a second mortgage on your house. I think she was talking about the US on average, not just places like Boston and Los Angeles, where Frank and I live, where house prices are astronomical. So for, let's say, $100,000, you can go to Mars and you can decide to set up shop there and pursue whatever you're going to do. She felt that closed that business case. I don't know if I think it's quite that simple, but I think when you can find a way to survive and thrive being the key thing there. We know how to survive in space now. It's just a matter of refining the technology to do it on scale and reliably. Because again, everything outside that thin metal hull next to you wants you dead. But once we work out those problems, I think we can begin to thrive. And that's where the magic is. And there's an overlap. There's a Venn diagram that I use in a lot of Space 2.0 talks, which has three circles. One is NASA, one is international space agencies, and the third one is the commercial sector, the entrepreneurial sector. Where those three overlap is where the magic really happens. And that's where I think we're going to see an incredible amount of acceleration over the next 10 years, all assuming we don't have some massive setback. So Frank, I think I kind of answered your question and wandered way off into the weeds there, for which I apologize.
That's okay. That's why you got more books than I've got.
Because I talk too much.
You got more to say. No, I think you're absolutely right. And I think, now that entrepreneurs are in the game, you're exactly right. They don't have to justify it. I mean, there was an interesting dialogue between Bernie Sanders and Elon recently, where Bernie essentially said it was morally terrible to be a billionaire and, he shouldn't be doing what he's doing. And he said something like, I'm taking consciousness out into the universe. And there was no communication between the two. But, Elon's got the wherewithal to do what he wants. And unless someone passes legislation that he can't do it, he's going to do that.
I'd like to make a point about that. Excuse me for interrupting, but there's an important distinction between Musk and Bezos. I'm a big Musk fan. I'm not sure he's even from Earth, which I think is very cool. But here's a person who says, I'm going to fail forward. I'm going to iterate rapidly. Get out of my way. He's not very kind to his workforce, reportedly, but he is effective. His goal, as he has stated many times, is to make humanity an interplanetary species and have a large settlement on Mars. He views that as a backup drive for humanity, which is a fine argument until you realize that most of us are going to be the ones left behind, whether because of means or because of age or health or what have you. And while I am very much a humanist, I'm going to be a little piqued if I'm the person left here when the planet has decided to dry out and turn into an unlivable husk, which I don't think will happen soon, but we have problems. Bezos, on the other hand, now here's an interesting contradiction. Amazon, by most reports, is not a pleasant place to work by any stretch. I wouldn't consider him a humanist in his Amazon iteration. And yet in his Blue Origin iteration, in his valedictorian speech in high school in 1982, so we know he's smart already, he got up and said to a very skeptical, head-scratching, eye-rolling crowd, my goal is to settle humanity beyond the Earth and to take, this is the part I like, to take heavy industry off of Earth, polluting industries off, so power generation, manufacturing, anything that's really bad for the planet, and put that in space. And that I like a lot. So I find that to be a much more welcoming conceit than the idea of just creating a separate civilization on Mars, where, let's face it, given the conditions out there, especially radiation from the sun and from beyond the solar system, hard galactic radiation, you're going to be probably living in a cave inside a metal habitat. And while I think people can survive that for a long time, you know, we have studies from 100 years plus of submarine crews surviving long periods of time underwater. You know, looking at a rock wall just to be on another planet isn't going to be as exciting as a lot of potential settlers think it's going to be. It's going to be a very hard life. So I'm all for keeping the planet we've got in good shape. And I think Jeff Bezos has a good shot at doing that if he keeps his eye on the prize.
Yeah, you know, just I know we're running out of time. I would just paraphrase what you said based on our topic here. People hate Jeff. A lot of people hate Jeff, but if they knew what he wants to do, they would love it.
Yeah.
You know, save the planet, et cetera, et cetera. And, you know, a lot of people love Elon, but probably wouldn't love the ultimate goal if they really understood it. But I'd just like to close inevitably with the overview effect. I think one of the great benefits of what's happening right now, and it goes back to serendipity and unpredictability. Every NASA astronaut, every cosmonaut, you know, they went into space with a capital S with a mission, and it was not to experience the overview effect. Sir Richard and his team really did go to have that experience. When I interviewed him for the book, I said, aren't you actually selling the overview effect? And he laughed and he said, oh, yes, we are. And he laughed and he said, we'd love to borrow your brand. And I said, oh, I want you to use it. Go ahead. It's there for the taking. And he, you know, he definitely agreed that this experience is what they're marketing. So we're now going to have hundreds and thousands of so-called ordinary people experiencing this environment, including the view. We cannot possibly predict the outcome, but every astronaut I've talked to about it has said, I think it's going to be really good for humanity. And that's a very near-term benefit. And I think personally, in terms of human evolution and human survival, I think it's worth all the investment, all the effort, and just overcoming our unrequited love to have that experience. I can't wait to see what the outcome will be.
Can I add one last thought, which is very much part and parcel of what Frank has done for the last many decades? And you'll have to pardon me, it's a slightly salty quote, but Edgar Mitchell, who was an astronaut on Apollo 14, who I think of of the Apollo astronauts experienced the overview effect most profoundly had a wonderful quote that's very utilitarian in modern times. And he said, and I'm paraphrasing here, that his experience makes you, quote, want to drag a politician by the scruff of the neck out 240,000 miles from Earth, have him look back and say, look at that, you son of a bitch. And what he was saying was, you know, as so many people you interviewed, Frank, have said, there are no national boundaries. There are no dark red lines drawn between nations. We're all in this together, and we have to start behaving like it, or we're probably not going to make it. And that may be the most valuable part of it that there is.
Absolutely. Very well said. I don't think we can go beyond Edgar Mitchell, a great supporter of the work I've been doing and the whole idea of the overview effect. And salty language or not, he said it well.
Do you gentlemen mind if I follow up with 2 questions for you? We'll go over time just a tiny bit.
Sure.
Please, let's go over time for an hour.
Oh, I would love to.
But that would mean I'd see other speakers, but.
Rod, in your book, Space 2.0, you echo what a lot of people feel about the gaps in the space program and how that set us back. Can you talk a little bit about the positive impact of gaps, you know, this urgency that you're talking about? Does it also, when there's a gap, does it also break us out of bad habits or restrictive paradigms where we can reach new levels? To just talk about that a little bit for us.
That question may be smarter than what I wrote, but I'll do my best. I think the gaps have been effective in a couple of ways. So they're failures of willpower. I mean, let's be frank. We had the capacity at the end of the Apollo era, and the Russians had a different capacity in their program. But our capacity was, we could have continued building. We could have gone on to build lunar habitats and stayed there and done great science. We could have gone on to Mars with the technology we had. Chemical rockets work. They just take a long time. We could have certainly put up larger settlements in Earth orbit. But what I guess the 2 primary things I think those pauses created were, one, it got a lot of people thinking about, okay, Apollo's over, the big rockets are gone, we don't have that system capability anymore. What government turned to was the space shuttle, this idea that it's cheaper and reusable. And, you know, their original sales pitch for that was it'll fly 54 times a year, which of course never got close to, never more than once a month, usually more like 4 times a year. It was dangerous. It was constrained. It was a heavily constrained program while it was being designed. So that didn't work out well, but they gave it their best shot. And we got a lot out of it. We got 30 years of flight and the space station. But a lot of other people who weren't involved in the shuttle program went off and said, okay, let's re-envision this whole thing. What's a better way? And I think that's what's moved us indirectly into the era we're seeing now with private rocketry. So if you look at what just Musk, as an example, with the Falcon 9 and the Crew Dragon capsule, by NASA's own internal studies, and you know those are constrained, they say that depending on which part of his program you look at, the cost to them was between half and 1/10 of what it cost to do it the old way. Well, that's a direct benefit from the slowdown, in my opinion. Another thing that happened in the wider population, so outside of aerospace circles, for people like Frank and myself who were a little bit stymied by the requirements for engineering school, which is same like you, Frank. I went to Stanford, the Stanford of the East, I guess you could call it. They always call it the Harvard of the West, but I don't like that, because they would let me in without being a science major. I could go there and study what I really dearly wanted to do, which was storytelling and how to convey this epic tale in the best possible terms. But a lot of people got caught up in that story, and that's where groups like the National Space Society, that's where groups like your group, Foundation for the Future, and many others came along, either directly or indirectly, during this interregnum of so little going on. The whole space advocacy movement was really born of the late 70s, early 80s, when the great adventure stopped and people said, you know, the shuttle's great, but it's not enough. We need to do more. And that's when you began to get the expansion of Jerry O'Neill's ideas and an awful lot else. And these weren't people, for the most part, that were scientists and engineers. A lot of them were, many were former NASA people. But globally, there is this enormous population. I think at the height, the NSS had maybe 40 or 50,000 members, but that's an appreciable number, saying we want in on this big dream. This is the greatest adventure in human history. We want to see it flourish. And I don't know that would have happened had we not had one of those gaps in which to reflect.
Yeah, a pent-up demand, can sometimes take things over the edge.
Well, demand and desire. I mean,
Yeah.
there is a demand, so we're seeing hundreds of launch companies try and start up. Not many are going to survive because there just isn't enough demand. But the desire of the human heart to go, as Frank was so eloquently said in his many books, is unquenchable. And that's, I think, ultimately what going to be drives us out there. Business is great, but just wanting to be part of this bigger adventure and wanting to see what those distant shores are like, whether they're welcoming or not, is really immaterial. We want to try.
Agreed. Frank, you may not have liked math and Rod, but you both have a scientist's knack for naming, classification, and definition. The collective word count in 10-point font could probably reach to the moon. Talk about the overview effect, Copernican perspective, universal insight, Homo Spacians, and now the siren principle, laser apt to its application. Thank you for that one. Talk about your collective decision to coin and define these terms and publish them and give things names, and the importance of that in this discussion to the community and to advancing the science and technology.
Yeah, one of the things I've tried to emphasize about the overview effect is that it is not a term that I sat around at Harvard and tried to come up with something that would get me tenure. And then I started interviewing astronauts, and then I thought, okay, it wasn't like that. It wasn't like that. I was flying cross country. I was thinking about Jerry O'Neill's idea of living permanently in outer space. I wasn't really thinking about astronauts, interestingly enough. I was thinking about people who don't exist yet. That's people who would live permanently out there in an O'Neill community. I was looking out at a scene not totally unlike that one behind me, although I wasn't in orbit. And it hit me. It was an epiphany. That's all I can say. They will always have an overview. They will always see the Earth as a whole system. I was the systems thinker at the time. The term overview effect came into my mind. And I thought, this is a hypothesis that they will be different from us philosophically. I didn't see it as extraordinary. I saw it as just part of their zeitgeist. And I started interviewing astronauts because I thought they would be good proxies. And then I found something new, which was it was extraordinary for anyone born on the surface who then went out into outer space. But just to answer your other question, as I wrote the book, it became clear that it's only the first stage of a transformation of consciousness. The strongest place to get the overview effect is low Earth orbit or on a suborbital hop. But as you get greater distance, new shifts start to occur. And instead of just getting that you're part of the whole system called Earth, you start to get you're part of a whole system called the solar system. And that's the Copernican perspective. People living on Mars are going to have much more of that consciousness because the Earth will be a point in the sky. And then going back to Rod's point with Edgar Mitchell, he experienced a unity with the entire universe. It was something really rather different. And I called that the universal insight. That is to say, some astronauts have gone beyond the first two stages. They have experienced connecting to the entire universe. And one of the astronauts I talked to called it astronaut secret. And he said it's a realization that we're not just citizens of a planet, we are citizens of the universe. And again, when we talk about what's the benefit, what could be more beneficial than realizing our place in the cosmos? How can we turn that down and lash ourselves to the mast? We can't. So, how'd you come up with the siren principle, Rod?
I was pondering my envy of your copious academic works this morning, and I thought I need to come up with something like that. Because, having space hates people to hang your hat on isn't exactly welcoming. I'm supposed to be selling this dream. And by the way, Frank and I have talked endlessly about this idea of how can we be more effective in selling this dream. And that's what I think is really the power of a group like this. You're all people that are already believers, or you wouldn't be here. And I don't believe necessarily true believers with quotes and capital letters, but you believe in the idea and you're part of the dream. And it's, I think, important for us to go out and, we used to say evangelize others, and I think that's a strong word with some negative connotations, but at least bring others into the conversation. So for instance, I'm going to a conference called Space Fest. I'm leaving this afternoon in Tucson. And Tucson is not a place you want to go in the summer. If you want to experience living on another planet, Tucson's like Mercury in the summer, and it's not a nice place. I mean, Tucson's a great town, but not in the summer. But I get to go be with about 1,000 people who love talking about this stuff. So unlike some family members, past and present, if I start waxing philosophical about this wonderful journey, I don't get the eye rolls and what's for dessert, and can we do something else now? I have a rapt audience that wants to hear about it and who has incredible ideas. So that's a great privilege, but I would love to see all of you take that forward and let people know why this is important. Frank and I have talked endlessly as I started this little rant, talked endlessly about how we, and in particular NASA, could better sell that topic. And NASA's been really struggling since their formation to explain why this is important. There's a lot of people that didn't want to go to the moon. There's this notion, even some very sophisticated scholars I know still subscribe to this, that during the 1960s, the nation was united behind this great imperative to conquer the moon. And nothing could be further from the truth. It was about 50-50. And some of the people who didn't like that idea were very vocal and rabid about it. And depending on which polls you look at and how they ask the questions, which is always a little gooey, we're still about there. You ask people, do you think NASA's good? The pollsters come back and say 80% of the public thinks NASA's great. Greatest brand since Coca-Cola. Then you ask them, should we go back to the moon? You get, well, no, excuse me. You ask them, should we continue to accelerate our expansion into space with exploration? About half say yes. When you say, how important is it for the Artemis program to go back and land astronauts on the moon again? It drops down to about 17%. So it's very question sensitive. And as anybody who's done statistics knows, these days with programs, you can just turn a knob here and there and get pretty much the answer you want. These aren't the answers we want. So let's turn the knob on the organic side and try and get the public more engaged in this conversation to understand why it matters.
Fascinating tie back to our group and our topic. Really, really appreciate that. And your description of the cocktail party experience for you. Frank, any closing thoughts?
Well, I'd say one thing when you ask the question about why are Rod and I, why do we keep doing this? Well, we're writers. We're both writers. That's what we do. And I go back to John F. Kennedy saying we haven't completely yet understood the meaning of space with a capital S. I don't think we have a choice. I think Rod and I have no choice but to keep writing and to keep trying to understand the meaning of space with a capital S and communicate it to true believers and those who are skeptics. And I think that that's our job, that's our role, that's our purpose. And I would just close by taking the spotlight off of the speakers and say, everybody here, all of you who are here, you have a purpose in this movement. And don't give up on it. Don't think you don't. Look at Richard Branson, how long he waited. I published The Overview Effect in 87, waited for a revolution in consciousness to begin. And honestly, I waited more than 20 years when I didn't think anything had happened. So I really want to close with the same kind of message that Sir Richard shared. If you've got a dream, if you think this is important, don't let anybody lash you to the mast. I keep coming back to I love the siren principle. I keep coming back to that, go for it. That's my final word. Go for it.
Let the harpies have me.
Yeah.
Well, see, that's where it
be
begins to fall apart, interestingly. I would just add one more thought, which is we can't all be Bransons, we can't all be Musks, we can't all be Bezoses. That's probably a good thing. You'll find, depending on what path you're taking through your love for this topic, it's not always very lucrative. And in my personal life, I can't speak for you, Frank, but in my personal life, I come from a television and entertainment background. The fastest way to move from a mid 6-figure income to a mid 5-figure income was to decide to start writing books. And it's only got more challenging since then. But I wouldn't go back for a 12-figure income, because this is what I love. I think it's what all of us here love, which is why we're together today. And, if you can do it, and it's not the same for everybody, if you have a family and a high mortgage and so forth, there are challenges, and people around you may frown on you dropping to a 4-figure income. But if you can find a way to bring this into your life in a fashion that's meaningful to you, there's nothing better than a state of bliss in your work. And it's hard to find, but when you do, it's just wonderful. And I think that's something Frank and I have shared for a long time.
Yeah, absolutely.
Gentlemen, thank you so very much for a lovely discussion.
Thank you.
It read a little bit like an issue of Ad Astra magazine, plenty of inspiration with a healthy dose of realism for good measure. Thank you.
Thank you so much.
Thank you.
Now, everyone, grab a lunch that is safe, acceptable, nutritious, and efficiently balances appropriate vehicle resources. And we'll hear a few words from our Executive Director of Foundation for the Future, Tim Crispin. If you've enjoyed the program so far today, please help us cover the cost of this and upcoming Conversations for the Future events by sponsoring our next event at registration or by making a donation at www.f4f.space. Now, as we face an afternoon discussion about health in space, make sure you move around a little bit while you're listening to Tim. He's our Executive Director and co-founder of Foundation for the Future. He's a former CIA and Army intelligence officer. He supported the National Space Council and the Joint Staff at the Pentagon. He holds master's degrees in intelligence studies and international relations and affairs, both from American University. Mr. Crispin is the author of the book Humanity in Space and of various articles about the expanse of our civilization in space. Tim's next challenge and mission is to make space accessible, survivable, and ultimately routine enough to be boring. Tim, take it away.
Thanks, Lee. That was a fantastic panel there. Thank you so much, Rod and Frank. It is important, I think, for many of us here who have varying degrees of recency to the space community to have a chance to hear from some of these people who had the original ideas, did the original research, and from which we are building off of. And as Lee mentioned in my bio, I've done a handful of different things, and the originators of a lot of different fields are not always the Rods and Franks of those fields. The ideas they generated stick, and they force things to stay in frameworks and hold back progress rather than gladly and excitedly taking on the role that Rod and Frank were just talking about, of pushing our understanding forward and trying to ensure that we're not just talking to ourselves, but instead we're pushing out and, as much as possible, avoiding creating these echo chambers. The presentation I normally give in this segment is around the Space Corporation Act and one of the tools that we at the foundation are pushing to help make space real and accessible. And I pulled this chart out of that presentation and wanted to walk through a little bit, done a little bit different path based on where Rod and Frank were talking, because they have witnessed these peaks and valleys that the space community has gone through. They look to more recent entrants, more pronounced, but as mentioned, there's never been this overwhelming groundswell of support all in for space that maybe we think when we go back and read the history books. But nevertheless, we are at a point that is very similar to where we were with the Apollo missions, with the space shuttle, where the promise given is so grand, so all-encompassing, that it seems inevitable that there will be a disappointment. We saw these drop-offs after the peaks there, where technology couldn't mature fast enough, focus couldn't be maintained long enough, and ultimately it was an echo chamber talking to an echo chamber that convinced itself that the public was more on board with space than they were. And one of the main missions for us at the foundation is avoiding that happening again. And we routinely hear questions from the general public. We see op-eds talking about this of, why are we wasting money in space? We have starving people, we have this problem, we need to solve this crisis. Why waste the money on space? And that is what has been the perennial question of anything new. Why waste money on the internet? Why waste money on cars? And so what we're trying to do at every turn is return the focus back to the ground. Hey, Richard Branson just took the first tourist on a suborbital flight, VSS-2. Looks like it's a billionaire that beat another billionaire. Cool. Why don't they solve world hunger? Well, now that we have a viable model for point-to-point suborbital flights that can deliver people, goods, and services anywhere in the world in a pretty short amount of time, we've now prototyped the capability to rapidly move to meet crises. NASA just landed new rovers on Mars. Why are we running billions of dollars of probe into Mars? Well, technically, we're testing dozens, if not hundreds, of prototypes in a harsh, austere environment to figure out how they work and how can we use them back here as well. And one of the things we try to do here at Conversations for the Future is tie things back to a location. We've been on the road a number of times this past year, going to places like Scranton, Pennsylvania, Akron, Ohio, highlighting different towns and how we've left them behind. They're not space towns, and there's plenty of reasons why we could make that they're not. But ultimately, the only excuse is we overlooked their potential. As we go into this open space era, this era when going to space is not a physics challenge anymore, it's a financial challenge, and that is one that can be bought down pretty fast. Now we enter a time when there is a need for people with the grit and determination to figure out the new, not necessarily rocket scientists and engineers to develop novel, exciting technologies. And so our area we're highlighting this month, Charleston, West Virginia, we chose because space, living there, working there, thriving in space, is ultimately about thriving in a self-contained community. You're on your own. You get resupply from the ground, but that's not in real time. Depending on where you are, communication isn't even in real time. And if you look across the country, the area of the US that has the most recent experience doing just that sort of thing is coal country, where they had self-contained towns that existed to mine. Everything was built around that. The community pulled together. There's plenty of cases of it not working well, but in the same vein, how they grew those communities around a singular purpose to survive and thrive is a model that we can look to as we go up and out. And so we wanted to highlight West Virginia as an example for the rest of us. Not only do we need to be taking the message to West Virginia that we need your help figuring out how to do this right, learning from what worked, what didn't in your history, and taking the skills and expertise of the workforce there, but also we need to let the rest of the public know we're not the rocket scientist nerds who have it all figured out. We're in need of the right answers, the good way of doing things, and are capable of adapting, overcoming, and learning. Because all too often, when you have these new and these exciting and sexy fields, people look to those early voices, those Rods, those Franks, and when they see rigid authoritarian views, you're either in or you're out. But we have the chance to welcome, because not only is that how we started, but we are continuing in that vein as we go forward. I don't want to go over and cut into the next segment, so I think I will stop there and see if we have any lingering questions from the panel. Yeah.
I have a question, Tim. Going back to the chart that you were showing there, could you give us some specific examples that might help us bridge that gap? You know, you talked about us being sort of at this, at this crescendo of, excitement, but what's it going to take to keep the trajectory moving upward instead of dipping down into, forgetting?
Yeah. We're building on the work of a lot of different people. One of them, multiples are here today. Eva Jane Lark wrote a paper in 2005 about this very question. And how do you smooth investment cycles, bridge the gap between expectation and reality? And ultimately, the answer is you create space so that failure is possible and that doesn't create ruin. Right now, with the investment cycle for space, you're either on a government contract or it's billionaire/venture capital money. If you're on a government contract, you more or less are safe unless there's a political change in the mission and the project. And so in that case, there may be space for failure, there may not, depending on what is going on politically. It's uncertain, but it's safer than if you are depending on venture capital, because you require success to generate the next round. The vast majority of new frontiers have been opened by long-term patient investment that knew the first 10, 15, 20 years of that investment, we're going to be at a loss. But the 50 to 100 years after, we're going to generate stable, consistent returns in such a manner that it was fine. Having that upfront patience was okay. And that's the key element that's missing and has been throughout the space economy's young life, that there is no patient source of money that is willing to look at this over a decade plus long time span, knowing that beyond that decade is when money starts coming in that changes the game completely. I see a question from I'm gonna butcher this name. I am sorry. Akshay. If that was right, you can give me a thumbs up. If it was wrong, please pretend it is right. The question is, how does an engineer working in another industry get a job in the space industry if you don't have experience? The answer is it depends on what kind of engineer you are. If you're a civil engineer, you can give up on life and never get a job anywhere. Sorry, civil engineer joke. But realistically, the engineering skills needed for the majority of space jobs right now are standardized. You need to be able to take existing, improve on it, know how the mechanical features are working together and operating as a system, and build off of that. And so whether you have experience doing that on a car, a boat, or a rocket engine, the challenge, if you don't have the space experience, is merely tying the similarity to the space. When we go out and talk about workforce development, we explain if you can weld a plane, you can weld a rocket. And we are reaching that point across fields in the space community, where there will always be those rocket scientists and uber nerdy science STEM people who are pushing the envelope of what's next. And in those positions, maybe it does benefit you to have some experience of what has worked before, what hasn't. But for the vast majority of the jobs opening now, they can't fill them fast enough. And so the requirement is, can you learn? Are you excited about space and willing to try new things? Then jump in.
Great answer, Tim. Lots of people transitioning into this industry, myself one of them. And, you know, it's a winding path, even for a STEM person. A lot of applicants to few jobs and few applicants to a lot of other jobs. And so finding your right niche, I think, is a good way to start. Thank you so much, Tim. And next up, we have the special segment, Saturday Space, where we enjoy things you might do on a Saturday in space. In this case, we're cracking a cold one in the cold expanse of space. Chris Carberry is the CEO and co-founder of Explore Mars, Inc., a nonprofit space advocacy organization that was created to advance the goal of sending humans to Mars within the next 2 decades. Carberry is a well-respected expert and influential director of strategic alliances in the space community and has been responsible for growing many partnerships grants, and sponsorships for leading industry organizations. He has organized and led many international conferences, has testified before Congress, and is the author of scores of articles and op-ed pieces in USA Today, US News and World Report, and the Washington Post, among many others. He's also been featured on Fox News, CNN, BBC, NPR, and NBC Nightly News, in addition to other media from around the world. Finally, he is the author of Alcohol in Space, Past, Present, and Future, which is the focus of his talk today. Chris, thank you for being here, and the screen is yours.
Well, thank you, Lee. Thanks for having me. And do I have the ability to share screen?
Yes, you do.
All right, hold on one second. Is that the right one? I think so.
That's your email.
Oops, it's still not showing. Wrong slide one. You seeing the should have the slide show up right now.
It still appears to be your email window right now.
Well, at least you can see who my emails come
That's
from in the
right.
last hour.
We're reading as quickly as we can.
Has it switched over yet? Because I have on my screen, I have the slide presentation up.
It hasn't quite yet. Why don't you try unsharing and then resharing?
Alrighty.
There you go.
Ah, brilliant, brilliant.
Just like the Hubble Space Telescope, they had to turn it off and on the other day just to get it to work again.
You know, after a year and a half of this, there are still little quirks, little problems occasionally. But thank you for having me on. And as crazy a topic as it sounds, you know, it's a very real topic. You know, for the last several years, I've been looking at, almost in a comical sort of way, looking, you know, amusingly at whether I should write an article on alcohol in space, whether you could brew beer in space or make wine in space and what it would taste like. But as I went along, I realized there were dozens and dozens of companies actually working on real alcohol in space projects. And there was a fascinating history. So I decided I might as well be the first one to write a book. And I think it's highly relevant to this discussion because, as you'll see as we go along, this topic really, you know, addresses a lot of the critical issues for space exploration and civilization in space, as you'll see. Now, you may know, I mean, just giving some background, alcohol has played a pivotal role in human civilization from before written records. It has played a large role in the history of agriculture. Many people think that the need for a drink actually had a more significant role in the in agricultural technology than the need to eat food. And of course, it's played a large role in things like diplomacy and religion and social gatherings, medicine and ceremonies throughout history. Oops, let's see if it's going to let me. It's not letting me advance. 1 second. Apologies, let's try this. Not letting me advance for some reason. Yep, okay, there we go. All right, one other example is in exploration. As we know, alcohol has played a pivotal role throughout his exploration. Probably one of the most famous examples was Ernest Shackleton. You know, he famously had left a whole bunch of scotch in Antarctica, which was discovered many years ago and was imitated to sell for a high price. But Shackleton brought a large amount of alcohol on his Nimrod mission before the Endurance mission. As you see here, for this small crew right here, he brought 25 cases of whiskey, 12 cases of brandy, and 6 cases of port. You know, he was quoted as saying, if I had not, strength of will, I would have made a first-class drunk. But trust me, by today's standards, Shackleton was a first-class drunk. Standards change for these things. But through exploration, they realized they needed a way to relax, to work off some steam, because it's very stressful while you're exploring when you're in a small space with the same people over for a long period of time. Oops, that was supposed to be moved, but alcohol has also been portrayed in a lot of science fiction, including these books, whether it be Ray Bradbury, Jules Verne, or H.G. Wells, but also, of course, I'm sure you're familiar with scenes from Star Wars with the Cantina Bar, or in Star Trek, 10 Forward, and many, many other different science fiction depictions. We always just assume alcohol is going to be a key part of that because it is part of human society. We're not all of a sudden going to stop drinking alcohol when we get into space. And as such, it's an area where we need to study. But yes, where did I, once again, what did I hit here? Okay, oops, I'm on the wrong slide. I brought up the wrong one, but that's all right. Anyway, but there has been an interesting history of space already, drinking in space already. It has been brought up from smuggled up to space since the beginning of the space programs, whether it be Russia or the United States. This is actually a picture, it's kind of a joking one, of the Soyuz Mars mission, where they have these little flasks, these little tubes of borscht, but they have vodka labeled on them. But this is a joke, but it's actually, there's actually been a long history of alcohol going up. Probably the first one that we really know of is when brandy was sent up on Apollo 8. Now, this was a joke. They just sent it up as a gag, to be part of their holiday meals. You may recall Apollo 8 went up over the holidays in 1968. And so 3 bottles of brandy were sent up. They weren't intending to drink them, but they did go around the moon, and a few years later, Jim Lovell actually auctioned off his bottle right there, pictured there, for I believe it was close to $40,000, plus that certificate of authenticity of one of the few bottles of brandy ever to go, well, probably the only 3 bottles of brandy ever to go around the moon. Just a few months later, some alcohol actually was consumed in space and on the surface of the moon. Buzz Aldrin actually brought up some wine and a goblet. He had arranged with his church, the Webster Presbyterian Church near Houston, to do a communion prayer. He had basically as part of his first opening statements when he was talking on the surface of the moon. He had originally asked to do it publicly when his mic was on, for the whole world to hear, but Deke Slayton advised him not to because he thought it might not go over well. This was particularly because back in Apollo 8, not the alcohol, but there was a big controversy when there was a prayer said, as they're revolving around the earth on Christmas Eve, and they start reading from the book of Genesis. Well, that got a lot of atheists around the United States upset. So Deke Slayton thought that if Buzz did a prayer and consumed an alcoholic beverage on the surface of the moon, that would even cause more of a controversy. So Buzz actually did his communion prayer, but when the microphone was off, and he describes it many times in different publications of the wine circling down his goblet in the 1/6 gravity of the moon. To this day, I believe Buzz is the only person who ever consumed an alcoholic beverage on another planetary body. It's also played a role in other places. It was originally supposed to play a role in Skylab. They wanted Skylab to be a home away from home. And so wine was going to be part of this mission. And they even selected, they were looking for a wine that was stable enough to be able to survive basically the harsh environment of launch. And so they eventually decided on sherry, a fortified wine, because if you shake it a lot, it's not going to make it, it's not going to skunk it at all. But over time, after they tested it on the Vomit Comet, and they realized when it was mixed, the smell of the brandy or the sherry, when it was mixed with the other aroma that is fairly natural on the Vomit Comet, the test didn't go very well. But there was also a lot of other pushback when it became public that they were going to send up alcohol on Skylab. So it was never sent up, although one of the Skylab crews in one of their simulated missions here on Earth were able to consume the sherry. Although that bottle is, I believe, the only remaining bottle of the space sherry that never went up into space. As I mentioned, it continued going on for years and years. This is actually the only image that we know of, the only official image of alcohol in space. Most people on this call may know that alcohol is officially prohibited by every space agency. However, it is more, it's taken more seriously than some space agencies and than others. And it was pretty much a staple aboard the Mir space station. This picture was taken after the Mir fire, when, you can imagine, after you experienced the fire in space, you could use a drink. And so this actually took place, this was taken right after that. And I apologize for the poor quality image, because this is the only image that we know of. It's owned by NASA, but NASA doesn't like admitting that they have it. So I even asked them for it, but they never could seem to find it when I was asking, so I only have this grainy image. Anyway, during the whole history, throughout history, it's gone further on in space as well. I mean, not just Mir, on the space station as well. Crews regularly consume little shots of cognac. As much as people may think vodka might be the most popular drink in space, cognac is actually the official drink in space. And so when new crews come up to ISS, they'll often have these toasts that kind of build camaraderie between all the international crews. And as far as I know, I haven't found any evidence of any crew or any astronaut becoming inebriated. They've only consumed small amounts, but even then, we still don't know, how alcohol is metabolized by humans in space, because all of this drinking in space has been unofficial and small amounts. So there's still a lot of studying to be done. But as I said earlier, there are a number of companies that are looking at this. The spirits industry, Ardbeg, the Scottish whiskey company, sent up the first whiskey aging experiment back in 2011. It came back a few years later, and the test results, were very, very distinct. The space-flown version of the Ardbeg tasted a lot better, and not for the better. They described it as tasting like lozenges or having a fishy taste, which is not exactly the taste you want in your whiskey. Another company that launched whiskey into space was Suntory, the Japanese beverage producer, and they still have a whiskey experiment up there. They're trying to see if aging whiskey and microgravity can mellow the taste of whiskey. They've been very tight-lipped, though. They have one experiment that's come back and one that is still up there, but they have not really been too open about the results of their the first experiments that came back to Earth. The other companies, beer companies, have entered the fray. Space barley was sent up into space a number of years ago through Sapporo, the Japanese beer maker, and they produced a small batch of beer that was based, on the barley that had been sent into space. Another company, beer company, in Ninkasi Brewery in Oregon, they sent up yeast on a sounding rocket and basically made their ground-controlled beer based on the yeast, or the descendants of the yeast, that actually went into suborbit. And they had quite a bit of a market for it. They've gotten a lot of publicity for that. Perhaps the biggest company to enter the fray is Budweiser. Back in 2017, Budweiser announced it wanted to be the first beer manufacturer on Mars. They announced this at South by Southwest. And of course, we thought it was just a PR stunt at the time, but then they started spending money on it. They have sent 4 barley experiments up to the International Space Station. And this is one of I'm not a great fan of Budweiser. Apologies if there's anybody from Anheuser-Busch on the call. However, this is one of my favorite experiments because it has implications far beyond whether we want a beer or a whiskey in space. If you can grow barley in space, that's a direct investment in agriculture. One of the enabling technologies, capabilities, if we want to create sustainability anywhere. If we can't eat, if we can't grow our food, we're not going to be having cities or working or anything in space. So this is an unusual company investing directly in one of the critical technologies of space exploration. Other companies, Vostok Beer, they tried to create a beer, have been working on a beer that's suitable for microgravity. And I should note, microgravity is very difficult for anything that's carbonated because, as you probably all know, carbonation on Earth in 1G, the gas tends to float to the surface and disperse in the atmosphere. In space, it doesn't do that. In space, it actually goes to the center in a ball and starts expanding. And that does that in your stomach as well. And so astronauts who have consumed carbonated beverages have reported wet burps and stomach cramps. Once again, not exactly the result, any beverage company wants from their product in space. But Vostok have been working on a beer that has less carbonation, but a stronger taste, because astronauts report diminished taste as well in space. And so they had used a stout and with less carbonation, similar to a British beer. And they've even tested it on 3 flights on 0G. Yeah, here's a good quote from Neil deGrasse Tyson regarding wine. After we find I can't even read it because I moved after we find space aliens, my next question is there Burgundy wine elsewhere in the universe? I don't know about Burgundy wine, but Bordeaux has actually been sent up into space. Last year, it was actually now 2 years ago, pandemic time clouding my mind. 12 bottles of Bordeaux were sent into space to test whether how Bordeaux aged in microgravity. And this is part of a whole different project looking at all these different elements of how the wine industry might be able to utilize space within their industry to improve the product here on Earth, but also maybe get a head start for future markets. I'm not going to play this video, but this is like another example of wine in space. This is Greg Olson, private astronaut. Greg owns his own vineyard in South Africa. He makes a wonderful Pinotage for anybody who's interested, but he also brought Pinotage grapefruit stocks up to ISS. There's not really an experiment. He's just letting them float in space. But he was hoping to bring them down and create the first wine based on roots that had been in space. But unfortunately, these roots died when they were coming back down to Earth. We won't show that. But another company that's working on, in the wine industry and champagne, who's also working on this, is the champagne industry, Maison Mumm. And Maison Mumm is really passionate about this. They have been creating a space champagne because they literally want, if you're going to drink their product in space on a future space hotel, they want to enhance the conviviality of you drinking that. So they're also creating these little glasses. And so they've done several, not 0G, it's the European version of 0G, so some parabolic flights in Europe. And on the left, you might recognize one of the gentlemen drinking from the glass or trying to catch the champagne in his glass as the famous sprinter Usain Bolt, who they also had him do the first microgravity sprint. Other companies looking into this in glassware. There are companies looking at microgravity cocktail glasses. I actually have a sample of a microgravity cocktail glass here that was 3D printed that Richard Garriott, the private astronaut, gave me a few years ago. There's also a company that was looking at Scotch glasses as well. So other companies looking at how you can consume your alcohol in space, but this also has direct relevance to other areas. It's fluid dynamics. So this can be useful for other beverages you want to consume, but also in spaceship systems as well. There have been a lot of stunts as well relating to this. And as I mentioned, I brought up the wrong slideshow, which has more slides. So I'm going to jump through these a little bit. And so, but one of the key things I also addressed in the book was space farming. And a lot of groups are actually looking at if you can grow crops in Martian, simulated Mars regolith or lunar regolith. Some of them are actually looking at this for whether you can actually create alcohol in space. And so I'll just go through a bunch of them. There have been experiments at MDRS, the Mars Desert Research Station in Europe, and Utah. And they actually literally did a beer experiment by growing, hops and sorghum in simulated Mars soil. There's also a group called Potatoes on Mars, which is a collaboration between the International Potato Center in Lima, Peru, and NASA Ames Research Center. While their focus isn't alcohol, obviously, if you can do potatoes on Mars like Mark Watney in the Martian, you can create vodka. You know, there are other interesting space agriculture experiments going on. You know, up on ISS, they have more than one greenhouse. And on the right, you'll see this experiment named Eucropsis, which is basically testing growing crops in different gravities. They spin the satellite to lunar gravity and to Mars gravity. And so, unfortunately, I believe their greenhouse failed. The spinning process worked, but the greenhouse failed on this project. I'm going to skip through a bunch of this, some of these things. What time is it? Because I want to give time for questions as well. At any rate, as I was mentioning earlier, you know, or as Lee had mentioned, I'm the CEO of Explore Mars, and I'll see if I can find one of those slides. So we do a lot of projects, you know, I'm not going to go into this too much, so we'll hope you'll come to our Humans to Mars virtual conference in this upcoming September. But we also created a new organization related to this topic called, and I don't have the logo here, because as I said, I brought up the wrong slideshow, called the Space Drinks Association. And so the reason for the Space Drinks Association is that as I was researching the book, I realized there were all these different players. They were very interested in the topic, whether it be in the alcohol industry, academia. Literally, there were countries that were working on this, as well in agriculture and the entertainment industry. You know, it was time to bring them all together because they were all doing related activities. So it was time to create a professional organization. So we formed a 501c6. We'll be officially announcing it soon. You can go to the website at spacedrinks.space, but this morning when I looked, there was a problem with it. So I don't know if it's back up, but we'll be making an announcement on that soon. And that will have chapters, it'll have corporate membership, as well as individual memberships. And it'll not just have fun events, but it'll also do actual experiments, you know, whether it be sending experiments up on CubeSats, testing out, trying to find ways to determine how human bodies metabolize alcohol in space, but also looking at some of the negative aspects as well. So not just a bunch of fun, which it'll be that as well, but we're going to look at a lot of these serious issues regarding the potential of future alcohol in space. Because as you all know, I'm sure you've been talking about, you know, we are on the verge of probably the golden age of space exploration. The next decade, as long as something unexpected doesn't happen, the next decade, we'll see more advances in space exploration than we have seen ever before. We should be able to surpass the achievements of the Apollo program by quite a bit, with the commercial sector as well, and all the other projects. So as we saw the other day, just when was it? It was 2 days ago with Virgin Galactic's launch, and Blue Origin coming up. And then in September, a board member of mine, Cyan Proctor, will be flying the first all private crew up to orbit on the Falcon, you know, Dragon. They'll be going higher than the International Space Station. And so with all these new opportunities for private citizens going into space, we know that alcohol is going to follow. So it is a legitimate topic to research, because we also want to do it responsibly and find out if there are any unknown risks associated with it beyond the risks we already know. So I don't think I have anything else. I'm not going to play that. And so thank you very much. And I'm certainly happy to take any questions. And let me get out of share screen.
Yes, you mentioned Dr. Proctor, and she talked about, when I interviewed her for a talk, she talked about the importance of ceremony and milestones in space. And you talked about the fundamental participation of alcohol in the human experience over time. There is some lively discussion in the chat and disagreement about this topic and the risks associated. Talk a little bit about the response you've gotten to this conversation and the pros and cons of talking about alcohol when we talk about space.
Well, generally overwhelmingly positive. And it's actually just FYI, it's being turned into a documentary. So that'll be released next year. But I understand the hesitation because, this is dark. We're not just here, and I'm not just here to, rally around and just make sure everybody can have a drink in space. We want to look at this and look at it responsibly. There is a dark side to alcohol, but there are also many positive elements. But ignore all that for a change. It's a legitimate topic because whether you agree with it or not, I don't think anybody's going to disagree. It's going to happen. It already does happen. The problem is we've done very little studying on it because even though everybody knows it's happening in space now, it's unofficial. It's prohibited. And so no official studies have been done, on how it does impact the human body, whether it really does impact the systems in space. They argue that one of the reasons they say it's prohibited is because the alcohol affects the ecosystems, the environmental systems. That's debatable. But, it's an inevitability. So therefore, it is something we should look at, whether you agree with it or not, to see what the pros and cons, what the dangers and benefits are, because we know it also has played a positive role. The circumstances on ISS, as I said, I haven't found any evidence of inebriation in space, but it has played a critical role in building camaraderie amongst very different crews during times when some of the countries involved have been, well, let's say, have had tense relations. So I think it can play a very important role, and as long as it's done in a responsible way. And probably the best example of how this is done is probably the French Navy is a good example of this. French Navy have bars on their ships. However, they are strictly restricted. You can only have a certain amount per day. It's strictly monitored. And so nobody overconsumes on a French ship. It's done responsibly, like anything else. So I think that's generally how we want to approach it. And I certainly understand people's concerns, but it's also an area I think that needs to be discussed.
Has your book and now the space documentary that will result from it, has it broken the space interest barrier? Speaking of coining new terms, where people are reading it who aren't typically in the audience that we have in this room, space enthusiasts, educated space enthusiasts. Are you seeing a new audience here? And do you believe that documentary will help illuminate the discussion about space to a broader audience?
Primarily, there has been. I can't say that it's been overwhelming that people who have never thought about space exploration or were interested in coming, but I think primarily in areas such as that have been covered in the book, like obviously the alcohol industry. There's been a lot of I've gotten a lot of outreach from folks within the alcohol industry who had never considered this or had been space geeks, but never had thought that they, in their industry, there was any overlap between space exploration. And this is one of the critical parts of the book, and what I like to push with the new organization as well, is that this is one of these areas where anybody, as was mentioned earlier, it's going to take all types of individuals now. It's no longer just test pilots. We need people from all spheres of society, all industries, to be able to participate, because if you're going to build society in space, you need to bring society in space, and that comes with the devices and everything else. And when industries like this do invest, that will advance space exploration dramatically. I don't mean just the alcohol industry, but I am a big fan when non-traditional industries invest in space exploration technology, because you expect the SpaceX's, Boeing's, Lockheed's, et cetera, of the world to invest in space. You're less likely to imagine companies like Budweiser or, getting outside the space realm, other companies working in AI, but that aren't associated with space, or are companies working on architecture or suit, clothing design. And there are a lot of companies that have no traditional ties to space exploration that are now investing in it, trying to play a role, trying not only to latch on to that the sexiness that is, I suppose, associated with it, but really be able to play a role. And I think this is very exciting. And I think we're going to have a very exciting decade, and hopefully several decades, as we are democratizing space, as more and more companies who have no previous experience in space exploration are now going to be involved in trying to invest and trying to look at that innovation that they might have a unique perspective on that could transform sustainability in space or quality of life in space, but at the same time benefit people here on Earth as well. That's one of my favorite topics, and it's also a topic within the book.
Yeah, thank you so much, Chris. I think you're right that we like to idealize our thoughts about space. I mean, you see lovely pictures like we were showing earlier, these children playing in harmony, but whenever you take people anywhere, they're going to be people.
Indeed, and hopefully a lot of them.
Yeah, it's an interesting tangle that we'll have to solve those same problems of human behavior in space as the longer we stay and the more people are up there. So thank you so much. And now that we've enjoyed that discussion, it's a good chance to focus back on our health. The upcoming speakers are some of the world's biggest experts in space health and medicine. We'll start with Dr. Jennifer Fogarty, PhD. She is the Director of Applied Health and Performance at Sophic Synergistics, LLC. Sophic is a human-centered design firm specializing in the integration of human factors engineering and human health and performance into a business model. Jennifer's division develops and expands the application of medical technologies to remote medicine, telemedicine, and home health care. Jennifer has over 20 years experience in medical physiology and extreme environments and was most recently the NASA Human Research Program Chief Scientist. She has dedicated her career to enabling human spaceflight and is passionate about improving quality of life through health and performance. Jennifer, the screen is yours.
Thank you, Lee. Really appreciate the opportunity. Sounds like a good conversation I came in on with Chris. We can chat about alcohol, and the psychologic needs are really at some of the highest needs that we're going to see when you push the limits of space exploration. Let's see, we're going to share some charts with you. So I still have some cool pictures.
We are seeing those slides just fine. They look great.
Great. Yeah, so there's nothing like our imagination and how we've seen it manifest over the decades with spaceflight. So much so with humans out on extravehicular activities are some of the most extreme activities that human spaceflight has supported. And we'll get into some of the reasons why and what we've been able to learn over the past 60, 70 years of the various versions of spaceflight. And to the most recent comments, how when you send people from diverse backgrounds, a variety of ages, and I'm going to get into a little bit more of the health background, how you understand exactly how you're going to manage the risk. And I think how the near-term exploratory activities probably justify, some version versus when we get better at it and we have more infrastructure, how you can start to open that space up. Because it's, a lot of people are like, well, I'll accept the risk. And that's very nice, but you may not even know what it is. So we're going to get at the different categories as well. I mean, there's an area of where you have the knowns, the problems we've run into, the engineering constraints, the battle of up mass versus human requirements, which is always in tension. And then the unknowns, things that we've been able to characterize we need to solve. And then the other space, which is until we get there, we won't know. And how do you position yourself to manage some of those risks smartly? And we've at NASA, the Human Research Program, in particular, has spent a considerable amount of time trying to get ahead of things and do a lot of predictive analytics based on our experiences thus far. So we always have to start back here on Earth. I mean, this is where we've evolved. This is where we understand resources and needs, and when those resources are in jeopardy, how our lives, our health are impacted. But I always put this up to give a little bit of context and pause, because when you leave this planet, you know, on these expeditions, it's not like an expedition on Earth where you might have a shot at using some resources around you to survive. In spaceflight, if you don't bring it or bring a way to contrive it, it's not going to be present. You're not going to pull things out of the vacuum of space without a lot of engineering behind it, or on a planetary surface for in situ resource utilization. So all of the planning and the thought process and the decomposition of how we would even articulate requirements has been an extreme amount of work over the age of spaceflight, coming from government and other, to really try to put forward what would it take to have people survive for very, very long periods of time, ones we have yet to experience. Because when we juxtapose what we have here on our planet and the resources, how we use them, how we survive with them, they're not going to be present on our next target, which is Mars. It's an incredibly hostile and austere environment. If we don't bring the capability with us, or if we don't bring the capability to draw it out of the planet's resources and reconfigure it into a usable manner, it will not be present. So again, how do we start to really document and work through, and we've seen some of the evidence for this with the plans for Artemis, sustainable spaceflight and moving toward the concept of exploration to deep space and colonization of another planet. But when I put the planets next to each other, again, just to start to think about the depth of understanding and being able to articulate on an engineering level, I spent most of my career trying to develop the requirements out of the science, the evidence base, with the physicians and the researchers, to communicate to a program manager or a chief engineer, what does it mean to really fly a human and why? And how does that balance against the upmass challenges? You know, Chris Carberry most recently mentioned environmental control and life support, and how you're going to manage that when you would have a contaminant as something as we take for granted as something like alcohol. It seems like maybe that could and should be present. And I'll have some plausible deniability about what goes on in the International Space Station. You can read it in people's biographies and autobiographies. But the idea is, as a flammable liquid, it's not trivial to have that present in the atmosphere. And something like alcohols could foul up something like amine swing beds, which are designed to remove contamination, including carbon dioxide that we exhale, so that we have breathable air coming out the other way. So I mean, the things we've taken for granted living on this planet, and things we struggle with here. And that's really how I got into the space program, was being fascinated, you know, by the need, the very kind of precise and surgical need that is driven by spaceflight, the narrowness with which you have to get down to expressing a need. But it also tells you, if you were to spin it back to Earth, how we could live more cleanly here, reducing carbon footprint, reducing, you know, waste, eliminating those things. It's very inspiring to think about how we can learn that in such an austere and extreme need, and then bring it back to a utilization on Earth to be better stewards of our own planet. So why do we dare? I mean, that's probably a whole topic for another critical conversation, a day's worth. There have been so many objectives put out there about why humans explore our own planet, nonetheless leave it and risk our lives and the cost. But, you know, necessity is the mother of invention. Until you drive that thing and are inspired by it, I think it creates such a paradigm of innovation and novelty and community. There's a lot of history, and I gave a talk in front of the press in Russia a couple years ago when we had an international crew entering the NEK facility for an analog mission. And I was peppered with questions about, the US relationship with Russia at the time, which politically was not friendly. And I said, we have been able to transcend the politics with spaceflight for a very long time. Not that there aren't challenges and conflicts even amongst the crew and the mission control personnel, but it has definitely given a higher purpose to how we function. But in a lot of cases, why we dare is to reach that next level of capability and understanding of ourselves and accomplishment. That again, I'm a huge advocate for what we bring back. So right now we've been successfully operating rovers for decades on the surface of Mars, characterizing the surface, characterizing the atmosphere, understanding how we might live there. And although these blueprint images come from Apollo, it is our mandate to turn those rover tracks into blueprints and have the human capability, the problem solving capability, and the curiosity driven exploration that would happen on the surface with humans there and what they observe and how they might prioritize what they're going to do next while they're on the planet. I think it's a critical activity for human spaceflight to move in that direction. And I do think lunar is the right step to get us there. There's a lot of things we have to learn to do it safely and accomplish it because the transit to Mars, if I go back one, while I put these right next to each other with some sense of relative size, Mars being 2/3 the size of Earth-ish, was that it's going to take you on the order of 9 months to a year to get there, unless we have a radical change in the propulsion system. And you're going to have to remain on the surface either for a very short period of time, say 30 days before you do the return to accomplish it in that same time, or you're going to have to wait about 18 months. And we can talk a little bit more about why that is the right paradigm, because when the human is out in deep space, unprotected by any planetary body, they're the most vulnerable. So you're trying to truncate that exposure and optimize your time on the surface. So all these things are always in tension and trying to be balanced. And so you see a lot of different architectures put out there to decide, depending on what the goals are and what the limitations are of the technology, what's the best strategy to get those blueprints on the surface. But I think it's always important to step back and really start to articulate, again, why we do this. It gets lost in the noise sometimes, and there's all these arguments about how money's spent, and we have a lot of problems on Earth where maybe some of that money could be better used. But when you look in the long term and you're investing in the long-term future of humans, I think this is really something that is inherently important to our society. So let's talk a little bit about the challenges that we're going to face. And they're not in a particular order. I actually meant to reorder them last night because I didn't want to imply that radiation is actually the scary one because of what we don't know. Obviously, there's data on Earth about different types of radiation, but I've been working in this field, like we said, for about 20 years. And as chief scientist of the Human Research Program, this was in my face on a daily basis, trying to trade all the knowns and unknown problems against each other to decide what's the right research portfolio and how do we burn these down so we feel we have evidence to make decisions. And again, it's that no one piece of evidence tells you what to do, but it gives you something to work with to decide how you might go about addressing the issue and being transparent. That was a huge part I was part of the development of what's called the Health and Medical Technical Authority after the Columbia tragedy. And one of the findings of the Columbia Accident Investigation Board was about this transparency throughout the decision-making process, that you get to reflect back on a decision you made when you have a new opportunity to decide differently. You always should be in possession of the data. And I think that was something my company and how I operate the division now is all about being data driven. It doesn't decide for you. And we can get into like even artificial intelligence. It shouldn't do it for you, but it can definitely give you insights that as a given individual, you are not capable of consuming all of the information from all the different disciplines. It can be quite overwhelming and you need some help getting signal and all that noise. So when it comes to radiation, there's a lot of research going on planet Earth with analogs that try to mimic what's out in space flight. I think Artemis and some of the capabilities with commercial space flight are going to be able to get us better characterization and do a lot more experiments in space. Because one of the biggest drawbacks that drives our confidence down with understanding what radiation means to the human is that our experiments on Earth are very contrived. And that's just by necessity. That's not a criticism of them. You just can't holistically recreate the deep space environment. But why? You don't have to. You got to figure out how to get experiments up and in that domain, and a good way of doing it, being efficient. But radiation is a looming problem. You know, it can do a lot of damage to the body. Strong enough at times, you know, solar particle events, very acute radiation damage that we know quite a bit about. And we need to prepare the crew and have a medical system. We'll get to the totality of the medical system. But it's really the long-term effects that kind of build over time. And it's not happening by itself. So when we talk about altered gravity, you know, we're going to do spaceflight, you're going to go through a lot of different transitions from launch, which have some acute exposures to G-forces, which are incredibly well characterized usually, and we can manage those exposures. Then you get into microgravity, which we've learned a lot about, especially with the International Space Station, where we've had people exposed for extremely long durations. You know, regularly 6 months, 8 months, 11 months. We've done intentional 12 months. The Russians have done intentional and non-intentional 14, 16 months. Sometimes traffic vehicle models just don't allow you to come back. And you got to take that opportunity to say, well, when someone was, you know, serendipitously extended, how do we get more data out of this? How do we make sure for the individual's health themselves, but what does that mean to the whole in terms of how that data is used and how we can do better observation? But what's interesting, and I think kind of gets, you know, not discussed in the totality of things, is that changing gravity environments rapidly is the biggest, most disruptive thing to the human. We equilibrate actually pretty well when you go into an environment over time and you learn to live there, and you have to allow some adaptation to occur so that someone can function well. But then on the order of minutes to hours, we drop someone into a very different gravity environment, and suddenly, such in the case of landing on a planetary surface, like, let's get out and get in those suits and do an EVA. And you're like, they got to relearn to walk again. You know, this isn't going to be a trivial task landing on a planetary surface. The trip to Mars, or to the moon, is pretty quick. Obviously, Apollo has taught us a lot about that, and we're gonna see more and different types of activities done by the crew, I believe, during Artemis. But what you're saved by is the transit time. Anytime you're going to go long duration transit and have a lot of microgravity, which means lack of signal, and I think that's something to point out. It's not an overwhelming experience by the body. It's actually, you know, the body's like, this is pretty interesting. You're not asking a lot of me, so now I'm going to detrain. And it's a natural process, actually. It's not pathologic. It's very much disuse atrophy, and it is very recoverable. So this kind of gets lost in a lot of the discussion that sometimes change is okay. Like, just because the system changes isn't something you should stop. Everything cannot be Earth normal all the time. But where is that balance of allowing a body to adapt to something like microgravity over time, but still being prepared to enter another gravity environment and be functional? And it's those that you have to watch both. And that's why, you know, the idea of countermeasures and kind of buffeting the changes that might happen during extended microgravity exposure occur. For hostile closed environment, I mean, you're really dealing with a place where environmental control and life support, the pressure shell, you know, are you going to operate at 1 atmosphere? Are you going to have 21% oxygen? How high can we let the CO2 go? This is something that spaceflight programs have been struggling with on an engineering level, because we can't reach Earth normal with a lot of the constituent gases. And it doesn't seem like an obvious, you know, change from what we have here on Earth to drive a significant problem with humans. But what we've learned between the microgravity and probably the carbon dioxide and some of the other stressors, radiation may be a player. It doesn't, we can't measure it in low Earth orbit as a factor, but is one of those variables in the background that might be impacting someone biologically. But we have stuff happening on the International Space Station, predominantly the disorder that's known as space-associated neuroocular syndrome. Something is going on in the brain and the eyes, the central nervous system, with the pressures associated with cerebral spinal fluid and the venous tract. We've seen some clots happen, that we've been able to accumulate about 15 years worth of evidence that says something is changing in a way that we think it leads toward more bad outcomes than neutral outcomes. So this is something that, spaceflight at large for humans is going to have to understand who's really vulnerable. And we can talk a little bit about precision medicine. Isolation and confinement. I saw quite a few attendees who probably know a lot about this and can speak to it in much more in depth than I can. But isolation and confinement is not an insignificant psychological contributor to stress. And, psychological stress, physiological stress, your body is managing them biologically. And you can get into vicious cycles of, it doesn't matter which one kicked it off, but once that stress is kicked off and you have a neurohumoral response, it can be very challenging to get back out of it. So isolation, confinement, and the idea of having a team of people and understanding the roles of the individuals, how they function as a team, and how those dynamics change over time has been a significant part of the research, because we don't really have experience with this small concept team going for 3-4 years. And how are they going to change over time that may impact all of that. And of course, distance from Earth is always something that really drives some of our modulation of risk. If we can get people back on Earth to deal with the problem very quickly, that seems to ameliorate a lot of the concern. Like, I don't have to take it with us, we can get them back, or they're coming back naturally. And that's what's really going on with commercial spaceflight right now. You can take a lot more risk with a given individual. One, if it's a short-term mission, and it's unlikely, if you do a lot of preventive medicine and characterization of their health, that something's going to manifest in 3-4 days or 10 days to 2 weeks. When you start pushing the limits of what medical observation and testing can tell you about the health of an individual, and that's on the order of about 6 months to a year. And there's, when you think about the logical cycle, why would they recommend an annual exam? Those are kind of the limits of understanding, if I look at you now, what are the odds of something cropping up between now and the next visit that I have to worry about? And that's definitely still working on a symptomatic level, even if it's before it's clear to the human, say something you could pick up in urine or blood markers. But it has a medical evidence base to interpret it. Once you get outside the 6 months to a year, a lot more can manifest that you just couldn't have picked up as of now. That is changing rapidly with the onset of molecular medicine and precision medicine. But it's going to take a bit longer for the data to accumulate so that people are confident they can interpret it. So I always describe between that and the microbiome, it's a little bit of the Wild West. Like, you'll see studies quickly, and the pandemic has really, I think, sharpened the edge on this conversation as well. Like, you're tempted to interpret that data because you measured it. Now you want to, can it be correlated to something? That the level of causality is still very much in question and will emerge over time as more studies are done and more data supports that conclusion. So distance from Earth, when that no longer becomes a risk mitigation capability, such as deep space exploration, transit to Mars, where it's a one-way trip, that changes very much the thinking about risk posture until we can really be prepared for sending people who maybe are not the healthiest. Those first crews that are going to go out, you just don't want your baseline health to be the issue that you have to be struggling with. You got a variety of other challenges that are going to be pushing the limits. So, that's why I really have always talked about initially, and I get the concept of colonization being off in the future, but when I break this conversation down to exploration, you really want to be built on a foundation of health and fitness for exploration. And when I talk to groups who do technology development or work with technologists, they're like, well, what does it mean? They have their solution, and it can be very exciting to think about how you're going to solve the problem of bone density, or how you're going to solve the problem of muscle atrophy, or, do you need a treadmill, or, what are you going to, artificial gravity is always the one that comes up. Do you do it in a module? Can it be done? Can you spin the whole vehicle? And there are engineering studies to try to describe what the costs of those things are, how challenging and potentially like the complexity goes way up with the vehicle design, and how much biological benefit do you get? And it's been really challenging to quantitatively put those things against each other. But there's no doubt, when I think about the spin back to Earth again, what does spaceflight need? It needs things that are autonomous. You can't be, the further you go, the ability to operate things from a distance is possible. We've seen that with the Mars rover. However, that doesn't help the human in the moment. And waiting 20 minutes for a command is not realistic. So driving toward autonomy, and probably I should change some of this verbiage, because there is a difference between autonomy and automation, that at times the technology can be automated. It's operating itself, it has internal checks, and delivering something for the mission in the context of the mission, either to the human or to the vehicle, other machines. But autonomous is that in the case of the crew, they can operate without ground support. And that could be in concert with an automated capability, and some artificial intelligence or decision support is what I think the language that we've had been using at NASA for quite a while. And you can upload from the background at a reasonable rate in terms of new knowledge, but that the knowledge is present on the vehicle with the people to inform how they should make decisions. And it doesn't decide for them. It just gives them the most relevant information to decide. Light and lean is always, something that's absolutely required. You got to get off of planet Earth. Anything that's heavy is expensive to fly, and it's competing against other resources like food and water. And I know earlier today, a discussion about food in spaceflight, and when you're trying to trade off against 1.5 liters per person per day, or 3 to 5 meals, and how many calories is that? It sounds like we should be doing better than that, but it's still always compared to the launch mass capability with everything else that has to go. Comprehensive, and what I mean by that is that it can't just consider solving one problem at a time. So often when we've talked about analytics on spaceflight, well, people want to measure something, say in blood or sweat or urine or whatever it happens to be, but you also got air and water to characterize. And so this device should be agnostic as to the source. And so you have to think about technologies that measure things differently than maybe the way we do them here, because we have the luxury of counter space and power, inputs and reagents. That's the other issue. Things that you have to mix and become toxic or throw away are all complications that are really not tolerable for spaceflight. Data and predictive analytics driven. There's the capability to pull a lot of data out of almost everything we have. I'm wearing smartwatches and different devices to keep up with biometrics, and it pulls a lot of data. Sorting through that data can be incredibly challenging about what's meaningful. So it's not data for data's sake, but in a structured way that it can be informative. And that's going to take a lot of work on the ground to understand what that means. So those things are in work now, but I don't think we're kind of, and it's like this amorphous goal, right? Moving forward, we want to improve healthcare. We want to improve, efficiency and remove waste from the system. But, it's kind of just in this gamish effort. Spaceflight narrows that. We need it here, and I love it that we get a date, and it says, here's when it has to be ready by. That structures and drives accomplishments that maybe aren't present by other needs on the ground that are present, but maybe we don't have the biggest driving force. Agile and responsive to a changing environment. It sounds like, I'm asking for everything all of the time. So agile and responsive to a changing environment. Going back to the crew's gonna be flying in, unless artificial gravity is present, a microgravity environment for extensive period of time, landing on a planetary surface. That device has to work in both environments. And not new equipment, not different equipment. How is it going to cope with things like dust contamination on a planetary surface, or can we figure out a way to mitigate that? The agility really is going back to the idea of, well, if you're measuring a sample and you want to know your water quality, and the next sample that goes in happens to be human blood, and you need some result out of there because you're doing your weekly check-in, that it needs to be agile in that way, and not exclusive, because you're not going to be running 5 to 10 different type of analytic devices. That's just not a possibility. So there's just all this criteria that when you talk through, it just keeps on narrowing and narrowing your focus, but making you think about operating in a very different paradigm, which when I juxtapose it against the medical community and having kind of this gold standard Cap and CLIA labs that they have that produce the results that says, the doctor trusts those to make a decision from, and you're going to come in with a completely unorthodox way. There's definitely that valley of death present that says that they're not going to trust it because it doesn't have 100 years worth of history behind it. But when you transition, I see Dorit is here, when you transition technology to operations, in our case, in my history, it was space flight and medicine for space flight. Hopefully we can get it to the point where the clinicians understand that it is different but equal in terms of the quality of results, and understanding what work that takes to compare to the gold standard, so you come in with credibility, but it's a completely new paradigm of how you're going to do the work. And so we just have to be prepared. And it's been challenging to say, well, who's going to fund that? Because it's probably, nobody wants, what's the charge code, or who's going to do the reimbursement? There's a lot of that bureaucracy around how do we make progress. And that does come from the top down. When you get mandates from the administration, from the president, people who are the large philanthropic organizations who have a vision for the future. If we don't make these investments now and begin this, we will never get there in the end. You can keep on, using what you've got today and kind of fixing the broken solution, or you can commit to a different way of operating, do a lot of testing quickly to rule what will work in and what won't out. And then, it's always like, I grew up in a casino town in South Jersey, Atlantic City. And I used to tell people, I'm like, you make those decisions quick, you pick your horse and you go, and you have to be monitoring it and get feedback from whoever's in charge. But until someone commits to that type of paradigm, which is what the innovation paradigm really is, we're not going to see those disruptive innovations come forward. They may fail for the wrong reason, which is when they showed promise, they were unorthodox and not invested in. So you do need that advocacy and that passion to drive something forward when you've got a winner, and convincing other people that this is the one you should go with. So that's what I'm doing now out in the private sector. And it's challenging. It's a whole new set of skills I didn't have before. So it's good to learn.
Jennifer, I'm excited for the panel coming up. And I really appreciate this discussion, as a science leader, not just as a scientist. You've really hit on some of the challenges that face science leaders, and prioritization, transparency, the challenges of discipline in terms of not interpreting data before it's ready, and then cost-benefit analysis of where you'll spend your time and resources on things that will provide a return on your investment, whether that return is financial or otherwise. You mentioned timelines, deadlines, incentives, and resources. So thank you for that overarching discussion with all those key components of leadership. And we'll hear more from you in the panel.
Thank you. Appreciate it.
Dr. Dorit Donofiel leads TRISH, a NASA-funded institute that finds and funds new approaches to reduce the risks to health and performance of humans exploring deep space. She is also an associate professor in the Center for Space Medicine at Baylor College of Medicine in Houston, Texas. As executive director for the Translational Research Institute for Space Health, Dorit leads a $250 million NASA-funded innovation R&D program that finds, funds, and facilitates disruptive human health and performance solutions for astronauts traveling in deep space. In her previous role as deputy chief scientist of the National Space Biomedical Research Institute, Dr. Donofiel led both domestic and international research programs that bridged academic, industry, and government resources to deliver fast and cost-effective tangible results. She is the recipient of multiple honors, including recognition from NASA and the NSBRI Pioneer Award. Dorit, you have the screen.
Thank you. So I assume you're seeing everything and hearing anything unless you tell me otherwise. So it's always both a pleasure to follow Jen because she covers everything. So you can skip things through your talk, and which is great. And she's incredibly thorough and so broad. But it's also a scary thing because she's such a good speaker. Jen and I have known each other for a long time, and we continue to work together to enable safe and productive humans in space. And so excited to see what her next chapter in her work brings us. So thank you to the organizers, Lee and Chris and Sarah, for inviting me. I'm really pleased to talk about human health in space missions near and far. And what I mean by this is that in near orbit missions that are near to Earth, low Earth orbit, suborbital and orbital flights, and maybe even moon, one could imagine it's kind of near. And then Jen talked a lot more about those far-reaching missions, the ones that go out to Mars as well. So we're going to touch on all of these things today. So our mission with Trish, we call it Trish for short because it's just too damn long to say the whole thing. We're really excited because we have an amazing partner in NASA. NASA is continuing to make very steady progress to reduce the health risks to humans exploring deep space. And it is, a large program, the Human Research Program, of which Jen was chief scientist. And they wanted a partner that was a lot more agile and was able to take risks that the agency itself could not do. Some of those things would work out and some of those things would not. And what we decided to do in setting our mission is really to kind of make sure that as we look for solutions to reduce the risks to human health and performance, some of which Jen covered in her presentation, we want to make sure that we do so considering any type of human that would go to space. We are a consortium that is run out of Baylor College of Medicine. So I am a faculty at Baylor. And we also have consortium partners, MIT and Caltech. So why is space exploration difficult? I don't need to belabor these things. Jen did an excellent job covering these particular hazards. What I will say to you is that all of these hazards, when you put a human in them, you start to see an adaptation to space flight, and every single organ system is affected in space flight. And you can see across the board, these are just a sample of some of the things that we've noticed after studying roughly 500 people who have been to space for the last several decades. One can even envision that space is like an accelerated aging model. You could see similarities in a lot of these organ systems. And some disease models, for example, like osteoporosis, is greatly accelerated in space. So one could start to study the early steps and maybe even the early biomarkers of disease processes in the space environment. So it presents us with an amazing opportunity to really kind of learn about disease processes in a situation that's highly controlled. So one can say that some of the changes that occur in these cosmos sapiens, if you will, I'm sort of borrowing the term. There's actually a musical group called Cosmos Sapiens. There's also a book that was written called Cosmos Sapiens. And lately, if some of you have been watching the Virgin Galactic launch on Sunday, they were using this term as well. Some of the adaptations that you see may be adaptive. For example, Mike Barrett, the astronaut, always talks about the fact that the tops of his feet became calloused because he was hanging on to things with his feet, the top of his feet, whereas the bottom of his feet became very like a baby's foot, very soft. So that would be considered an adaptation that is an adaptive change in the Cosmos sapien, if you will. But some of these changes are actually maladaptive. So for example, Jen mentioned the SANS condition, the spaceflight associated neuroocular syndrome. We don't know yet whether it's truly maladaptive, but we are concerned about it. We're keeping an eye on it. Bone loss is maladaptive when one introduces the Cosmos sapien back to a gravity environment. But in the zero gravity environment, having less bone is probably okay. So one can see as we start to transition from different Gs that these adaptations can become adaptive or maladaptive. So we've learned all this from over 60 years of space flight. And as you can see here, it's a fairly small human sample of roughly 500 people. And a large percentage of them are American astronauts, and there have been many Russians as well. And only 12% have been women. And this is changing. More recently, the astronaut classes have been selected, have a lot more diversity, which is a really wonderful thing. But we have to study them for a really long time to start to understand the gender differences as well as the ethnic and racial differences as well. So, what I'm excited about is this new space age with all these companies, some of which have been supported by government contracts like with NASA and other international companies as well. We now have an opportunity to start to study different kinds of people. And so, as a biologist myself, I always think of increasing the N. We are actually looking for more individuals and more diversity. And so in the future, in fact, as we go from 88% professional astronauts in 2021 to a future in roughly 20 years' time where 80% of the participants will actually be private participants, as you can see here, going from 1% private to 80% private with the advent of commercial spaceflight and the opening up of the skies for all kinds of people. We are going to be seeing all kinds of different things in these individuals that go up. So what's the problem with that? Well, there is no problem really, but we just have to keep an eye on it. As you can see here from this lovely picture of the 2017 NASA astronaut class, they're all fairly young individuals. There are women, there are people of color in this group as well, but they tend to be extremely fit and very healthy, and they were selected for this, in fact. What's the problem with commercial spaceflight? Well, all kinds of people can fly, and we can do so safely. I really believe that we can do so safely. But for example, it was recently announced by Blue Origin that Wally Funk, at the age of 82, will be flying on the very first suborbital flight with Blue Origin. And there have been other individuals who are fairly older as well. Richard Branson, for example, although he's probably very fit, I don't know, but I assume so, was 70 years old when he took his flight on Sunday. It's a very short flight. John Glenn flew at the age of 77, and there have been other older astronauts as well who've done quite well. But remember, a lot of these folks were really carefully screened ahead of time. And while some of these commercial spaceflight companies will be screening their passengers, some will do a little less screening than others. So we kind of do have to keep an eye on this. So, coming back to Trish, and what are we doing? We are partnered with NASA to support the development of health technologies for the agency to support the upcoming Artemis missions, which will be in lunar orbit, as well as the deep space transports and eventually the mission to Mars. And so, why does it matter to us that there's commercial spaceflight? Well, one thing we noticed is that the commercial spaceflight orbital missions, at least the ones that SpaceX is planning, they're coming up with the Inspiration 4 flight, for example, coming up in September, resemble the early Artemis mission profiles in the sense that it's a very small craft with probably 4 crew for Artemis, maybe up to 6, in a very confined space with very limited capabilities from medical and all kinds of other behavioral countermeasures. So we really believe that by studying these early orbital missions on commercial spaceflight, we can start to get a sense of what it's going to be like for those early Artemis mission astronauts as well. So what's it going to take? Well, as you can see here, the commercial partners really are working hard to democratize space for private citizens. They're working very quickly. They can have a desire to contribute to space research for their own needs as well, because they want to make sure that they can take more people up, even with pre-existing medical conditions. You also have crew, private participants who are really interested in contributing to science and to the understanding of humans in space. And they bring with them a diversity of different kinds of human subjects and also being able to increase the number of participants. Whereas our institute brings to the table a lot of scientific rigor, the backing of NASA, our experts, and all the folks who know how to implement science in space that makes sense. So our priorities in looking at this new market for health biomedical research and biomedical research in commercial spaceflight is really to come at it from the perspective of reducing the health risks to all types of space explorers, not just the NASA astronauts, but also those private citizens, because it is about what we give back to the entire sector. We bring science with us, really rigorous science, and we want to standardize and collect the data, as Jen mentioned, in a way that makes sense. And we want to put all of the data that we're going to be gathering in one database that will be absolutely accessible to NASA, to the FAA, to the commercial spaceflight providers, to research organizations, to individual investigators at universities who want to study it. So increasing the N is what we've called our initiative. And the N, if you know anything about statistics, it's the number of people that are in your sample set. So the more number you have, the better. Your confidence then is in that what you're seeing, the phenomena that you're seeing is actually not a fluke, but actually is a meaningful correlation with whatever change you're studying, which is in this case, spaceflight. So our research-driven program is really focused on making sure that we remain provider and mission agnostic. We want to standardize and normalize. We want to make sure that we do enough standardization across the data so that we can go over that data with a layer of metadata and start to apply artificial intelligence and machine learning to see if we can see some correlations and some predictive models. And we want to make sure that whatever program we put in place, with whichever provider, does cover the internationals and protects their privacy, and everything that we do will be reliable, reproducible, and safe. So some of the emerging Artemis analogs are as follows. We have probably the furthest along in terms of our progress is a relationship with the Inspiration4 crew and SpaceX, who will be running its very first completely commercial orbital flight on September 15th. And this will have a crew of 4 individuals who have never before been to space. It'll be approximately a 3-day orbit around the Earth, slightly higher elevation than where ISS is. And it's going to be taking up 5 Trish-sponsored research projects. We're also working with Blue Origin, and we're going to be helping them establish a research capability as well. At the moment, Blue Origin is only thinking about suborbital flight, but they do have plans to go into cislunar space in the future. We're also in talks with Axiom as well as Space Adventures, and we're also looking at the Australian Antarctic model because they have a very interesting concept of operations in terms of their medical and their behavior setup that would really mimic a lot of the concerns we have for deep space missions. So we call our program, this research program, Expand, and it's a menu of low burden Trish research projects really developed to collect data from the spaceflight participants. What do I mean by low burden? And I'll tell you about that in a minute. And the Inspiration4 projects kind of have a fun little crew patch, essentially not crew patch, but a researcher patch for the mission that we developed. So these are the researchers that are taking part in this. The low burden, what we mean by this is that this is supposed to be a flight that is, number one, going to be focused on high priority risks for NASA. And so for NASA, with Artemis in mind, and even for Mars, radiation is an important concern. Medical capabilities, that's that distance from Earth that Jen talked about. Let me check on the time. The behavior in terms of the confined space. Remember, we talked about the confined space in the Artemis capsule as well as on the way to Mars. And sensory motor. Sensory motor is an important concern for us because as we're conceiving of those early Artemis missions, the crew is going to be undergoing G transitions, very rapid G transitions over a short period of time. The second thing that I wanted to mention here is the focus for us in selecting these research projects was around what is relevant for 3-day orbital flight. So for example, over 3 days, from what we know from studying 500 people over 60 days in space, bone is probably not going to change significantly over a 3-day period. So we didn't choose a bone study. But there are other changes that made sense. For example, the sensory motor, the behavior concerns, et cetera. So we had to kind of select things that were low burden, as I mentioned before, minimally invasive, minimal crew time requirements for training, and for them to actually execute. So the other two factors that I wanted to bring up, and this is very, very different from the NASA-sponsored research program, in that you have professional astronauts whose job is to participate in the research that NASA is executing so that we can study them. These are individuals that are going to space because they want to, because they want to enjoy themselves. So we really have to come at it from a different perspective. Rather than try to burden them with things that are going to be very difficult to execute, very difficult to train, may make them very uncomfortable or sick, or maybe painful for them to execute, we're going to find things that will be fairly minimal for them to do, and really things that are lightweight, things that would require very little integration with the vehicle. That was the other thing that was a major concern for us, because if we want to remain vehicle agnostic, we didn't know what vehicle requirements or constraints we were going to have in the future. And some of these things are still being developed by each of the providers. So maybe today Dragon is not able to give us an interface with the vehicle, but maybe in 2 or 3 years it will. So we had to work with a paradigm where we could be completely self-contained. And so we came up with the menu of these projects, and I'll tell you about them in a minute. Now, what's amazing about all of this is from soliciting the proposals to the moment where we actually had all 4 passengers of the Inspiration 4 crew consent to our wide-reaching IRB, to the full complement of the Trish projects, and the collection of baseline data was 5 months. Solicitation to consent of crew and collection of data, 5 months. Now, if you ask my Trish crew whether they want to do this again, they'll tell you, heck no. This was incredibly difficult on the team to execute it quickly, but it can be done. And that's the point. We're sort of nimble, entrepreneurial, and we can demonstrate a very quick turnaround time when we need to. So these are the experiments that are going up. I'm not going to go through all of them. They're going to be monitored with an Apple Watch that will collect a whole lot of different kinds of parameters. And this data will be opened up to us by Apple itself. So this is not consumer data, but will actually be research grade data for us. The crew will be doing neurocognitive performance on their iPads. We will be sending up a space dosimeter. It's not just a passive dosimeter, it actually collects spectrometry data. And this is an elevation that's never been tested before with this dosimeter. It's above the ISS. And we also don't really know what is the space radiation profile inside the Dragon capsule. So this is going to be incredibly important for us to understand what the risk profiles will be for when they go to the moon. We're also doing in-flight saliva and blood analysis with a very miniaturized device. And this will not be using venous blood. This will be just from a pinprick of blood from their fingers. So this is something very easy for them to do. And they'll get data right away on their iPads. We're also going to do pre and post flight markers, and we're going to collect a dried blood spot in flight, because there's really no way to have cold storage. So we can't take blood samples and keep them cold, but we can collect the dried blood spot in flight and compare it to pre-flight and post-flight blood and saliva and other biofluids as well. So we're looking for biomarkers. We're looking for things that will change in flight and whether we can predict them in markers that will be collected ahead of flight. We're also going to be testing for the first time the butterfly ultrasound in spaceflight. The butterfly did go to the ISS with a resupply mission, but it has not yet been unpacked. So I'm not really sure whether the ISS will open and use it first or whether the Inspiration 4 crew. I assume the ISS will go first. But Butterfly is a really highly capable ultrasound system every single medical scan, up to 14 scans throughout the body, are enabled by one probe, and it ties into your smartphone, an iPhone or an iPad. And it could do every part of the body, and it could do every kind of scan that you want to do. And it's driven by an AI so that it actually helps the user align the probe properly. And so this will be tested. This is a medical capability that will be very helpful on an Artemis mission or even a Mars mission. And this will be used for the first time by novice users, and will particularly be interested to look at the internal jugular vein to see how the blood flow happens, because there is an emerging concern with thrombotic risk in some of the astronauts as well. And then pre and post flight, we're going to be doing sensory motor testing, how to predict how they do with the G transitions and the readaptation, and the biosample collecting. All of that will be stored and analyzed and available to be mined. And the Hermes database, this is first of its kind, a capability of bringing together medical data that was collected by the flight provider in screening the passengers, the environmental data that will be important to analyze what's happening to the crew in flight, and the health research data. All of that data will be combined in one database. And it will be able to be parsed out by the access providers. So SpaceX will have its own section within the database. Blue Origin may have its own section. Axiom may have its own section, et cetera, et cetera. But we can do metadata analysis across the different mission profiles. And we're going to be able to collect from the entire health continuum. So the database itself will have data from before they went to space in case they have any medical issues, their space flight, as well as after. We'll be able to collect data after their space flight. So the vision for this Hermes database, and it's so exciting because it is a state-of-the-art capability that's being used now by pharmaceutical companies and research organizations to execute and collect data from drug testing. So this is a real world solution. We're not building it from scratch. We're just modifying what's already built and being used by the industry for our own use. And the idea is that everybody will be able to look at this data. Essentially, the providers, the spaceflight providers, will be looking at this data to increase participation safety on the near Earth missions, as well as NASA being able to optimize the health of people who go to Mars, also using this data to understand what happens when you take somebody into a spaceflight environment when they have a pre-existing condition. And with that, I will stop. I think we are back on time. Thank you.
Thank you so much, Dorit. Questions, but I will put them down to the panel. I'm excited to have you all come back for the panel, and really appreciate, and there were several comments about your beautiful graphics from in the chat. So our next speaker is Aliris Allman. She is an innovator and orchestrator connecting cross-disciplinary ideas. She fuses a deep passion for science's opportunities with the emerging pathways delivered by technology. She advances the consideration of the social and cultural impacts of technology in equal importance as its innovative impacts. Aliris founded Deep Space Predictive Research Group to push the boundaries of social science and behavioral technologies to be utilized in space mission planning, and she leads an international research team whose goal it is to create new behavioral technology to support that mission. Aliris works extensively in the Colorado aerospace community, serving 3 terms as the chair of the board of directors for Colorado Space Business Roundtable, or CSBR. In this capacity, she is also a vice chair for the Colorado chapter of the Aerospace States Association alongside the Lieutenant Governor of Colorado. Aliris also serves as partner director of the Artificial Intelligence Institute. Aliris, thank you so much for joining us today.
Thank you, Lee. Thanks for that introduction. And hello, everyone. I am really excited to be a part of this. So thank you for the invitation from Foundation for the Future. And as I've been listening to everyone, it's like perfect is Jennifer talked about the biggest picture ever, where we're going, and then Dorrit gave us this really focused view, and I'm about to bring it down to another smaller view. So we're creating a funnel here as we go. So I'm going to share my screen here, and like Dorrit, I will probably be running blind here a little bit. Let's do that. Share this, and then so are you seeing, what are you
I think we're
seeing?
seeing your presenter view right now.
Got it. Okay, so let's stop that. Bring this down. I've been working with technology how long? And this is what happens here.
They keep
So
changing it on us.
they really do. They really do. So I'm going to just give you my whole presentation here. If it keeps going, that's not where I want to go. It's not showing the right screen. We're going to make this happen. There we go. And now do you see a presentation?
Yes, now we can see it. It looks perfect.
Yay. Thank you. So what I'm going to talk about today is really getting down to, as you've heard the first couple of speakers in the human spaceflight, one part that Dorrit brought up was the psychosocial. And this is where deep space predictive focuses on. As you can see, with my background, I have worked in a lot of application of the technology and working with that. And one of my passions is bringing behavioral health into the conversation of deep space exploration, or space exploration, period. I like something that Jennifer was talking about earlier, is where your behavioral health is manifested in your physical health. And Dorrit is bringing both of those together. And this is an opportunity for us to really understand what it means to bring that psychological piece into the conversation when we talk about space exploration. So what we're going to talk about today is understanding what I mean by measure of a man, and not to be sexist or anything. We're talking about diversity, but it is an acronym, obviously. But exploring the new space economy, Dorrit touched on that as well, and how that impacts space exploration, and then the deep space challenges that we have when it comes to the psychology of working here. So we're talking about the psychosocial aspects of that travel. So when we talk about what are we measuring and who are we sending up, we have to make sure that the vehicle can get us there. We have to make sure that the human body is maintaining itself, is healthy. All those challenges of, radiation and making sure bone density, and finding all these new challenges and experiences as we go into space, how that affects the human body. But the other part of that, and it's been talked about a little bit in the isolation and confinement, but it's also what kind of person needs to be able to withstand all of that, all of those challenges that they're going to experience when they go in space exploration. So we talk about a new kind of crew member, talking about the emotional awareness that person has to have, that they have to have a bond within the group, and making sure that they have what we call a high crew citizenship, which is a takeoff of organizational citizenship from industrial organizational psychology, which is where my background is, as well as the application of behavioral science to space exploration. And also, when we go, the deeper we go, the more isolated the crew is going to be, and the more autonomous they're going to be. So they have to be conscientious and be self-managed. And so those are the types of characteristics, in addition to everything else, that we've talked about, that need to happen, because all things being equal, when you talk about how a crew member and a crew survives, they're going to have to depend on each other. It's not an isolated experience for each individual. It's a symbiotic relationship with each other and with the vehicle in and of itself. So those are the things that we'll be, talking about and understanding. How do you identify and manifest this new type of crew member that's going to be needed when we go into deep spaces for exploration? So when we talk about man, we talk about measurement, understand how you measure these characteristics that we need for the crew members. How do you align those characteristics to find the best crew that can work together for the longest period of time? And then how do you nurture their tools so that they so that they can self-manage and understand the implications of what it means to go without contact with your family? How do you manage that isolation? What does that look like when we're going to Mars and that mission is 36 months, even though once we get there, it's 9 months, but staying there and doing their work and then coming back. So that's a whole different kind of mission that we're talking about. So when we talk about measure, we're looking at individual differences, emotional awareness and intelligence, and then remote monitoring of physical health. Dora was talking about some of the measures that they're using, and that's going to be vitally important because the physical health is a reflection of their psychological health. But when we talk about the individual differences, the other piece of it is the emotional awareness and intelligence of those individuals. Because if you listen to a lot of the analog astronauts or even the current astronauts, they talk about the hardest part is the interpersonal relationships. How do you manage that? And they get kind of caught off guard about the importance of that interpersonal relationship because we're focused on, vehicle maintenance, keeping the human body alive, doing those types of things. But what if you don't get along with your crewmate who's just as capable, who's just as driven as you are as an individual? So how do you manage that? What is the role of a crew leader? How do we understand? So what we look at Deep Space Predictive is measuring all these individual differences and then putting those individual differences into alignment and focusing on group cohesion. So at Deep Space Predictive, we believe like the crew is the smallest unit of measure. We're looking at how those individuals come together, we create what we call a cohesion score in creating understanding how a group will work together. And it also depends on the type of mission. Can a group get along, for 3 days or 3 months or 3 years? Those types of mentalities and cohesion is going to be very different based on those missions. We talk about psychological safety. How are you going to be vulnerable in order to grow and enable and be flexible in the work that you're doing, because this is so high stress? I mean, life is on the line in such a different way when you go into deep space. I love all the different studies, Dorothy, that you're doing around, getting data, getting information. Jennifer talked about how important the data is in making decisions, but there's also biases in the data. There's also how do you receive that data? How is it shared? When you there's been a few studies about creating a psychological dashboard for people to understand their relationships with each other. That can get kind of dangerous if you don't have psychological safety, if people aren't willing to be vulnerable, if the culture is psychological challenges that will emerge. It's not if, it's like when they do, how do you manage it? And then what we try to think of is like, there is going to be psychological challenges. There will be a psychological breakdown. It's going to happen. How do we help and provide the tools to the individuals so that they can manage it, so that they can go through it and know that they can come out stronger on the other side? I'm fortunate enough to work at the Mental Health Center of Denver, which is the largest mental health center in the Rocky Mountain region. and I'm the director of innovation, and we're looking at digital health and how that can help different people at a larger number of people. Our mission is slightly different. It's called, it's with access to care. However, the whole idea of what mental health is, how it manifests itself, how it how people can manage it on their own is something that we are trying to incorporate into developing and identifying that individual from the measurement side and also in alignment. And then also, what happens when there is a need to recalibrate on the mission? Not only your physical kind of like profile, but what about your psychological profile? If you have a situation where an individual has not necessarily had a breakdown, but had a challenge. We won't go all the way to a breakdown, or their relationship changes within the group and the crew. How do you start to recalibrate that to help them, one, manage themselves and also manage the relationship? All of us have friends, all of us are part of a family, and we know when two people in a group fight, everybody has to recalibrate their relationship to that situation. And that changes the alignment. That causes another stressor. So what we're trying to do is make sure we have the group that can work best together, still accommodating those challenges, but knowing that it's important that they face it and that they're given the tools and that they have the safety built into the group in order to do that. And then, of course, we do use artificial intelligence to create these profiles. And then how do you realign that profile once something has happened? So we also talk about nurturing, and that is self-awareness, making sure that individuals have the tools when they are feeling that their mental health is not, that their mental health is waning, that they feel that they need a break of some kind. We want to make sure that that they have been given the tools to understand themselves, and then they know how on their own in an autonomous way how to manage and recalibrate themselves and their mental health. Because the whole idea is once you identify the right individuals, the right team, it's still partly an individual responsibility to understand what's going on with themselves and not to shame them into thinking that, okay, this mental health thing, it's mental health, it's not mental illness. And I think that's another part of the conversation that we have to have when we send, because we are sending people. And people take a lot of management. You've heard from the health side, you've heard, where we're going, how we're getting there, but the whole idea around individual engagement and individual self-management is understanding and giving them the psychological space to heal and the psychological space to manage themselves, going back to the psychological safety, but understanding that there are things that they can do to maintain their health, and that when you have a mental health challenge, it is not mental illness. And that's just part of what we're trying to do and help people understand what that looks like and how we manage it. So the man part is measurement, alignment, and nurturing. Nurturing all the way around and making sure that the group and the crew are the best aligned crew so that they can do the other work, so that they can have the resilience to face those physical challenges that are coming up, that they can manage the stress and that they have a way to manage their own stress. This is also where we talk about self-awareness, using different tools to understand what those stressors are, how it's impacting them, and using that, say, oh, here's alert, you're not feeling your best today. This may happen from a stressor perspective, from a psychological perspective. If you notice in journals, so-and-so did not get along this week and everyone notices it. Well, check your physical health. How is that manifested? How is that impacted? But the whole idea is making the crew self-sufficient psychologically so that they can continue and have a successful mission. And if someone does have a psychological break, that we can catch them, we give them the tools. It's not the end, because especially if they're on long-term, a very deep, in our case right now, Mars being deep space mission, they can recover and still complete the mission in a safe way. And that's the thing, that human mind is one of those black boxes that we don't know, we can't control. And that's something that this whole, what we're talking about with Deep Space Predictive, is understanding the emotional impacts of the relationships and understanding how to manage those relationships as we go forward. And of course, when we talk about teams, diversity is the key to success. It's challenging, it's a little harder than most people think, because it's like, oh, we'll just bring diverse people together, but everyone has to recalibrate. I'm going to use that word a lot today. Everyone has to recalibrate how they relate to people when they're in a room with people that they usually don't work with, that they're not used to having a relationship with, having a deep relationship with. So it's really important that we take diversity, understand the challenges of diversity, but also know that it's well worth the level of effort that we're trying to create crew success. So that's going to help people, you know, the behavior that is engendered from a diverse crew is to make sure that we understand groupthink, we understand how those relationships are going to be challenging, and give people, again, the tools to make sure that they can handle the diversity. And with diversity comes challenges. People are getting their status quo challenged by someone else who may or may not look like them. Dora talked about the number of women coming into being astronauts. You're looking at the selection class of every class of the astronauts in the last few years have had more and more women. That's a thing. Now we're also talking about diversity, cultural ethnicity issue, or ethnicity diversity. And as we become more global, we're going to have crews that have cultural diversity that is so different than American on top of that. So all of this diversity, it's helpful, it works, but it's a challenge, and you have to give people the tools. And so Deep Space Predictive is looking at how do we give people the tools at every level of their relationship building for going on a mission. And the other part, as we do this, as you heard, I worked with an international research team. Our researchers are from France, they're from Scotland. Some are doing half-time in the US and Australia, different disciplines, very different cultures. Even getting our models together was a challenge because diversity is what it is, and you have to accept it and have patience for it. But the other part, as we go through and understand the impact of the tools that we're creating, is also understanding what our tools enable and where we're trying to go. We're all here for space. We're all here for understanding where we're really satiating humanity's curiosity. Because we can do things, we're going to do it. We're going to go to Mars because we can. We're going to make that happen. But the other part of it is we're going out with the hubris of ourselves as humans, as far as we know, the sole inhibitors of this universe that we have. And with that, it comes tough choices. How do we act? What is important as we go? How are those astronauts and crew members going to make decisions when it comes to being out in space in conditions that we have no idea, we've never been there? So we have to, what we have incorporated is space ethics. We've worked a lot with the ILS School of Theology and their artificial intelligence, making sure the tools that we use don't include any biases, that we train people to recognize those biases. We've worked with the Markula Center of Ethics, Technology Ethics, and also working with individuals at Cal Poly in space ethics. So it's really making sure that we have our own personal ethical tools and we build those ethical mindsets into our processes and working with different individuals. So it's really making sure that all of these pieces are brought into play in an ethical manner that manages and understands the the biases that exist as humans, because we are humans, but also not assuming that the technology is objective, because it's not. And so we have to give people that mindset and understanding as we develop them and prepare them for these missions. And Dora did a great job talking about the new space missions. As you heard, I work with Colorado Space Business Roundtable. So this new space, these new types of missions, we talked about, or Dora talked about 5 months from selection into going to flight. That's a whole new kind of training with novice individuals who may have had experiences, but some may not. We're getting a whole new workforce. She had a great slide, and Dora, one day I may have to use that slide because it's great about the workforce and what those astronauts are going to look like, how they're going to be trained. And again, it's the different types of missions. We're going to have an astronaut corps that will be as normalized as flight crews, sometime down the future. We're really developing this new space economy in low Earth orbit that's going to require a whole new group of people. And that's going to be a whole different kind of training that's going to be required. The risk management is very different between our new space economy and our deep space. So we're looking at the different mission types as far as crew cohesion. You don't have to get along for very long if your mission is only 3 or 4 days or a couple of weeks. 3 years, whole different mission. Which goes into our other part is, going into Mars and beyond. We were talking about our, when we started going into space, they were going for 3 or 4 days. You didn't have to get along. So, if you had Neil Armstrong and Buzz Aldrin going to Mars, they may not have made it given their different personality types and how long they have to survive. So we're really trying to find what is that magic algorithm that's going to help people survive, but also knowing and being aware it's like there's no computer model that can replicate the human experience. And what we're trying to do is help the humans do self-management, be autonomous, be self-aware so that they can manage themselves in order to be successful no matter how long the mission is. And we have these different models for different types of missions because that's critical. And the way that those individuals are chosen and put together is so vital to the success. So we're trying to balance technology and human experience and human knowledge and making sure that that is what's going to help us be successful. So that's the end. Thank you. I thought that was cute. So I just had to do it.
Thank you so much, Aliris. I'm really interested in high-performing teams, and so your discussion about the smallest unit, of measurement being the crew, especially with these short time frames, is really a new way for me to look at it. And you talked a little bit about how much that played into past crew making. Do you see opportunities to have the crew select each other in sort of an eHarmony Match.com kind of way as a result of your research?
Well, it's really a little bit, it is that we wouldn't let the crew do that because they're bringing in all their biases too, but we're kind of observing one of the tools that we use in our selection process. We use gaming because one, we're all gaming, but there are a lot of games that require cooperation because that's really how the one of the key aspects of a successful crew. How well do they cooperate? How well do they let different people lead when meeting? The individuals who are selected as astronauts are high achievers. This has been like, they know how to succeed. They know how to be successful. Question is, can they be successful in a group? Can they let someone else lead if they're not the leader? Are they okay with that? Can they take feedback that's not going to be taken personally? And the other thing is, so just to put that along, so those are the things that we look at in how different groups relate to each other in in one of these tests of using games. But the other thing is, the vehicles that are being built to go long distances, they're starting to be self-sufficient. So which means there's lots of time available. And if individuals are going to have a new experience, I saw that you had Frank White on earlier, and that overview effect, that's going to change people. That's going to cause them to be reflective. That's going to cause them to be, it could be a way that they are more open. And the overview effect is more of my place in humanity, humanity's place in space. But now I have all this time to reflect on my life. Has that life been good? Has that life been fruitful? Is there trauma that we don't know about that people haven't dealt with that may emerge in this space where they've had all this time now to reflect, all this downtime? And I know that's a big piece of, of research of what is going to allow the crew to relax. I saw the alcohol, talk. There's that, but it's, how do you know what is under there, and have you given them the tools to understand it, to not be ashamed of it, to move through it? Because that's my thing, is like, it's gonna happen. Move through, get through it, and you're going to be more resilient, you're going to be stronger. But people fear it so much, and so it's like stopping a sneeze. When you stop a sneeze, there's damage. People are going to be damaged from that, and we don't want that. That's that psychological safety. Can I tell you a secret? Are you going to hold my secret? Are you going to judge me if I tell you this? If we have those conversations that have been loosened up by, alcohol, or just having free time to reflect. So it's those things that I think are important, and a part of all the other things that have to happen in research and risk management is the emotional risk management. That's why I was like, are you emotionally intelligent? Can you handle different things? Is there trauma that you haven't addressed that is going to be reflected? So did that answer your question?
It did, and it reflected back a little bit on your comment about the difference between a mental health challenge and mental illness, which I thought was really insightful. Have there been yet, given the short times typically in these missions, have there been yet real effects suffered by astronauts from isolation, confinement, or conflict? Or did their selection and training so far adequately prepare them for the missions that they were on?
Most of our research has been from analog studies, especially the longer ones. And I mentioned earlier, is when you see people like coming out of Hera or coming out of high seas,
Yeah.
first thing they think about, I'm going to have 6 best friends. Yeah, no, you're not. You're going to be lucky if you like yourself coming out of that, just because they're just not prepared or thinking that that's going to be an issue. Their work is like, can I do the work? Are we going to be able to meet our schedule? And they know it a little bit, but it's more of, how do they handle it in real time? And it's just a challenge. It's not good or bad. It's just a challenge. And I think we're doing a lot of research, or there is a lot of research going on, in how do you help people manage through those interpersonal issues.
Thank you so much, Alira. It's great to have you on, and I'm excited to bring you back for the panel here. Briefly, before we begin the panel, I want to invite my colleague, Emily Mishler, to join us. She is CEO of Cultivated Group and an advisor to Foundation for the Future. Emily?
Hey, Lee, thank you so much for having me. I also loved that illustration of holding back a sneeze. It's definitely something we can all relate to. So it's a pleasure to meet you all and be here today. Lee, thank you so much for that quick introduction. As she mentioned, my name is Emily Mishler, and I am the founder and CEO of a group of impact-driven consulting companies called the Cultivated Group. Our background is in the intersection of corporate philanthropy and creative solutions for revolutionary ideas, and we are affiliated with the Foundation for the Future's philanthropic development arm. We've been so impressed with the incredible speakers we've had today at the Foundation for the Future's July 2021, which it's hard to believe it's already July, Conversations for the Future Thriving in Space, and are so grateful you're here with us. We're also inspired by the advancements of our speakers, allies, and the Foundation for the Future are making in building the future of space exploration. This future in space and beyond is being built one relationship, conversation, and connection at a time. Each month, the Foundation for the Future hosts Conversations for the Future to ensure that our future in space is easily accessible, economically fruitful, and secure from threat. Our immediate steps must begin at the ground level now. Conversations for the Future is a nonpartisan forum to explore the needs, solutions, and innovations around space infrastructure near Earth in this decade. In order to continue this momentum in building and contributing to this caliber of event, conversation, and community, we need your help. Join us in contributing to Conversations for the Future through a one-time donation and helping us cover the cost of the event. So our ask, help us, sorry, apparently there's some traffic out there. So our ask, help us in making space boring and accessible by donating to support the cost of Conversations for the Future, because the time is now and the world can't wait. If you have any questions, please don't hesitate to ask or reach out to any affiliate of the Foundation for the Future. Our contact information and a link to donate is available at the QR code on the screen and also available on our website, f4f.space. For those of you on the live call, I'll be happy to stick around and field any questions. For those of you on the live stream, please reach out via the Foundation's website, f4f.space, with any questions. Thank you so much for your time and attention. And now I'll turn it back over to Lee for our regularly scheduled programming.
Thank you so much, Emily. All right, and now for our panel, we're bringing back Jennifer Fogarty, Dorrit Donafiel, Aliris Allman, and we're also joined by Sarah Lynn Mark. And she is Dr. Sarah Lynn Mark is an expert on space medicine and a world-renowned leader in women's health. She's an endocrinologist, geriatrician, and women's health specialist. Excuse me. As president and CEO of Solomed Solutions, LLC, Dr. Mark has served as a medical and scientific policy advisor to the White House, NASA, Health and Human Services offices on women's health, Bill and Melinda Gates Strategic Investment Fund, and other organizations dedicated to improving health on Earth and in space. She is also the president of iGiant, the only nonprofit accelerating gendered innovation in the world. Dr. Mark holds 4 academic appointments, including at Yale and King's College London and the Center for Human and Aerospace Physiology. She is author of Stellar Medicine, A Journey Through the Universe of Women's Health, which chronicles her adventures with the space program and her journey across all 7 continents. She has published and delivered over 700 lectures and is a frequent health media expert. Dr. Mark has received numerous awards, including the NYU School of Medicine Alumni Leadership Award for her contributions to medicine, precision health, and emerging technologies. Dr. Mark is generously giving us a part of her vacation today. Sarah, thank you for being the seed for this wonderful panel group. I'm not sure that Sarah has made it on quite yet, but there are quite a few questions in the chat for all 3 of our prior speakers that I didn't get to ask. So I'm going to go ahead and launch into those. First for Dorrit, how is Trish projects on private space flights funded? I think this may have been answered, but you might address the whole group. By the participants, by the organization, or NASA?
Yeah, it's a great question. So it all comes down to money, right? How are you going to pay for the research? Who's going to pay for it? So this Inspiration 4 flight, we focused on high priority risks for NASA, and we used technologies that the agency is interested in themselves for Artemis missions and for deep space. So it's always, because we are NASA's institute, we're always keeping their best interests in mind. And so all along, as we were considering partnering with SpaceX and Inspiration 4, we kept them in the loop, and they were very supportive of us using our funding to support this research complement. We're not paying for the seats. Those are paid for by the individuals themselves. We couldn't afford them anyways. But we are funding the researchers who are actually collecting the data, as well as the database itself. Now, in the future, if there are going to be experiments that the participants themselves want to do, like I think for the upcoming Axiom flight, there is the Ramon Foundation from Israel is sponsoring the whole complement of research studies that the Israelis want to fly on that flight. So it really kind of is driven by the market. it's really quite interesting that it is kind of opportunities for us to get involved when there is a desire by the participants to engage in space research that is important for the agency.
Thank you. I do, because you may have to leave the panel early, I do want to ask one more question of you. And that's, you recently had a survey on your social media about what the topic of your TEDx talk should be of the various focuses that you had available. I'm curious how the vote went and why, if you've summarized the data.
Yeah, it's really kind of interesting. So for those of you who haven't seen my social media posts, and I hardly ever post surveys on social media, but I just didn't know what to do with this. Baylor College of Medicine is doing a TEDx, their very first TEDx event. And so they've very generously asked me to participate. And I wanted to say like the one big thing, right? So the one big thing could be space is an accelerated aging model. So by studying the human body in space, we are learning how, to prevent aging. The second option was space is sort of a condensed disease model, if you will. As I mentioned, an example in osteoporosis, it happens much, much quicker, over a 6-month mission, the equivalent of many years in a postmenopausal women. So, so you could study disease processes and kind of look for early biomarkers on Earth using the space as a model. So a way to prevent disease from progressing. And then the third possibility, which was a little less about what people called negatively, the people called those two things as like really depressing, which I don't blame them. Coming out of a pandemic, we're not quite out of it yet. The third option was space makes us evolve differently, right? As I mentioned, all the changes that occur, right? So we're a different kind of human when we're in space. We look slightly different. Our organs have shifted a little bit. Our eyeballs are different, our hearts are a different shape, all kinds of things are a little bit different. So it's almost like an evolutionary study. We used to not have opposable thumbs. So in space, those changes that occur may actually be an opportunity to study a different form of human. So people really like the third option. I thought that was very, very interesting because it was more hopeful rather than focused on aging or disease, which nobody likes to think about. So thanks for that question, though. It was really interesting.
Yeah, I thought that was a really interesting discussion and a good variety of responses in what I saw. Let's see. So a few questions for Jennifer. Do you collect keystroke dynamics data to get passive measurements of, I'm not sure it's for Jennifer. You guys can all jump in on this one. Get passive measurements of mood and cognition. And what about interstitial fluid measurements using microneedle patches?
I can start at the history, and then I think other folks can weigh in. There's definitely been work on looking at fine motor reaction time. Now the question of connecting them, I think Ilaire's talking about like what reflects mood. There's a lot of metadata that has to go into anything to interpret it when you're going to do some type of quantitative measurement and then have a qualitative feature associated with it to know how maybe they associate. There's been a lot of studies both on station and in the analogs to understand how someone's cognitive and emotional abilities are affecting their performance. And then you try to look for a very objective performance measure. So I think that we have databases, NASA has data. I'm newly out, so I still tend to draw back, and I think Dorit's waving goodbye. I do fall back into lingo, but there is quite a bit of data. Now you say, has any one experiment reached critical mass? I'll let Ilaire's maybe comment on the, have we been able to move forward with interpretation confidently with the work that's been done?
Thanks, Jennifer. There hasn't, with the focus being on performance outcomes and measuring performance versus what I'm looking for, your mood for performance and optimized performance versus mood for emotional management. There's same measure, different outcomes, or rather applications. And what we're doing is looking at mood for emotional connection, which eventually, emotion first, then performance, because it's all kind of intertwined. And what we're finding is it depends on what you're looking for as far as mood and as a stressor for performance. What we found is that yes, you can identify, mood as an impact to stressors and performances. What we look at is mood for emotional relationships, and what we're using to measure is a physical measure as well, is cardiovagal tone as a specific reflection of emotional state, so that an individual can self-manage their own emotions and how they're feeling so that they can perform better. So that's how we're looking at it. And there has been, a lot of research on the fact that mood obviously does impact, your actual performance, which is what most of the mission is looking for, is like, are you able to do your job so the vehicle can fly, so that it can be, taken care of, and you can do the task that you have been assigned.
Yeah, that makes me think of sort of the burnout epidemic that we seem to be having as a
Right.
result of COVID,
Yeah.
and that balance of, is it mood for mood's sake in a way, or is it mood for performance's sake? Yeah.
Well, it all gets down to performance eventually, because that's where the impact, but you want to manage that mood so that it's not an additional stressor to performance. I think that's kind of where we want to go. Jennifer?
Yeah, I agree. I mean, it was always about what component is actionable. There are things you can measure that are just indicative of a situation, a state, and then there are the things you can act upon. So in the case, I think, of the psychological state and the mood of the individual, if you can use a bio marker, to give them a heads up. So part of it is, did they see it coming? Before, we were talking about how well trained and high achieving these people are. And I will say, and this is my non-professional opinion, of you can block a lot of stuff out and damp it down for a while. And this is where we're always been concerned with the astronauts, that and in the group that worked in health and performance side, that was in charge of the whole portfolio of, if they don't, you can use these tools to help them be self-aware and then act upon it at early stages, rather than having to get it to a critical point where they do have a break or the team cohesion is just incredibly damaged from it. But yeah, I think the biomarkers can give a lot of insight into it. They can act upon it and then see it reflected back in good performance, and then keep those markers of stress, the bad kind of stress, down, and this has been an ongoing discussion, I have regularly with folks about trying to understand the role of stress or inflammation, but there's a biological need to have it. Like, you have to heal from things. Your body has to have its natural processes. But what are the signs that it's gotten out of control, or it's tipping? Where are the thresholds? That's been really challenging from a research perspective to find. I always imagined it as a dashboard, and I know there's been some other projects that have been put out there with similar terminology. But if for all your systems that we consider part of this thing of resilience, like, how do we maintain high function? What are the key components to measure? And of those, which are the actionable, or what action do you take when those dials start to go in a way that implies, you're going negative, or you're diminishing your capability? You got to refill that tank, whatever that means. And so emotional state has definitely been one of them. And there are different, I think, Alira's mentioned before, there are different ways. And it was always the discussion of, you can't expect no conflict, just like you can't expect no change. But you have to have those tools, as she mentioned, to manage it when it does occur, so that it is recoverable, whatever it is. So yeah, I think there's a lot of literature, a lot of research. Now it's, going back to the term I use, like comprehensive. How do you bring it together to start to create actual solutions? I always described it when in my job as chief scientist, like, I'm trying to put together this puzzle. I have all these pieces laid out on the table, and I have no edge pieces to give me that like framework. So like, you try to match pieces together, and that's kind of when you look at the portfolios that go into the analogs, such as HERA or High Seas, they're kind of stitching together different choices of solutions as well as still de novo building up. I've got some dogs that are going to go ballistic in about a second. They, stitching together different pieces, or still trying to understand that, to Leah's point, like everybody's so different and different on any given day. Having that crystal ball of, does it mean the same thing today as it did yesterday when you're getting like sympathetic tone or respiratory rate? Like, are they still key indicators of a negative outcome versus just your body adjusting? So we're working on all confidence behind those measurements as well.
Right. It's like, how do you reset your baseline?
Yeah.
That's one of the things where it's like the baseline is going to change. When is it changed significantly or whatever your measures are, that you can get what the real, a good picture of what's really happening.
Yeah. And we've, for an example of that in spaceflight, and this is where the interpretation gets a little away from us if you use the Earth normal baseline, but it was actually aerobic capacity, your ability to do workload at a certain heart rate with a certain gas exchange, oxygen intake and CO2 production. And mathematically, there's a relationship where after you establish someone's baseline, measuring a lot of the variables, including gas exchange, you say, okay, this kind of workload, met rate, wattage at this heart rate, gives us, mils per kilogram per minute. And we measure you against that. Well, then you go into space, but you lose 1.5 liters of fluid, almost immediately you have this huge diuresis, you get a shift to the upper body. I mean, physiologically, this whole dynamic, it doesn't mean that there isn't a relationship between gas consumption, heart rate, and workload. It's just different than it was on the ground. So you got to do some work to say, well, where is that new relationship or baseline so that I understand what a delta from there means. So that's the work of saying, when you put someone, and all the terminologies have been used, when you allow someone to adapt, in a lot of ways we should allow them to adapt. You don't want to completely interrupt the process. That can be just as damaging to the relationships and productivity, but you really should try to understand what that shift is and quantify it as much as you can. But humans, I can tell you, anytime you get into a room with engineers, no one likes to look at the standard deviations when you do human research. They're like, what is that? There's not these tight little, like your error bars are within your little symbol. No, I mean, we get wide variation. So it's been challenging given the number of people, the lack of diversity of populations that have gone, like the assumptions that have been made, to say, okay, we still have a lot of work ahead of us to get confident with these measurements, these actions, and then tools that can be applied, especially for critical missions when you're talking pushing people 3 years, in a small confined space, and the concept of a Mars landing in there.
And I want to add a little bit to that, is like the key word that you said there is engineers looking at this and the data, when, I'm coming from the psychologist perspective and the psychology, and is the one thing we know is humans have free will. And the minute you say go left, they're going to go right, sometimes to be spiteful. And we know what we can say. We tell them to go right, they go left, and we know why they went left, because we can have all these measurements, but that true underlying is like, because I don't want to. I mean, how do you account for that? And those are the things that we just have to be prepared for. And like you said, it's like, what are those countermeasures that we can give to them when those calculated assumptions are wrong? And how do you manage it and give them the tools to be resilient and understand the impact of that free will?
Yeah, the relationship with authority shifts the baseline.
Yeah.
Bless you. You didn't hold it back.
I didn't hold it back.
Yeah, I think that goes back to, we've learned a lot about the need, even on the International Space Station. A lot of work is shown, like in terms of the crew controlling their schedule versus it being controlled from the ground. The Russians have actually done quite a bit of documentation when the crew versus the mission control, and analogs have shown this too. They become an us and them relationship. So when you really are in a position, you've highly trained people and they know what they're doing, that the systems might be more beneficial. It's really hard for any one of the groups to give up that control, but it may be more beneficial to allow the crew, give them trust and have them operate more autonomously, so you don't get into this defiance mode of the ground, wherever that is, doesn't know what they're talking about. We're off in the mission. We can plan it better. But by concept, that's a true, like, we're trying to get there. Let them go, test it. And there are some activities that have happened on station, including what's called playbook, where when the crew is able to manage their own schedule, they can be incredibly productive versus feeling like they're chasing someone else's goal for them, and occasionally getting very frustrated with, if because you can borrow time, or you can give yourself, just like with the talks today, like, well, someone goes 5 minutes under, later someone will go 5 minutes over, and it kind of balances out. But if on a minute by minute, you're being evaluated minute by minute progress, you're like, how can I do this? Stress associated with that has been reported to be detrimental to the crew mood and the team cohesion, because then they're like, well, you failed us, or the team has to jump in and compensate. So it was like, give them a little bit more autonomy, let them manage themselves. They are smart people. That's why they've been selected to go. How does that play? But the unpredictability is what's disconcerting to a lot of folks involved. And I get it. There's some work to be done. Again, that word confidence, in how that's going to work out. You just repeated, do it, train like you fly. Let's see it happen. Let's try it. And if it proves itself out, then we can rely on it. But right now we're still in that struggle, just because if it goes wrong, the consequences are catastrophic in space flight. You have very little wiggle room there to be wrong in a lot of ways.
What about submarine data? You talk about not enough data on a lot of things. Have you
Sure.
looked at nuclear submarines and the long duration but strict hierarchy?
Sure.
What are some of the differences, and has there been exchange of information there?
Yeah, and I definitely, the human health and performance experts can weigh in. But yeah, submarine data has been, evaluated quite a bit and compared and used as an analog. And it is always a struggle. You say, well, it's relatively large numbers. It's relatively homogeneous, men, Caucasian men in their 20s for the majority of it, with a very, like, as you mentioned, a very strict hierarchy. Yeah, I think there's definitely stuff to have been learned out of there. Actually, the Navy has presented the data regularly at different forums, conferences, academic meetings, and they do acknowledge the rate of psychological emergencies driving evacuation, suicidal ideation, people not being able to cope, not having any tools to manage it. So yeah, I think there has been a lot to learn, but when you add up the differences, it's a guidance. I think it has directed a lot of our research in some ways, but it's not a direct learning and application. But it has I clearly been very relevant.
Great. There has been some interesting discussion in the chat about top 5 most vital steps, and Aliris is doing an amazing job of juggling this discussion and the chat. Would you share just a little bit about what you're typing there and the significance?
Sure. The question was from Inara about what are the top 5 things that are necessary to get humans to be multiplanetary. And while we tend, and just to give you the gist, we went there, and I do have a colleague on as well who's helping me, but Jason Bott. And the idea is, we all focus on the engineering and the vehicle and things like that. One of the things we focused on when I worked with 100-Year Starship is, the vehicle piece is almost easier than the societal and psychological piece because it's discrete. You fix it or you don't. Just as we talked about with the challenges with mental health and psychological and the psychosocial issues with the crew, the same thing has to be considered on a global scale. And that is, in order for us to become multiplanetary, you have to have the support of society. How do you get people aware and engaged in that level of effort? We talked about funding. We have to elect congressmen who believe in that kind of funding. We have to put that conversation on the table as not something so far out, but a complement to the problem solving we have on Earth, because what we learn from going into space gets applied here on Earth. Look at all the different technology transfers. all the medical, what's the word I'm looking for? Breakthroughs that we've had as a result of things we've learned in space, and we'll continue to do that. So it's convincing people that this is a worthwhile endeavor, and then following that is the science. We don't know where those technological leaps are going to happen, but they need to happen. We need to keep pushing forward someday. I mean, and I'm going to age myself a little bit here. You know, when I came out of high school, email did not exist. The internet did not exist. Coming up now, we have such thing, you know, the creative use of this technology has just exploded. So now when we talk about technology advances in propulsion, that has to happen. Artificial gravity is going to reduce many of the problems we have around health if we have that, because then, you know, we can focus on the other things that are issues in space. But finding those little pieces are going to make huge impacts. We just don't know when it's going to happen, how it's going to happen, and how long it's going to take to do that. So part of the science that needs to happen to make this endeavor grow. But I really think, you know, some of the issues that are going to come up is who gets to go, who decides who gets to go. When we send people to Mars, Jupiter, Titan, wherever we're going after Mars, it's like they're kind of gone. If we bring them back, understanding time is going to be important when we do this. But from a societal perspective, it's how come that country's going? Is this a global effort? What about indigenous people and how they feel in their relationship to space? There are so many questions and so many conversations to have. We have to have those in alignment with the science part to get that kind of support that's going to be necessary.
I'm so excited to hear tomorrow. There's a talk by a choreographer who was commissioned by NASA, and in coordination with his choreography, he included recorded interviews with indigenous peoples and their views of space. So I hope you'll be able to join us for that as well. I want to close. All of today's panels have been too short. We would like to keep it lively, but these are just time is flying too fast. I want to close out with a little bit different kind of question, and that you both will have some perspectives on, and that is sport in space. So the fitness, physical aspects, as well as the psychological, emotional aspects. Just sort of postulate on what that might look like and the impacts it could have.
I think physical activity is absolutely required. You know, it's for physical, psychological well-being. They're not mutually exclusive of each other. And again, keeping the body in touch with things it's going to need to do. Mm-hmm. You know, there are different types of emissions where it won't be required, but that proprioceptive feedback is inherently important for the nervous system, the cardiovascular system, the musculoskeletal system. When it lacks input, it starts to pull away. Your body is an amazingly energetically efficient machine. And if something is not demanded from it, it stops investing in it. But then suddenly we require it back, and we expect it to be able to respond immediately. And you're like, no, you got to reinvest in establishing it. So we don't, we always, I think, need to keep that those literal and figurative touch points in mind when humans are transiting. Now, I think there are many different ways to do it. And I think there's a lot of advantages to be on planetary surfaces to experience that stimuli differently that we're going to have to contend with. And some brains will be wired to have a lot of fun and play with it, and other brains will be wired and struggle with it. And, when you got to give people the opportunity and the grace to learn and explore those things, and not, dictate exactly how and what it's going to look like. But, for all of the years I evaluated data on the medical side and on the research side, in spite of not everyone enjoying exercise, everyone in space enjoyed their time being physical. I think it just gives you a sense of your body and where it is and how it functions and regulates. And it was a very tangible experience for them that sometimes they were lacking otherwise.
Thank you. Aliris?
And I would agree with that on the physical side, and think that it's twofold. It helps your body anyway, and then the actual competition and the engagement with others is vital. So you can also do that because we are in space. It's not like you're going to have a football game up there. You can't follow fantasy football if that's your thing, because servers aren't going to travel. But you have to look at entertainment and sport in a different way. So now we have esports, which is keeping the mind active and keeping the mind sharp, because you're always solving puzzles when you game. So esports is another thing of keeping people engaged, keeping up their fine motor skills as well as their large motor skills with physical activity. So I think esports will be a big part of how people engage, how they can relate. Like I said, we use gaming as a part of our assessment process in relationships, and I think that'll continue on. I personally love gaming, and I also love being physical, doing cycling outside and things like that. So we're going to find a balance and an opportunity to use technology to create new and interesting sports.
Yeah, that's a good addition, because that was one of the more robust areas where you can really see the blending of virtual reality and augmented reality to reach another level with the physical activity, whether it be engagement with something you miss, like the sights of home and a running trail or a cycling trail, because you could be on a machine that replicates emotion, but then your mind has to be able to go somewhere, in terms of, I'm not stuck in this tin can 24/7 for not a couple thousand days or whatever it's going to be. So yeah, blending the two. But I think your point about competition could definitely be engineered and give people motivation, and add that entertainment and fun and dynamic exposure to stimulus, because I think that's definitely been shown, like with Antarctic folks. I mean, their brain changes due to like sensory deprivation, essentially. So we need to provide healthy exposures to a variety of stimuli, and it won't be because they can get out of the cabin and go for a walk. So we're going to have to make it.
Exactly. And if you look at, speculative science fiction and movies are great foreshadowers of what's coming. And I don't know if everyone saw Ad Astra, which is basically what I see as deep space predictive in real life or, fictional life, but they had that big room where Brad Pitt went in to readjust his emotional state, and it was all like nature is one of those scenes, and environments that calms us and grounds us as humans. And so it's just this big room with all those images as a place to go, which is virtual reality and augmented reality in that experience.
Amazing. I really appreciate your perspectives and your expertise. Thank you for your generous donation of time today, and just watching the chat go by at a mile a minute. Certainly people will want to be interacting going forward. Feel free, everyone, to share your LinkedIn profiles, and hopefully there'll be many conversations that branch out like a beautiful tree as a result of this discussion. Thank you so much.
Thank you. Appreciate the opportunity.
Thank you. Same here.
All right, our last speaker of the day is our student spotlight. Claire Lau is a high school student who is interested in pursuing a future career in space and aviation. She was introduced to space debris through her participation as an intern and a student ambassador of the Colorado Space Business Roundtable, and her passion for the issue allowed her to become involved in a number of related events and projects. Additionally, Claire is a figure skating coach, the general manager of a tutoring nonprofit, and the executive director of a charity music organization. She loves to read and perform, enjoys spreading her passions and knowledge to her students, and strives to help kids reach their personal bests. She also hopes to study aerospace engineering at the Air Force Academy. Claire, welcome.
Thank you, Lee, for the introduction. I'm gonna
share my screen real quick.
You have a little bit of background noise. Might try to
One second.
either speak just a little closer to the mic, speak up a little bit. Yeah.
Is that better?
A little bit. That's much better.
Okay.
Yeah. You've identified the
Okay.
Your slides are visible to us.
Perfect. Okay, so thank you again for the introduction. As Lee said, my name is Claire, and my interest in space debris began as a CSVR intern and student ambassador. But as a child, I was just drawn to space and its mysteries by the thought of the possibility of having more habitable planets in space that we haven't discovered yet. And I'm honored to have the opportunity to get involved in this industry as a student and to speak here today. So Lee did mention a lot of my other interests and extracurriculars, including teaching cultural dance and coaching figure skating and competing in speech and debate. But amidst a very great variety of interests, I do find that the issue I'll speak of today is very important for us to all continuously consider, especially in this technological lifestyle that we have today. Okay, so humans have always been breaking the barriers in exploration, and now more than ever, as you all know, we are undertaking the most exciting and challenging exploration of all time, which is that of space. But rather ironically, we may be stopping ourselves from going to space the more that we do it. It is incredibly difficult to launch anything into space, and it's even harder to get an item back down. These things have the ability to continue their path in low Earth orbit for centuries before air resistance is able to slow them far enough or enough to fall back through Earth's atmosphere, which is excellent for some of the items that we do need to stay in Earth's orbit, such as the International Space Station. But like every double-edged sword, this is also the source of the threat to the end of the space age, because decades of space travel have created thousands of pieces of debris, turning Earth's orbit into a junkyard. So today I'll be talking a little bit about what space debris is and active removal of space debris. Just to get a formal definition in here, space debris is all non-functioning human-made objects in Earth's orbit, and items can range from empty fuel tanks to broken satellites, scraps of debris from missile tests and explosions, or tools that astronauts accidentally left in space. There are currently about 2,600 defunct satellites, 10,000 pieces of debris greater than a monitor, 20,000 pieces as large as an apple, 500,000 pieces the size of a marble, and at least 100 million more parts that are so small that they can't be tracked. But these objects are all traveling at a speed of about 30,000 kilometers per hour, which is up to 14 times the speed of a bullet. And this is really what makes debris so dangerous, because even a pea-sized piece of debris can crash straight through solid metal and destroy functioning spacecraft. So unfortunately, the threat and effect of collisions may continue to grow worse with every space mission. And eventually this can really threaten both our future space exploration and our current usage of technology, which relies very heavily on current connections in space. So now that it is clear that space debris is becoming an increasing problem, we do need to consider ways to actively remove the debris. So with help from mentors at Astroscale and CSVR, I conducted a very brief research regarding the potential success of 3 unique proposed technological designs in removing debris. The general idea of all of these methods is the same, where deorbiting spacecraft lugs the debris to a lower orbit, where then the debris falls and hopefully burns in the Earth's atmosphere or it drops into the ocean. However, all 3 of these 3 designs were chosen specifically because they are very different in terms of its base technological design. So the first method that I looked at was the robotics arm method of removal. This is where a robotic arm on a chaser spacecraft is used to capture the debris, and then it's reconnected with the chaser, and then the entire system deorbits together. Very similarly, a method that was considered hand in hand was the tether net method.
And it's very similar in concept, only that a net is used to capture the debris instead of a robotic arm. And the specific differences between the two include the reach and positioning that is required to capture the debris, which does seem to technologically put the net at an advantage due to a greater reach and a smaller precision needed in capturing the debris. And then the second method I looked at was the electrodynamic debris eliminator, or EDI. This is a propellantless device, so it rides Earth's electromagnetic field and captures debris with a net, which is also very similar to the tether net method. It stretches about a mile long in space and is powered with solar panels. And when the debris is captured, the EDI is able to ride on its own to a lower orbit on the Earth's electromagnetic field. And then the net is cut off and drops into Earth's atmosphere. The main advantage that we can see from the EDI is that it could possibly remove multiple pieces of debris in one mission and have further uses beyond just removing debris while it is in space. And then finally, I looked at the ion beam shepherd, or IBS method. It is contactless, so it deorbits debris by exerting a force through its propulsion system to the debris. Of course, there does have to be a second force exerted in the opposite direction to keep the IBS from drifting away, which does seem to make it a little less efficient than the other two, just because it does use more energy to keep the IBS stable. This method also does require a lot of calculations and precision, with very small variations affecting the overall success. And it works best on satellites or debris with a circular orbit, so that does limit this method a little bit. So all in all, there is a lot more to each of these methods than what I just mentioned, which can definitely be examined for deeper consideration. In a very brief analysis, it seems that the best method out of these three is the EDI, because the net method of capture does not require the EDI to get as close to the debris or have as accurate of a lap to the debris as a robotic arm system would need, which is something that is very significant to consider when we're looking at different sizes and shapes of debris. It doesn't have the loss in efficiency or the same level of accurate calculation that the IBS method does require. And finally, could be possibly used more than once in a single mission to deorbit multiple pieces of debris, as well as used in other missions while it is in space, such as satellite repair. As I mentioned, this project can be significantly expanded using models, simulations, and data to support the conclusions that I made today and determine the specific mathematical and technological advantages in each of these methods. And additionally, other considerations, including economic and political complications, can be included to further this investigation and gain a more holistic view of which one of these three, or you could say 4 methods, is most practical for us to use today and develop. But my greatest message today is that we do need to be thinking about the future and sustainability in space, whether it be removing debris or planning for new missions. I'm currently also working on developing a program to simulate the trajectory of all objects in space, including debris. And the end goal is to create something that can be used in a variety of departments in industry. For example, marketing and communications teams could use this application to inform the public about the danger of space debris. And business teams could possibly use this in customer demonstrations, and engineering teams could use it to understand the environment more around specific spacecraft and debris and plan for future projects or collisions. Ultimately, this is a topic that should be receiving great international attention. But outside the professional space community, there is a limited population who is both aware of and cares about the space debris and the active removal issue. So I'm here to help spread the word. This is a national problem where professionals in many different fields can begin and continue developing solutions in specific areas, whether that be technological, economic, political, or legal. This is an international issue where we need to look at collaboration between space agencies and across countries. And like any other global problem, this solution will gain momentum with local efforts. So I encourage you to spread the word about this issue and let more people outside the space industry know about this problem. Let them know that there is a risk of losing instant communication, the ability to call a friend on a whim or immediately Google the term space debris after listening to my speech. There is a risk of losing the ability to use credit cards and banking systems because they use the GPS timing signal, and there is a risk of our space adventures and dreams ending before they truly take off. So I've split the issue to you. Now it's your turn. Thank you.
Terrific job, Claire. Thank you so much. You mentioned Astroscale, and publicly, the things that they're talking about are the focus of the robotic arm. So your work was affiliated with them. Are they investigating these other opportunities as well?
So I don't think they are specifically investigating these other opportunities. I know they, like, for example, the Eddy is from a very specific company, but they were able to help me in my research and understanding more about what space debris is and how I can go about my research, as well as giving me the opportunity to work with them in the programming project that I mentioned as well.
Great, great. This question's a little off topic, but you're just getting started in your passion for space, in your career overall, and you're already lifting others who are coming behind you. So younger folks, my son participated in your music talent show. You've got your tutoring business. Tell me about why you're driven by that, helping others already when you're so young yourself.
Yeah, so I've always had a great passion for leadership and service. And I think that really started as a figure skater, where I received a lot of help myself, and eventually grew into that coach position. So as you mentioned earlier, I think I have a lot of coaching and teaching positions. And I just really enjoy watching others find a new passion. And I think it is, as a coach and a teacher or a manager, it's my responsibility to help others in a student position to grow into someone that they want to be in terms of that specific area. So as a figure skating coach, my responsibility is not only to teach the figure skating skills, but also to develop a new passion for figure skating and to pass on my kind of leadership and willingness to help others to them as well. And I think that's part of teaching sportsmanship as well. And that follows along with my music program, tutoring programs, and space as well. And so I aspire to be a leader and to serve my community. And that's also why I want to attend a military service academy as well.
And as a musician and a skating coach, can you talk about the importance of artistic expression and space? So you heard from our prior speakers about sport and exercise, and the psychological benefits as well as physical. You just, with your experience, talk about how much those enrich your life and how you might apply that to space.
Yeah, so I think first is that space is a very unknown place, and for engineers or for other people who want to go to space, to explore space, the first and foremost attribute that they need to carry is creativity, to think outside of the box. And I think that's something that artistic thinkers can really bring to the table, especially in combination with engineering and scientific thoughts. And I also think in combination with something that was in the previous presentation is that continuous artistic thinking can bring a lot of enjoyment and differences in culture within space or on Earth that can really enrich the life of an astronaut in space.
Thank you so much. Tim, did you have a question for Claire? I see you're on.
Mine was just which service academy, the right one or the Naval Academy?
If you mean by the right one, West Point. I was thinking first the Air Force. I do live in Colorado, so I've grown up next to the Air Force, but it depends on which academy accepts me, right? So, yeah.
None accepted me. So kudos to you for the work you're putting in to develop your application there and lift up the people coming behind you like you're talking about. You would be a great fit for, as you said, any of the service academies that let you in.
All right. Well, that was very impressive, Claire. Really appreciate you taking the time to rejigger your presentation and make it a little longer for us so that we could really enjoy that. Sounds like Dallas Beanhoff offers a little bit of advice. Be sure to accept any help offered in your application process. So any of the folks that you see on this call, you can grab them on LinkedIn. Lots of people with some influence who can help you understand the process. All right, and we look forward, of course, to seeing what you'll do in the future. Everyone, this marks the end of our talks for today's Conversations for the Future. We appreciate your interest in these fascinating and impactful topics. Foundation for the Future is a nonprofit that relies on your support to put on this event. As you reflect on what you've learned today and the new ideas you have to think about as you're going about your daily activities, please consider supporting our efforts by sponsoring our next event at registration or by making a donation on our website. Today was a great day to learn about health, food, plants, alcohol, and the joys and challenges of human life in space. We're grateful for the generosity and expertise of our speakers. And tomorrow we'll be back and we'll talk about space habitats, space-related dance, and storytelling. I look forward to seeing you there. I'm Lee Steinke with Foundation for the Future, and we'll see you tomorrow for more Conversations for the Future. Thank you.
Thank you.